Hey guys, welcome to this live session by Intellipaat. And in this session, we're going to look into data science with Python. We'll learn from the most basic part of understanding what is data science in Python and till the most advanced parts where we'll be creating a project with them. And before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now, before moving on with this live session, let's take a quick glance at the agenda. We'll start off with the introduction to data science. What is data science? Why do you need data science? What are the use cases of data science? And much more things to learn about data science. Then we'll move on to the introduction of Python. So Python programming language, why do you need it? Where can it be used? And basically we'll understand all the key concepts in Python. Once that is done, we'll basically understand Python for data science, because that is the main concept of this particular live. We'll understand why should you use Python especially for data science. After that, we'll move on to the introduction to artificial intelligence and machine learning, because AI and ML are subsets of data science. After all of this, we'll be looking into data extraction using Python. So we'll be understanding how to extract data from various sources using the Python programming language. Once we are done with all of these theory concepts, we'll move on to the hands-ons and projects to make you understand the subject even better. So we'll start off with how to import and analyze data sets. Once that is done, we'll move on to a data manipulation project using Python, and in Python we are going to use the Pandas library. After that, we'll look into matplotlib, where we'll be using matplotlib to visualize underlying data. Moving ahead, we'll be looking into machine learning using scikit-learn. Once that is done, we'll be learning how to create a chatbot using Python. So once we've completed all of these hands-ons and projects, we'll be looking into the interview questions on data science and Python, and that would be the end of this live session. So guys, without any further delays, let's begin with this session.
Hello everyone. Let's get started. What you are already experiencing in the field of data science. All right, all of us in some form or shape in the current day have been experiencing data science in a lot of ways. Right. Take for example YouTube. Right. But the moment you watch a YouTube video, the moment you see relevant video content that is available right next to it, right next to the video that you already watched, and a lot of days you probably wouldn't even realize that a video like that actually existed if not for YouTube actually pushing YouTube actually recommending that to you. Similarly, Netflix or let's say any streaming platform, whenever you watch a video, similar content is always pushed for you to, or recommended by that particular platform, so that you get to watch the content that you really like. That is in a lot of ways what data science really is, right? Also, take the example of sports, right? Take the example of let's say English Premier League teams, or let's say take the example of the Indian Premier League cricket team auctions that typically happen. There's a lot of analytics that goes into how teams are decided, which player is decided at what position, and if the particular team needs to go for that particular player or not. While they're bidding their auction, what should be the maximum cap beyond which the teams actually shouldn't bid for a particular player. So all that, a lot of analytics actually goes in, a lot of intelligence goes into who should be playing a particular game and what position should a particular person be playing, and things like that. So if you think of it, there's a lot of analytics and intelligence that is baked into sports as well today. More importantly, we were recently working with a diamond mining company in Botswana, and that particular company apparently contributes to almost 30 to 40% of Botswana's GDP. And imagine we were working in that particular location, trying to build systems that could automatically identify if a particular machine is likely to fail in the diamond mining site. Imagine if a particular equipment goes down in the middle of the complete mining exercise. Imagine the kind of challenges that the mining company goes through. Every hour they keep losing money if the equipment actually doesn't work, right? So imagine um, when an equipment goes down, and in remote areas, especially mines are always in remote areas, imagine how difficult it would be to send out, let's say, a service personnel after the event actually occurs. But if we could make use of some information, some historical data, and then predict if a machine is likely to go down, then even before the machine really goes down, you could send a service personnel out to actually rectify the issue, which would save a lot of time, b a lot of money, more importantly, right? That is called predictive maintenance, and that's a big application of the field of data science. You name a field and there are numerous applications of the field of data science. um, one of the most recent additions into this particular thing is, take for example, the game of Pac-Man. Right, Pac-Man is a game we've been playing since a very long time. And all of us as kids, when we used to play the game of Pac-Man, it's a very simple, silly game. But then the reason why it is so intriguing and interesting is because as the game progresses, it keeps getting faster, and there's these monsters that try to eat you away. But then that's the nature of the game. But imagine if you can build an intelligent system that could automatically play by itself or learn as it goes along, right? Or playing a game of chess against the computer, and imagine if you can build an algorithm, or if you can build an intelligent system that could automatically play chess against the computer, and it could beat the opponent, let's say, right? So these are some cool and very interesting applications of the field of data science. Self-driving cars, right? Or driverless cars, let's put it that way. What Tesla has done is just phenomenal, right? And actually bringing it into the consumer world, while all of this driverless and self-driving cars as a fad is awesome, but imagine bringing that actually into the consumer world. A driver sits in the car and then actually takes the hands off the steering wheel, and the car takes control of how to drive through the how to drive through the streets. So the point is, what is data science? When we say what data science, if you look at one common element across all these aspects that we just spoke about, the commonality is intelligent systems, right? Building those intelligent systems. Now, the question is, how do you build these intelligent systems? When you say intelligent systems, what do we actually mean by it? The definition of an intelligent system is something as silly as, if the machine itself has the ability to make a decision by itself. The machine itself has the capability, has learned so much over a period of time, that it has the capability to start making decisions by itself. That is what is typically referred to as a that is what is typically referred to as an intelligent system. Clothes, or let's say how a robot were supposed to, let's say, clean your house. But today there are systems that can automatically understand, based on the type of the cloth, based on the amount of volume that you have. The washing machines are now smart enough to automatically adjust the spinning rate, the amount of water they use. Take the example of Uber, the Uber app. When you make an Uber booking, even before you actually make the booking, you're given an estimate of what would be the price of that particular trip. Now, how does Uber make that decision? Right? There's so much that goes into actually identifying how much price should Uber actually charge you even before you take the trip. Think about it. So what Uber has been able to do, they've been able to build an intelligent system that automatically predicts what the price of this particular trip is likely to be, based on your start point, your end point, the weather, the number of people who are traveling, the kind of cab that you've booked, and the location that you're in, this if there is a high demand or not, and thousand other elements, right? And the traffic in that particular location, and thousand other factors go into actually identifying the price of that particular trip. If the system is not that intelligent, and if it predicts way too high, then as a user I would be super disappointed, because I know that I would be spending very less. I would not be making a booking because it would be too expensive. On the other hand, if the machine predicts very low, then Uber is going to run into losses, right? So imagine how precise that particular intelligence has to be, right? So what we're essentially saying here is, when I say data science is basically a field that is sort of responsible for building these intelligent systems. The more and more systems become intelligent, the more and more smartness you start baking into these systems. Uh, what that does is it gets rid of firstly a lot of unnecessary decision making that we personally do. or it gets rid of a lot of unnecessary overhead in terms of having additional people in trying to make those decisions. I'll tell you a simple example, another very simple example. We were working at a bottling unit of a very popular cola brand. This cola, when they get filled almost at a rate of 600 bottles a minute to 1,000 bottles a minute, right? So the machine runs at extreme pace, and when you think of these bottles actually go through a conveyor belt, and every time if the bottle was incorrectly filled or if the crown was incorrectly placed, there was a system that was in place which automatically pushes the bottle down into a gutter. Even before that, 5 years earlier, that this is the situation right now, but earlier to that, what happened was they used to make a person sit there and manually look at bottles that were incorrectly filled. So the guy used to sit there and he used to actually look at the person used to actually look if the bottle was properly filled or not, and if it wasn't filled, he would manually pick it up and push and set it aside. Humans are likely to make errors. We're not saying machines don't make errors, but what we're essentially saying is these are mundane tasks. These are tasks which have extreme cognitive load, and these can be handed off to machines, right? So with a little more error, it's okay to hand it off to machines. Because I can make use of that manpower elsewhere. Secondly, because I can reduce costs, right? Companies would want to reduce costs, right? So the question is, there's a lot for companies in doing this. There's a lot in place for companies to do something like this, to actually embrace data science, right? So we'll talk about more and more examples as we go along, but the crux of data science or the end goal of data science is to build these super cool intelligent systems that have the capability of making decisions all by themselves, right? So to more formally describe data science and the field of data science is a process of finding hidden patterns from raw or unstructured data. Now let's try and understand this statement a little better. So when we say extracting patterns from hidden data, what we are saying here, firstly, the field of data science is not new to us, right? The field of data science has been there is almost a century old. It all started with statistics, right? Long, long ago, once upon a time, there lived a man called P.C. Malnobis, a very popular Indian statistician, mathematician, who believed that statistics could actually be made use in the field of in the industry. Um, Basically, applied mathematics or applied statistics could actually be made use in industry to actually benefit the industry in doing a lot of complex analysis. How do they make use of how does the industry want to make use of something like this? So think of it this way: if a milk supplement brand, let's take the example, right? If a milk supplement brand um, claimed that if you drink our let's take the example of, let's say, Horlicks, or Horlicks is a popular Indian milk supplement brand, milk powder, basically milk supplement powder that is generally given to kids. Horlicks claims that every time you drink Horlicks, or basically GlaxoSmithKline, that's the company that owns Horlicks. GSK claims that you drink Horlicks, you get sharper, taller, whatever. You grow taller. That's what they claim. But they just cannot make these statements right out of the blue, right? They just cannot randomly say, if you drink Horlicks, you're going to get taller. Then I'm going to say that if you talk to me, you're going to get smarter, right? Companies, especially with that reputation, cannot make such claims just out of the blue, right? There has to be some analysis that goes into it. There has to be some kind of numbers that back this whole thing. So what do they do? So what they do is and this is what is actually happening over a period of time. So let me quickly show you what they actually do. Let's do some quick whiteboarding on this, right? So what these companies basically do is they basically identify a group of they basically identify a group of 5 to 10 people. Just give me a second. They basically identify a group of 20 people, 10 people here and another 10 people, or let's take this as 100 students, 100 kids, right? Two groups, group 1 and group 2. This group is simply given milk, and this group is given, let's say, milk plus, let's say, Horlicks, and these two groups basically do exactly what each other do. I mean, if the group one does cycling, group two also does cycling. If group one eats certain kind of diet, group two also eats certain kind of diet. Everything is basically the same between group one and group two. It's just that the only difference between these two groups, to the extent possible, of course, it's not possible to control everything, but the only major difference between group one and group two is, of course, the fact that they drink Horlicks. Group two drinks Horlicks, group one doesn't drink Horlicks. They only have milk, plain milk. So now what you do is now you go ahead and you conduct a simple experiment. So you monitor these groups for, let's say, a span of, let's say, 6 months. You monitor the groups for 6 months, and after a period of time, let's say you then again capture the growth rates of group A and group B, or group one and group two. You capture the growth rates. When I say growth rates, capture how many centimeters has each kid in group one and group two has grown. And after that, let's say you compute some kind of an average. Let's say the average growth of group one is, let's say, 2.5 centimeters, while group two people, is, let's say, 2.7 centimeters, right? Group one, the average height growth in height is 2.5 centimeters, and group two, who is having milk and Horlicks, the average height is, let's say, 2.7 centimeters. Now, just because you see 2.5 and 2.7, and because this number is larger, can we simply go ahead and claim that group two has a higher growth rate than group one? Absolutely no. Just if tests were conducted like that, trust me, we would probably have been taking a lot of unnecessary drugs today, and a lot of false drugs would be available outside in the market, which probably are not really that effective. To really identify if your Horlicks is good or not, right? There has to be something more than just that. I'll tell you why, right? Though the growth rate in group B is actually higher than 2.5 centimeters, is actually more than group A, it could have so happened that there was some guy in group B who was probably a close relative of Usain Bolt, or let's say a close relative of the world's tallest person, and that guy just grew tall. I mean, that's a genetic thing. Or maybe there was two people in group B, or maybe there were two people in group A who actually did not do any kind of physical activity throughout the whole thing. The point that I'm trying to drive is that difference from 2.5 to 2.7 could be out of absolute randomness, right? So to perform more to perform a more complete analysis on if group B is actually better than group A or not, we we basically make use of a field called as statistics to identify if group A is better than group B, or group B is better than group A. Essentially saying, is Horlicks better than, let's say, plain milk or not? So that's where statistics comes into picture, right? Statistics has been like the most important pillar of how people have been analyzing data. Remember, we haven't done anything out of the world over here. We've just collected some data. Some we've observed something happen. We've collected that data, and then we've simply analyzed that data, right? And that is exactly what statistics is all about. Statistics is a field where you aggregate numbers, you try to draw inferences out of numbers, right? You look at some numbers and you try to draw inferences out of it. You perform some analysis on a small sample, and then you try and identify if this is actually correct or not. Extrapolate this to larger problems, like, let's say there is a beer manufacturing company, right? A beer brewing company. You don't call it manufacturing, call it beer brewing company. And the beer brewing company wants to identify if um, a particular batch of beer is, if it's of the highest quality or not. Or take, for example, a pharmaceutical company which wants to identify if a particular vaccine. Take the example of coronavirus, right? It's all over the place today, right? Especially in our side of the world. So what you do is you simply try and identify if that particular vaccine, if it is actually better than the existing vaccines or not. So you do some kind of trials and you collect data and you try and identify if the vaccine is actually helping out or not. All of that analysis is fueled and powered by a sim and a very, 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 very important field of mathematics called as statistics. That's the core and the fundamental pillar of any kind of analysis that people have been doing. And remember, statistics has been there for a few hundred years now. It's more than a century old, if we were to say, right? So the fact is that the stepping stone of data science, which is statistics, which is basically the art of analyzing data, analyzing historical data, has been, or this seed has been sown almost a century ago, right? And people have been practicing that field over and over, right? What people have realized is, as time progressed, in the mid 1950s, 1960s, when computers started to come in, right? People started to realize there were computers, and people started to build these abacuses, and computer algorithms started to come in. Computers did not become a household thing only until, let's say, 1980s, so to say, but computers did exist in the mid 1950s and 1960s. A man by name Samuel Arthur, he came up with an interesting concept. He said, while statistics is a field where there was a lot of analysis that was being done by pen and paper, but why don't we actually make computers do it? Why don't we make computer algorithms which would automatically extract hidden patterns from data? Instead of actually us doing this analysis manually, why can we not write simple computer programs that can automatically extract patterns? So that is where the field of mathematics, that is statistics, and computer science started to amalgamate. They started to come together. And that field where computer science and statistics came together, right, was basically referred to as machine learning. A new field took birth, right? Machine learning it sounds cool. Basically, the concept is the term basically says you're building a machine that can automatically learn, or that can automatically extract patterns, right? That is what machine learning was all about. Time progressed, machine learning evolved. In 1980s, as as people started to realize, people started to collect more and more volume of data, problems also started to become more and more complex. 1980s, a man by the name Geoffrey Hinton uh, then realized that while machine learning is a computer algorithm that automatically tries to extract hidden patterns, this man, Geoffrey Hinton was one of the many scientists. He's not the only father, but of course he's one of the popular ones. He was intrigued by how human brain worked. This man was intrigued by how intelligent human brain was. Of course, there's a lot of analysis that was going into the neurological space, neurosciences. But this man was intrigued by computers and human brain. So he wanted to build systems. He wanted to build computer science algorithms that would ape how a human brain was. That basically was the stepping stone. So he wanted to build systems that would act like the human brains, or that could basically try to ape like human brains, right? So for example, when you see a particular object, imagine how your eye captures information and how your brain processes that information. When you look at a human being for the first time, your eye captures, there is a sensor, basically your eyes are sensors that capture this information, and there's a part of the brain that stores that information. And there's another part, the next time you see that particular person, the same person, probably he might be wearing a completely different dress, but you still remember that same person, because there are certain elements of that particular person's face that your mind is capturing. And the point is, uh, and the point of course is that this particular man believed that we could build systems that could automatically um, that could act like human brains, and that system was called as basically neural networks, right? This is basically a sub part of machine learning. If I were to say, machine learning is like the larger is like the larger piece. They wanted to build computer algorithms that would act like neural networks. This is in 1980s. 1990s and 1920s, people became more and more intrigued by this idea of neural networks, and they started to build more and more complex algorithms, more and more interesting algorithms that could identify faces, that could identify text, that could do some really cool stuff with text, and that could, today modern day systems have the ability to write text by themselves, right? Or you pass a color photograph, to pass a black and white photograph to a particular algorithm, and it would basically do all the color corrections and add color to that particular photograph as well automatically. Now, the point is that this is basically the evolution of the field, and one of the latest inclusions in this is called as deep learning. When I say latest, I'm talking about 15 years old, right? Um, Deep learning is one of the latest inclusions in this particular field, and the cool thing is there are more and more complex algorithms coming in this field almost on a daily basis. There's so much that's happening, right? So the point is that data science is, now if I were to point a finger and say this is data science, all that you see on your screen is data science, right? There's so much that actually goes into data science, right? So there is statistics, there's machine learning, there's neural networks, and there is a completely different side of it where you have to learn computer programming. And if I were to kind of put this in a simple representation, this is what data science is all about, right? What you have here is, just a second, what you have here is the most important piece, which is statistics. The other side, which is the algorithms and machine learning. You have statistics and you have machine learning on one side. And along with these two together, you have one more very, very important aspect, which is, let's say, your data analysis, which is the ability to perform some quick data processing and do some kind of quick data manipulations. So you've got to understand how to work with this data as well. All of this put together is what data science is. So the point is that data science is not just about learning one side of the whole story. So if by now you would have understood that data science is not a tool, data science is not a programming language. There's a reason it's called science. It's a field of science. It's a field of science that basically performs, that is tied very, very closely to pattern extraction. And if you're someone who really likes pattern extraction, if you're somebody who really likes extracting very, very interesting patterns from for businesses, like for example, people who use 1 GB of data and let's say belong to a particular locality are most likely to churn out from a particular telecom company. Extracting these patterns and then building complex algorithms that can automatically make these decisions on the fly is what data science is all about, right? So the other cool thing why data science really shot to fame over the last 10 years is because less 10 15 years is because of the presence of data. Hardware became cheaper. Our company started to store large volumes of data. I still remember and I'm a millennial, but imagine if and I remember let's say my first computer actually having 256 MB RAM, and people would be laughing at me if somebody who's probably born before me, right? They would probably even remember systems that had let's say 256 KB of RAM and things like that, right? So they were dealing with KBs long ago. But then the point is that storage became cheaper, hardware became cheaper. People started to store more and more data, and machines became cheaper, which meant that we were now able to afford machines with larger amount of RAMs, which means that I can actually crunch all of that data and generate and process all of that data and extract patterns from it. Of course, you cannot do it with pen and paper. Of course, you cannot do it with Excel. You need more complex tools. That's exactly where the tools come into picture. And the tools are like, let's say, your Python, your R, and a lot of other tools come into picture. And those tools really help us in performing complex data analysis, right? So if somebody asks me what is data science is the field where of pattern extraction. How do you perform data science? Well, there are numerous ways of performing data science. One of the most popular ways of performing data science or performing data science analysis is via, let's say, tools like Python, via R, or there are a ton of other Spark, right? TensorFlow, and so on and so forth. So there are a ton of other tools that are available outside in the market today, which have grown in popularity over a period of time. And I'll talk about that also in a few minutes. But net, this is what data science is. Let's move on a little further. Right. This is the point that I just mentioned about why do we need data science, right? The primary reason why we need data science is, of course, because almost since the year 1990, what we've seen is there's been a sudden spike in the volume of data that is being generated. Year over year, we see that the data growth is simply exponential. A lot of internet-based companies are coming, a lot of e-commerce companies are coming in, a lot of small and medium businesses are completely switching digital. Everybody has a mobile phone, everybody uses social media, everybody uses WhatsApp, and and everybody now performs transactions with digital wallets. Nobody actually uses actual money anymore. Everybody uses credit cards and all of those transactions, which means that imagine the volume of data that's getting generated throughout the globe. Every time I move from one place to another, data gets generated. How? Because I have a watch on my phone, on my wrist, which captures the number of steps that I move. Right? I move, this data getting generated. I sit and I work, there's a volume ton of data that, let's say, my Windows system is generating. So the point is, data is everywhere. Their data is getting generated everywhere, and every company wants to analyze that data and then identify some interesting patterns of how people are how actually they're using their product, which means that every company wants data science. And if every company wants data science, every company wants data scientists. And if every company wants data scientists, you got to take this course. Just kidding. But then the point is, it's a good time for you to actually move into this field, more so because we've never seen, and data science as a field is here to stay, right? It'll evolve over a period of time. um, it'll become more and more smarter, more and more complex problems will be solved, because the ones who are going to come in later are only going to be left with complex problems, because all the easy ones, we've already solved them for them. So the point is, the field will evolve over a period of time. You would suddenly realize that your 9th standard or your 10th standard kid is already learning data science probably in their school. It's already happening, right? Kids are learning data science and engineering already, and then it's a matter of time before they start learning data science in their school, in some form or the other. This would more or less become an essential skill, and this is not a hype that would die off after a few days, right? The other interesting thing is also about, take the example of credit card fraud. I'll tell you a classic example of how fraud detection systems really work, and not credit card fraud, but let's talk about a different kind of fraud. Let's talk about the fraud that happens in, let's say, an e-commerce industry. We can also talk about credit card fraud. That doesn't matter. Something more relevant is the e-commerce industry. So let's say you as a user, right? You are a user. You're using, let's say, your e-commerce platform, Amazon.com, Flipkart.com, whatever.com, some e-commerce platform.com, and you've performed a particular transaction on this. Right? When you perform a transaction, what happens is, this is basically you and your house. The moment a transaction is performed, of course, an order is placed at the background, right? There is an order that is placed at the background. But at times, if you've observed, what happens is Amazon doesn't directly approve your order. You don't get an order confirmation right away. But Amazon takes a few minutes before they confirm your order. But what happens during that time? There are multiple things that happens during that time. The first thing that happens is they go back and they check if the product is available or not. They identify which seller to pick up, and they identify all the logistics behind that. That's one side of the story. The other thing that also happens is they validate if the transaction that you've performed, if it is a valid transaction or not. They identify if the transaction that you've done is, if it's a valid or a fraudulent transaction or not. So what happens at the background? I'll tell you what happens. So the moment you perform this transaction, there is a bunch of information that is sent, like your name, location, time of transaction, the amount, the product, right, and so on and so forth. A ton of information is sent to, if I were to say, an intelligent system at the background. Let's call it a data science predictive model. We call it predictive models. Predictive models are simply nothing but, these are a bunch of simple mathematical equations that are learned from historical data. So there is some kind of a model that is sitting at the background, right? So some information is sent to this, your name, address, location, whatever, all your information is sent to that particular, the amount of money that you've paid for that product and the mode that you made that payment from, and so on. It's sent to this, and this spits out if your transaction, if it is a fraudulent transaction or a genuine transaction. Now, the moment it predicts, so it gives some level of probability. It says that this product is this transaction is an 80% fraudulent transaction, and this transaction is it's only 20% genuine. So if it identifies that it is 80%, what happens after this is then it is likely that you could get a phone call from Amazon verifying if you have actually performed this particular transaction or not. So you are likely to get a phone call from Amazon, or let's say from your bank as well, verifying if that particular transaction that you've done. And there's a whole system, the whole set of a team that sits at the background, which makes these phone calls, right? There's support center people, customer service people, fraud detection, customer support division from Amazon, or let's say from Flipkart or any of these companies. They automatically pick up the phone call, and they dial you up and they verify if you've performed, if you've done the actual transaction or not. They verify if the transaction is fraudulent or not. Then what happens after that is quite interesting. If they realize that it's a fraudulent transaction, it is a +1 for your model. Your model is happy that you basically, because your model has predicted something and your model has actually learned something. If your model is predicted that this is incorrect, it predicted that it is fraud, but then in reality it is not fraud. You called the customer service guy called up the customer and he said that the transaction is a genuine transaction, then it's a -1 for the model. So figuratively speaking, what we do over here is we retrain, or we remake this particular data science model relearn from the new data, right? So what now happens is, now this fellow is fed this information back, and we ask him, or this data science model is retrained on the latest data, so that now it starts to recognize more and more interesting patterns from the latest data that has been sent to it. Okay, but the question is, how was it trained in the first place? How was it trained in the first place? The way it was trained in the first place is, what Amazon would have done is Amazon would have collected a large list of information, starting from the name, address, blah blah blah, transaction amount, so on and so forth. And they would have also identified if the transaction was a genuine or not. So they have a flag which says fraud, no fraud, fraud, no fraud, fraud, and no fraud. They pass this information into a predictive model. And when I say predictive model, these are the models that you typically hear names like decision trees, random forests, regressions, and so on and so forth. Those are the terminologies that basically come in here. So we pass this to that, and this particular model automatically, this model, what it then does is you pass this particular data into a model, and this gets trained on this data, and this fellow becomes now smarter. This fellow is now very, very smart, because now it has learned all of this data. So this fellow is now ready for performing predictions. So now what I can do is I can pass a new record to it, something that looks similar to this. I can pass it to it, and this fellow will identify if it is fraudulent or not fraudulent transaction. It'll make those predictions. The moment I'm happy about the performance of this fellow, I take this fellow and I put him into production. I take him and I put him into production. And then we continuously, and this fellow is like now in the war zone. Every time a transaction comes in, this fellow predicts if it is good or not, if the transaction is valid or not. Now, this system is now become an intelligent system. Earlier, how was Amazon doing it? There were people who were manually trying to identify if the transaction was genuine or not, because there was manual verification that was happening at the background. Now what they've done is they've replaced that manual verification with a intelligent system. So when you place a transaction and when the order doesn't get confirmed automatically, what's happening at the background slowly is that it would take a few minutes. The Amazon machine or any e-commerce platform, what they do is they go back and check if your transaction is valid or not. Now this is valid even for, let's say, a credit card company. If you make a transaction on, let's say, your credit card, and let's say this credit card transaction suddenly comes from Vegas, I don't know how many of you all have actually realized this. If you make a sudden transaction with on against a company where you've suddenly traveled out of the country and then you've performed a transaction, the very next moment you get a phone call from from the company, basically asking if that particular transaction is valid or not. It's the same concept there as well. Think of it this way: every time a mail comes into your inbox, what your email does, your email server, your Gmail, or let's say your Outlook, what they do is they predict if this particular email, if the content in that particular email, if it points it towards a junk email, or if it is, let's say, if it is a genuine email. Based on that, it would drop it into one of these two places. um, so there is a lot of intelligence that goes into that as well. So based on where you use this kind of a concept, there are numerous applications of this particular system that we've just learned, and there are so many ways that you could that you could actually implement these, in so many industries that you could actually implement this particular thing, right? um, let's go back. That is basically what we mean by credit card fraud detection, credit card fraud, or any fraud detection. There's so many things that go into predicting fraud, right? I see some question from Kodishwaran. There are so many parameters that go into it. It could be the location from where you're performing the transaction, all the financial details of your mode of payment, from which bank it's getting routed, from which country it's getting routed, who is the issuing company or the issuing bank, and from which country is it based out of, and there's a ton of other, and what product have you purchased, what's the price of the product, and so on and so forth. There's a ton of information that goes into it, and it's not a manually crafted pattern, right? These patterns are learned over a period of time. Cool. So where can you implement data science? Data science basically can be implemented in a ton of places. These are just a few of the many that can possibly be that can possibly that where you can actually implement this. You name an industry and I'll give you 100 use cases of 100 use cases of, if not I, at least there are people where data science is currently being implemented. It's just that we don't actually have to see it, because systems are becoming intelligent by the day, which means the moment you don't realize something dumb happening, that means there's a lot of data science that's going on at the background. Swiggy, or your Zomato, or let's say your DoorDash, all your popular food delivery apps that you have in here in your own respective countries, there's so much intelligence that goes into it. What what dish do you want to eat, and what kind of what restaurant do you want to order this from, and so on and so forth. So much intelligence that goes into it, right?
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Predicting the ETA of your delivery, 20 minutes, 30 minutes, identifying how long would the delivery person actually take to deliver the product to your house. There's so much that goes into that as well. Right? Now, the thing is, there are these popular names. I actually don't want to confuse you all with all these names. These are those popular names and popular terminologies that you would see outside. When you see these names, now this is not to this is not to either show off or b to tell you all these complex jargon and frighten people. This is basically to simply tell you that when somebody talks about data science, these are common terminologies that people often use, the common jargons that they use. These are not really that complex, to be honest, right? So these are all those cool techniques where which is basically helping this algorithm to learn, right? All those are those cool techniques that is helping that algorithm to learn if a transaction is fraudulent or not, if the car should take a left or a right, or predicting if a customer would quit or not, would churn out or not. Imagine your company is doing some kind of analysis on you guys on predicting if you would quit your current job or not. It's scary, right? But then it actually happens. A lot of companies spend a lot of time in predicting if you guys continue to work, if you will continue to work, or basically predicting employee attrition. A lot of companies do this analysis. What goes into it? Think about it. Think of what kind of digital trails you're leaving to your own company. So your browsing patterns, your leave patterns, your work style, your performance, all of that is a nice indication of your interest towards quitting the company. How often do you visit the careers portal in your own company? How often do you visit LinkedIn? I don't know. I'm just saying. I mean, they could do it if they want to, but then we don't really know how many companies actually do it. But then, yeah, these are interesting scenarios to predict if you're going to quit the company or not, right? So all these are those algorithms that are going to help us build intelligence in extract patterns from your data and then build these cool models, so to say, right? uh, I'm going to talk about this a little, and I'm going to talk about this a little about what data science processes really are. um, the first and foremost is about how do you solve a data science problem. Now remember, data science is all about uh, if you want to extract pattern from your data, you've got to pass the right data into it. So Zafar has come back with a question saying, why are algorithmic traders not rich? Well, the algorithmic traders are not rich because data science is not magic. It's not sorcery that is automatically going to extract patterns for you. When I say extract patterns, there's a lot of work that goes into training these algorithms, right? There's a lot of work that goes into passing the right kind of data, extracting the right kind of data. If I ask you what impact, let's say, the stock price of Amazon, right? There are a million things that impact the stock price of Amazon, right? So then how do you, if you can pass all of that information to the algorithm will do well. Now tell me one such scenario where all such information is readily available for you. Not just for you, even the algorithmic traders are not going to get all of that information. If you have that information, then you're rich. So that's the reason data is like gold mine today, is more costlier than gold mine today. So you have all of that data with you, then you can mine, or then you can build these complex algorithms. If you don't have that data, there's nothing that you can do about it. So data is the next most important natural resource. If I have the data, I can do wonders with it, right? So that's the reason why not all algorithmic traders are rich. A lot of algorithmic traders are rich, by the way. Not all of them are rich, at least. Okay. A typical data science solution goes through a certain set of phases, steps, if I were to say. The first one, let's say, for example, take that example of fraud detection algorithm that we just spoke about a while earlier. The most important piece of data science is to understand what business problem to solve, right? Technology is readily available for us. There is technology that is there. You could make use of tools to solve a problem, but then you need to know what you want to solve, right? So it's like having a calculator with you. A calculator is only as efficient as the user, right? So if you don't know what to punch into the calculator, and if you just learn how to add two numbers in the calculator, you'll only be adding two numbers in the calculator. Similarly, data science is a long list of techniques that are available with you, but you need to know where to apply these. Right? To know where you want to apply these, you need to understand what business problems are available outside. So if you're working in, let's say, a telecom industry, or if you're working in an insurance industry, or let's say you're working for a stock brokerage company, you need to know what is the most important business problem that you'd want to solve. So understanding the business problem is super critical. When I say a business problem, take for example, my most important issue today as a telecom company is that a lot of customers are quitting my service and joining someone else. So can I build an intelligent system that can automatically predict who are likely to quit and then give them a relevant offer so that they stay back? So now what you've done is you've basically converted a business problem into a data science problem, right? So converting such business problems into data science problems is super critical, and that's what the first step is going to be all about. Once you identify a particular problem, and then you try and uh, you decide to solve that particular problem, then you move to the most important phase, which is the data gathering phase. And the point that I just mentioned to Zafar a while ago is the data gathering phase, where you try to gather as much data as you can about that particular business problem. So think of, in a telecom company, what are those factors that really cause a particular person to quit, right? Bill bill shock is what we call it. Bill is a primary reason why people quit. People quit also because of bad service, call drops, right, is one of the biggest issues. Bad internet issues, network availability is a big issue. uh, Value added services, you don't have enough value added services. All of these are major reasons why people typically quit. So what you're essentially going to do is you're going to move from the field of you're essentially going to capture all of those features, and then pass that into and then do some kind of quick data analysis and data processing. So you capture all of that data, but all of that data is not going to be in the best format for you. So what you do is you identify if the data is of good quality or not, and then what you do is you go ahead and you join different data sets from different data sources. I get data from, let's say, the billing system. I get data from the network system in a telecom company. Each system is separate, so I collect all of this data. I bring all of that data together. Once I get that data together, I do some basic analysis about if how good my data is. I do some quick visualizations just to understand my data a little better, right? Picture speaks 1,000 words, right? You don't really have to spend a lot of time in actually analyzing the data. Visualize it, and then you'll start to see interesting patterns come out of charts. You create those interesting charts and visuals. Becomes very easy for you to digest your data. Then what you finally do is you then prepare your data, and then you go ahead and build your model. Building the model, all of this has building the model is basically using the techniques that we saw in the previous slide. A few, I mean, there are more than these techniques, to be honest. These are just an example, commonly used techniques, but they're more than these techniques. If I were to list them out, it would probably take me the next half an hour to list all of them out. There's so many techniques are available out there, but basically the point is, we use those techniques to solve these problems, right? Creating and testing a model. Once you're comfortable, the next step, of course, is to go ahead and deploy it. That's basically the life cycle of your data science problem. Now, I've oversimplified the whole process, but at a 10,000 feet level, if I were to explain you what is data science and how data science problems are typically solved, this is a nice representation of how your data science problems are generally solved. Okay, there are more layers to this, and there's a lot of layers on how on what kind of people are involved in this whole exercise. One of the things that I'd like to talk about in this particular slide is that as a data, see, if you imagine until here, until your last step, 6 out of the 7 steps have got to do simply with data, data cleansing, data extraction, data analysis, and this and that, and this and that. Everything has got to do with data. So remember, garbage in, garbage out. Right. So if your data is not of a great quality, then your system is not going to learn any patterns out of it. If you don't have any patterns in the data, then you cannot extract those patterns. So don't blame the algorithm for it, blame the data for it. Right. So you've got to make sure that your data is of the is of a great quality. If the quality of the data is good, then automatically your patterns are going to get extracted very well. Okay. um, so because a lot of our work has got to do so much to do with data and so much to do with data extraction and so on, what we have seen is that there are a certain set of roles that most frequently operate with data scientists, and I'll tell you what they are. Right. So there is a data scientist, of course. The prime responsibility and the prime expertise of this data scientist is to apply these complex algorithms and perform pattern extraction and so on and so forth, do visualizations and do some pattern extraction and so on. But what we've also seen is that certain aspects, you cannot expect the data scientist to do data gathering and also to do deployments and everything, right? So there are people around the data scientists who help data scientists, right? There are other roles around data scientists who help data scientists quite a bit. Typical terminologies are, you have a data analyst or a data engineer. Let's call him a data engineer. A data engineer is someone who is responsible for doing the data gathering, right? So data engineer, what they do is they build data pipelines, they collect data, and then they put it in a particular location for us to use it from there on. That's what a data engineer is all about. Then you have, let's say, we then you basically have somebody from, let's say, your deployment teams. We call them, you can also call them as, let's simply for the current sake, let's call them as deployment specialists or deployment teams. they are responsible for deploying the models that you've built. So you've built a model, and then they often take the model from you, and then they go ahead and they deploy it in the production systems. They are the ones responsible for scaling out your problems. We call them ML engineers, big data engineers, and so on and so forth. But essentially, these are the ones who are responsible for your deployments. And then on the other side, you also have some business specialists, business experts who specialize in the business side, business stakeholders. They are the ones who understand the business. They are the ones who evaluate if the models that you've actually built is of real business value or not. But in a lot of ways, a data scientist is also expected to bits and pieces of each of these. It depends on the size of your organization, size of the company that you're working in. Certain companies, you have these teams well demarcated. In certain companies, you might not. As a data scientist, you're expected to do all of it by yourself. So it depends on how big your organization is. It depends on how well structured the data science teams are there in your organization. But remember, your core skill as a data scientist and your core skill out of this course that you're going to learn is going to be data science, which means it's the art of pattern extraction. Don't expect yourself to learn data deployment at the end of this course. That's not what we are headed towards. Don't expect yourself to build data platforms at the end of the course. That's not where we are headed. What we are headed in this particular course is to equip you all with all the necessary skills as a data scientist. Right? What do you mean by data scientist? Somebody who can explore data and understand and build these intelligent systems, understand the data, visualize data. Somebody asked me, why do you need to visualize data and why do you need to clean data? Imagine a lot of companies, what happens is when you fill your data set, when you fill an application form, how many of us have filled the application form with utmost with utmost commitment? Half of us don't even care about the fields that are there in certain application forms, and we choose not to write them. So there's a lot of data cleansing that needs to happen. So when you're manually typing in forms, manually entered data requires a lot of data cleansing, right? Because I might write, let's say, I might be very bad at my spellings, and I might write the term Philadelphia incorrectly because I did not learn the spelling of Philadelphia correctly. But you might require some kind of data cleansing to clean these incorrectly written data out. You might also have to write, so somebody might write their pin code as 00000, just so that people don't get to know what their pin codes are. So there is some kind of data cleansing required to get rid of such data set, such records. Hence, data cleansing becomes really important. And why do we need data visualization? The reason why we require data visualization is because you might be doing a ton of analysis, something that only you understand. But then how are you going to convey the story to, let's say, a how are you going to convey this story to somebody who does not understand data science? The best way to do that is by putting in charts together. You perform some kind of simple visualization, and that visualizations are going to help us in conveying the data story to somebody who's not from the data world, so to say. That's where visualizations become super critical. They are a very, very strong form of communication to a community that does not understand data at all, right? Hope that makes sense as well. So the point is that there is a ton of roles that are available outside today, but remember, what we are targeting is a data scientist. I mean, there are different names that people are called at, of course. You also have a term called as big data, right? All of this is great, but what is big data then? So big data is where things become very interesting. Big data is basically that particular field which has got to do with the data engineering side of the world. Right? Big data is a field got to do with the data engineering side of the world. I mean, partially with data engineering and partially with data science. There's an overlap between the data science and data engineering world. So if, for example, if you were to deal with large volumes of data, right? Take, for example, the amount of data that an aircraft engine generates. An aircraft engine has got a few hundred sensors on it, and every second ton of information is generated from one single engine. And there are so many engines, there's so many flights that are in flight, and across the year there's some millions of terabytes of data is generated in a given year by, let's say, a simple aircraft carrier. Your cars generate so much data, right? When such large volumes of data come in, the first question is, where do I store it? Like, forget about analyzing it. Firstly, where do I store it? Right? So then you require complex data platforms to be built, interesting data platforms to be built, so that you can store that data, and not only store the data, also retrieve that data. So big data big data analyst, or when you say big data and big data analyst and Hadoop and things like, these are basically technologies that help us in building these complex data platforms. Let the data flow in. But then what is big data analytics? Why does the term analytics come in there? The reason why analytics and big data and data science are often very well spoken together is because at the end, the largest consumer of this data is a data scientist. So what does a data scientist do? A data scientist then takes that large volumes of data and then builds complex algorithms. What that means is that we should, as a data scientist, I should also be well equipped to not only work with small volumes of data, but also work with large volumes of data, right? That's one of the reasons why a data scientist is also expected to have some knowledge about big data. So remember, a big data analyst is somebody who is or big data engineer is somebody whose primary responsibility is to move large volumes of data from one place to another place, store them, do ETL, do some transformations on data, do some loading of that data, and that's where they are. That's their space. Our space is to make use of that data and build complex algorithms, and there's an overlap between these two. That's basically where big data and data science sort of have a slight overlap. But remember, it's not our responsibility, and a lot of companies have this very well demarcated. Even the small companies have a data engineer and a data scientist well demarcated. Generally, there's a decent demarcation even in small companies, but again, it depends on the role that you're picking up and things like that. The tools that we will generally be learning, that you as a data scientist, I'm not talking about it from a simply the course standpoint. I'm talking about in general data science as a field. What has happened is Python has more or less become the ruler of the industry today, right? Python is the most popular data science most popular tool preferred by data scientists. Second comes R. There has been a very tough competition between Python and R for a very long time, but slowly what has happened is Python has taken over. Python has become more and more popular. The reason, of course, there being the fact that Python has more capability. It's much easier to build Python models for production. R is great for experimentation, but Python is really great to build production grade systems. So that's the reason people have moved away from R towards Python, and that's the reason that's one of the cool things about how Python has become really very popular. So Python and R are of course the two most popular tools for doing data science. Python is of course meant to do a ton of other things as well. You can build websites using Python, you can build games using Python, you can build web apps using Python. There's so many things that you can do using Python. You can do data engineering using Python. There's so much that you can do. The only point is that Python as a tool, one of the key things that you could also do with Python is data science, right? So we're going to use Python for data science, and whenever you attend a data science session, the kind of Python that you're going to learn is, of course, you're going to learn the basics of Python, but of course, you will learn Python from a data science lens. So you're going to learn all those libraries and all those tools and packages that will help us in performing data science analysis, right? So that's basically tool number one. In parallel, while these are tools that are really cool for performing analysis, what has also happened is to be a really useful data scientist, the other thing that you are also expected to learn is some SQL, right? Why do you need to learn SQL? Remember, I mentioned to you that our responsibility is not just about building models. Our responsibility is also to take that data and build models. Take a data that is available somewhere and then build models. Nobody's going to feed things into our mouth. So which means that a data engineer is going to do his part of moving the data and then putting it in a particular location. But from there, moving that data from the databases and doing some quick analysis on the database side and then moving it into your own Python environment means that you will need to learn some SQL as well, some basics of SQL as well. While these are great, if you move from, let's say, basic and intermediate courses to advanced courses, what you will also learn is Python also has got more complex variants in it called as, let's say, PyTorch. For example, if you're moving from traditional machine learning to, let's say, deep learning courses, so then you will have to learn other packages of Python. When I say packages, other modules of Python, which are called as PyTorch or, let's say, TensorFlow or Keras. These are the ones that are going to help us in performing big data. So these are the ones that are going to help us perform deep learning. So this will help us in deep learning and let's say neural networks. So this is basically regular machine learning, but if you want to move from regular machine learning to advanced concepts like deep learning, This is basically where the play is going to be. You'll have to learn these tools like PyTorch and Keras and TensorFlow and things like that. That's where don't think of these as different tools. They're just different modules of Python. That's about it. It's still Python as a programming language only. Okay. On the data science, on the data engineering side, what you will need to learn, while SQL is good enough for regular machine learning and simple data, when you're working with complex data, large volumes of data, that's where you might have to learn a tool called a Spark. Why? Because the moment the volumes of data become larger, you cannot fit a 1 terabyte of data in your machine, right? You'll not be able to open it. Forget about doing analysis. You will not be able to even be able to view that data. So to actually perform such large volumes of to perform analysis on such large volumes of data, that's where Spark becomes very, very useful, right? So that's where we'll have to learn Spark as well. And that is basically what you see on your screen is the landscape that is currently available today. Python, R, SQL, and of course you have Spark and other tools as well that are available outside today. Okay, so that's the landscape. In most of the courses that you're going to see, even in the Intellipaat course, and let's say most of the courses that you will typically see, this is if you, I mean, being a good Samaritan, you got to make sure that the tools that you're seeing outside are covered. Wherever you pick up, whatever course you pick up, got to make sure that the tools that you see outside here on your screen are covered. At least one of these two, this, and this, basically is what you should ideally be looking at based on again the complexity of the course. If it's a small course, a short course, then Python, SQL are good enough. But you're taking a longer course, then expect yourself to learn all the other tools as well. Deep learning is the next big thing of big data. Deep learning is the next big thing in data science. Big data and Spark are basically for, are on the data engineering side. Think of it this way. Spark, big data are on one side of the spectrum. Deep learning is basically the next big thing in the data science industry. It's not the next big thing, it's already the big thing. For a typical data scientist, right, what happens is a data scientist can actually join in as an apprentice, a junior data scientist, and can become a senior data scientist, can actually become a lead data scientist, a data science manager, and then you can have a VP data science and CEO data and analytics and so on. A CIO data or a VP data and analytics and so on and so forth. So you have roles starting from as low as, let's say, an apprentice entry level data scientist all the way till the end, right? All the way till a CXO level, so to say. So there is, in a lot of large organizations, these roles are very well defined and there's a nice career path, so to say. But in general, if you want to be a data scientist, expect yourself to be a hands-on data scientist at least for the first few years. Don't expect yourself to straight away enter as a manager or, let's say, as a lead straight away. Expect yourself to do some kind of hands-on initially as an individual contributor, and then you can move into other larger roles. There are two kinds of data. The first one is structured and the unstructured. I'm going to repeat this point for you all once again. Structured and unstructured data. I think the structured data that we're talking about is data that can fit in a table, right? In an Excel sheet like a format, right? You have rows and you have columns. So you can basically enter data in a row and column format, right? So think of it that way. So you have customer ID, and then you have, let's say, information about all that particular customer, and all of this information is nicely stored in, let's say, a tabular format. Unstructured data is data that does not fit in a tabular format. Take the example of an image, photograph, right? When you want to do some kind of analysis on a photograph, or you want to do some kind of data analysis on, let's say, videos and audio and so on, that does not fit in a Excel sheet, or that does not fit in a simple that you cannot store that information in a tabular format. Hence, such data is referred to as unstructured data because there's no structure to that data, right? That is what we mean by structured and unstructured data. As data scientists, we work both on structured and as well as unstructured data. Okay, that is what we mean by structured and unstructured data. Data scientists work on large volumes of data. Data scientists work on big data sets, so to say. Yeah, that's basically the relationship between these two.
Introduction to Python. So, what is Python? Well, Python is a high level object oriented programming language for general purpose programming. It is one of the most widely used high level programming language and is well known for executing basic tasks with less code, which makes it more compact and an economical language to learn. If you see, Python code is often 3 to 5 times shorter than the Java codes and around 5 to 10 times shorter than C++ codes. Well, if you talk about its history, it was developed by Guido van Rossum in the year 1991 and since then its open source community is still growing. So how do you think he came up with this name? Was it because of a snake? Well, no. Rosem named Python over the name of a sitcom TV series, Monty's Python Flying Circus. It seems he was highly impressed with the show, right? So these were some of the high-level introduction to Python. Now, a question might arise in your mind that what made Python so popular or why you should learn it. So let's discuss it one by one. So the first point we have is simple and easy to learn. Well, if you compare Python with any other language, for example Java or C++, you'll find that its syntax is way lot easier than them. You don't have to worry about the missing semicolons in the end. And its syntax is more readable and you are safe from writing multiple lines of code just for printing a statement, like in case of Java. If you talk about Python, all you need to write is just one line of statement. For example, print, and within the double quotes, mention whatever you want to print. So that's how it is simple and easy to learn. The next point comes the career opportunity. Well, like I told you in the beginning of this video itself that Python has a huge career opportunity in the IT industry. Almost every other IT company, be it a startup or a multi-billionaire company, are using Python in some or the other ways. So if you're a Python developer, you will be in a huge demand for a wide range of jobs in the domain of machine learning, databases, data analysis, cloud infrastructure, website designing, website reliability, testing, scraping, security, mobile developments, and many more. If you don't trust my words, just go and look out for Python developer job on any major job website. You will find thousands of job opportunities out there with an average salary of around $116,000. This indicates that there are many companies out there who are competing to hire a knowledgeable Python developer for them. So yeah, you have a huge career opportunity in Python. It all depends on your skill. Alright. Next is large open source community. Well, if you become a Python developer and when you are stuck or you want to learn something new, then you don't have to worry about it. You'll find a large number of resources like reference manuals, books, tutorials, videos, forums, etc. out there on the internet. If you have any doubt or some technical issues, you can directly seek help from thousands of Python community members on forums, Twitter, Facebook, and pretty much everywhere. Now, since Python is an open source community, you will always find people who are trying to improve it, keeping it fresh and up to date with current trends and bringing out newer version of the language. Right? So yeah, it has a damn large open source community. Next we have is reliable and efficient. Ask any Python developer or anyone who has ever used the language and they will agree that it's speedy, reliable and more efficient. You can work with and deploy Python applications in nearly any environment and there's little to no performance loss no matter what platform you work with. Again, because it's versatile, this also means that you can work across several domains including web development, desktop application, mobile applications and many more. You're not bound to a single platform or domain as it offers the same experience almost everywhere. Alright, so next we have is the extensive library. Well, Python has a huge set of library list which would be useful for any programmer interested in Python depending on their area of interest. For example, you have NumPy for scientific computing, Plotlib for data visualization, NLTK for natural language processing, Django for web framework, Pygame for game development, and there are many more. It can be used in a lot of places and has a wide variety of application. Like for web development, you can use Python web framework like Django, Flask, and Tornado. If you are into developing desktop application, you can go with PyGTK and Cocoa. If you are planning to use Python in the field of machine learning or deep learning or data science, you'll find many Python libraries for it. Like sklearn, TensorFlow, Theano, NLTK, and many more. If you talk about cloud and DevOps, you can use OpenStack Python Software Development Kit, which is generally used to write Python automation scripts to create and manage resources in your OpenStack cloud. You can even use a Python library named Fabric for streamlining the use of SSH for application development or system administration tasks. Alright? Last what we have is hardware programming. Next, if you're planning to switch over to hardware programming, you have Raspberry Pi to connect your project to the real world with Python. Well, now that you know how important is Python to the world, let's see the popularity of Python in industry. Well, big tech giants are using Python. In fact, Python is one of the Google's favorite languages. They are always hiring experts in it, and they have even created many of their popular products with it. Well, I don't think I should again mention that since many big companies like Yahoo, Facebook, Netflix, Dropbox, YouTube, BitTorrent, NASA, and many other rely on Python developers. So these companies are always in search of talented professionals who have already worked on and have some experience in Python. There is and there always be a demand for Python developers and Python web developers, and they are even offered some decent packages.
Why do we require Python for data science? What makes Python the gold standard when someone thinks about data science in today's world? Well, of course, let me tell you this by starting out saying that Python is the number one programming language in today's world. I still remember the days when Java was still the king of the programming languages, and then Python came out of nowhere with this popularity, with this huge, powerful community. Of course, open source community. Python is a free language, and these guys started developing the language in such a beautiful way. It has beautiful syntax, it's very easy to use, and it scales across multiple domains, be it artificial intelligence, be it natural language processing, be it handling and designing web pages, whatever it is. Python is there and it's expanding rapidly across various regimes in today's world. With respect to data science now, in fact, let's dial it down one more notch before we talk about the specifics of Python for data science. Let's talk about how simple and readable Python actually is. Now check this out. I have a Java code in front of you guys which basically prints one output on the screen which says hello world. Do you see the amount of characters, the amount of complexity that goes beyond the understanding of the common man to basically get at this output? Well, all we're trying to say is, hey computer, can you please print hello world to me? And look at how we can do it in Python. If you were a programmer and you understand that data science is a very complex arena with lots of statistics, lots of mathematics, and lots to do with artificial intelligence, data handling, data pre-processing, data analysis, and whatnot, I think this would give you a lot of clarity on what would be your best choice to pick up a language, right? Well, I've just given you a very clear examples on the basic statement of how to print something. Well, I can tell you and I can assure you that with respect to all of the other syntaxes in Python as well, this is exactly the same case. Even if you do not understand the syntax, when you're using Python, the advantage it gives to the readers is that you can actually look at the syntax and figure out most of what it says, and you do not even have to know what it means to sort of, guess what it's doing. With respect to other programming languages, I believe this is not true because I was there a couple of years ago, in fact, when I was trying to figure out syntaxes of languages that I did not know, and it was really tough for me at that point of time. So what do you guys think about Java and Python? These two are the top programming languages. Of course, we have other languages in the world of data science as well, but then to understand that in the complex world of data science, keeping it simple is everything, and I would emphasize more on that. And again, here in my opinion, Python wins for just being simple and having the high readability. Now let's talk about a little bit in terms of what it offers when you're working with big data. In the world of data science, as you might know it, there is tons and tons, gigabytes and petabytes of data, which is basically, generated on a daily basis. When that is the case, you need to have the statistics, you need to have the tools, you need to have the techniques to handle all of this very easily. Well, again, with Python talks amazingly well to all of the big data frameworks out there, be it Apache Spark, be it Dask, be it PyDoop, or any other framework which basically handles all the big data in today's world. With Python and with all of these tools, we can bring the power of parallel computing to today's world. You might be wondering what parallel computing means. Well, let me tell you that basically if you have a task which needs a lot of computing power, instead of making it run on one single computer, you can actually assign it to multiple machines in a network and use the computation power and leverage that extra extra power to get it done. So now instead of stressing one single machine out, you can spread this task across and get the same job done easily, quicker, and in a more efficient way with respect to multiple computers. Now I just made it very simple for you guys to understand, and there is a lot more complexity of where this comes from. And even in that case, referring back to my first point with respect to Python, it makes it really easy to work with the first step of data science, which is basically to handle the data, bring in the data, and even perform some pre-processing with the data. Now, artificial intelligence is something most of you would have in your mind as soon as you clicked on this live session, right? Well, I've got you covered. Well, whenever we talk about artificial intelligence, you need to understand that AI has been the paradigm shift that the world was looking for, because now we have numbers saying that, we can prove artificial intelligence is an entity which is helping humanity to its maximum. There is a 44% increase in basically enhancing the products we use by using artificial intelligence. We can optimize all of the operations within our organizations, within our companies and firms by up to 42% by making use of AI and its related concepts. And believe this, we thought humans were the best when it comes to decision making, right? Well, of course I would agree on that point, but then to add on to that, well, with respect to that, we can make better decisions with over 35% of guarantee when we use artificial intelligence. How cool is that? And of course, we can optimize external operations by up to 31%, and we can free workers to be creative. We can make sure that they're not doing the mundane tasks which can be done by computers in today's world by over 31%. Well, you might think, okay, these are just percentage numbers which might not mean a lot to me. Now think about the billions of people, if not the millions, who are actually in the world of IT and who are actually waiting to revolutionize the world, who are waiting to jump on this trend. Now, all of these numbers will be extremely beneficial to the people, will be extremely beneficial to the employers as well. Let's come back to the specifics of Python. The first thing is that when you're working with Python provides a very efficient way to help you process all of the data. When you're working with artificial intelligence, you need to understand that having more data equally relates to getting your model trained better and helping it become more, let's say, intelligent. Now, when that's the case, you might be wondering, okay, so how big is the data? Well, this depends on each of the scenarios, but then with the general understanding that we need more data to train the models better, you need ways where you can efficiently process this data, right? With more data, you will be inviting more complexity. With more complexity, you will be inviting more problems. And of course, we don't want that, right? That is exactly what I'm talking about. When you're working with Python, it gives you very elegant ways on how you can handle data, which of course we'll just check out in the upcoming slide. And then coming to the vast library ecosystem of Python, of course, as I told you, Python is one of the biggest growing programming languages in today's world. When it gets that kind of a tag, when it gets that kind of an attention, there's a reason for that. And I believe this is the reason for that, because it provides thousands and thousands of libraries for people to work with anything that they have in mind. So let's say you're trying to solve a problem now and you're stuck at any point. Well, basically all you have to do is, the first thing if you're working with Python is just Google it out, find out if there's a package in Python which will basically help you for that. And if by chance you're in luck, let me tell you, 99% of the time there is a package, there is a library in Python that will basically help you with exactly what you want. And this is amazing because we're catering to millions of people here with probably hundreds and hundreds of thousands of problems, right? When that is the case, all of these libraries which are present in Python will be the guiding force to solve these problems quicker. Coming to visualization tools, again a little more on this in the next slide, but then you need to understand that with Python, with all of the frameworks and the library extensions of Python, it becomes a very, very powerful tool when you're working with data science. And of course, community support is everything. If you're stuck with a problem, you have a community which is open source, which is widespread across the world, where you can dive right in, ask your question, and even solve the problem probably in under 24 hours, no matter where you're in the world. So this is the kind of community support that we have with respect to Python. And this is the reason thousands of companies around the globe have invested in Python, have invested in Python developers as well. Now, coming to the specifics of a couple of libraries that Python provides for the data scientists out there, we have two main concepts, and the first of it is numerical computation. Working with numbers, making sure that your mathematical game is up to the picture, ensuring that you can perform these computations and operations in arrays, be it in the form of matrices or whatever it is. Pandas and NumPy are the library in Python to be made use of just for this purpose. Coming to data visualization, you can create beautiful looking plots by making use of two very good data visualization libraries, which is Seaborn and Matplotlib. Of course, these are just like one or two tools in a whole pool of tools, and of course we're going to be looking at this a little more here as well. And this brings us to the Python developers trends of today's world. You might be asking, okay, so if it's the top job in today's world, if there is a huge requirement for Python developers, what do the trends look like? Well, you will be astonished that there are over 2 million jobs in 2020 and beyond. It is told that every year there is almost an addition of 500,000 jobs for Python developers. Yes, 500,000 every year, and in the year 2020 we have 2 million job openings for Python. So this is amazing when you even look at the Google Analytics chart you can see on the above. So this Google trend picture is trying to show you the interests of people over time, when all the way from 2015 and coming to 2019, and even showing a bit about 2020. At the end of it, you can see steep rises, steep curves everywhere, and there is a reason for this, and people understand that this is adding a lot of value to their organizations, and this is adding a lot of value to themselves as Python developers as well. Hence Python is this amazingly easy to use, friendly and trendy language out there now. If you're wondering what is the average salary that a data scientist gets in today's world, well, these numbers are amazing. So the average data scientist salary really does not care for inflation around it. And this sounds funny and humorous, but then it's amazing to see that right from 2014, which is now 6 years before today, the data scientist salary has always been above 120,000 American dollars. $120,000. This has been increasing, by the way. I have friends who are data scientists who make well around $190,000 to $200,000 per year as well. So when this is the situation, so you need to understand the importance of the salaries, because again, at the end of the day, we might be looking to make a career out of it for our lives. We might be just people who are interested in Python or anything. Knowing that there is a lot of potential here is very important. The average salaries in the United States of America is over $90,000 and all the way up till $140,000 and up. Be it recession, be it any sort of downs in the world of IT, a Python developer, a data scientist who can work with Python will get paid and compensated in a really nice way regardless of all of that. When we talk about India again, everything from 8 lakhs per annum all the way to 24 lakhs per annum. So basically what I'm trying to tell you guys here is that regardless of your experience, you might have questions asking, saying you might not be from a computer science background, but you want to jump on the trend train now. Well, let me tell you that, there is no strong requirement and prerequisite when it comes to becoming a data scientist. Of course, if you pick up a structured program where you're taught all of this from scratch, at the end of it, you can become proficient in data science without having to have any prerequisites of any sort. Coming from that kind of a thing to understanding that there is huge salary on the other side and it's trending and there's millions of jobs out there for Python, for data science out there, I don't see any disadvantages here at all. Now, if you're wondering what is the demands for data scientists in today's world, well, let the screen load right now for you guys. I have filled the screen end to end with people who are hiring constantly for data scientists, for people who know how to work with Python when it comes to data science. All of the social media that you can think of will make use of data science and Python in one way or the other. Be it Instagram, LinkedIn, Pinterest, Viber, WhatsApp, I can name everything on your screen right now. Amazon, YouTube, Unisys, Fractal Intelligence, again, basically Mu Sigma, IBM, Ernst & Young, Edgeworth, Ola, Siemens, Oracle, and everyone else, even Adobe and Apple. So basically, everyone on your screen right now is hiring. So, you need to put yourself out there and you need to have a data science oriented profile to basically, land a good job at all of these people who are hiring. You might be asking, well, how can I do that? Well, in my opinion, as I just mentioned, a lot of project works and a lot of industry level experience where you have a good amount of hands-on, where you have a good amount of teaching and structured learning will basically help you get there. You might have 10 certifications in hand right now, but then what if you do not have the ability to clear that interview, right? So that's what I'm basically talking about. A good certification program will ensure that you have the right experience. It will ensure that so you can crack interviews at all of these companies is what I'm saying. Now, if you're talking about job satisfaction, again, in the world of IT, there were multiple surveys conducted from 2010 and above, and people say that if they're a Python developer, they are about 80% satisfied with their job. You might be wondering, well, it's only 80%, it's not 100%, right? Well, no, 80%, trust me, is a lot when you're talking about an IT job, when you're talking about a job which requires you to program, which probably requires you to perform data pre-processing, data analysis, probably pushing you to achieve some sort of artificial intelligence, use deep learning, use machine learning, use data visualization, create dashboards. Well, that was a mouthful. You get the point. If 80% of these people, if 8 people out of 10 people are, immensely satisfied with their job, I believe that Python is adding a lot of value to the world of data science. Now, on that note, you might be asking the question saying, what are the packages that are available when you're working with data science? We already covered 2 or 3 packages in a very gist before, right? Now let's take a look at Pandas, for example. Pandas is a beautiful library in Python which will help you with all of the data structures that you need. And you can work with data wrangling concepts, data cleaning, data hunting, and in fact, even data manipulation and data visualization. So basically, if I have to order up everything that I've mentioned on the screen, from data cleaning, from, adding data structures to whatever raw entity you have, to manipulating that information and to visualize all of that, well, one library can do it all for you with respect to Pandas. And this, in my opinion, is again a beautiful thing in a programming language. And Python is all about these kind of libraries and packages out there, and Pandas is surely living up to the name to be one of the best libraries out there for that.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
And of course, NumPy. When we talk about NumPy, numerical computation, array processing, array operations, even linear algebra concepts, guys. So basically, for all of these needs, NumPy really stands strong and it makes your life a lot easier with very good syntax, high readability, and at the same time, ensuring that you can put in the required time to solve the actual problem at hand rather than worrying on the syntax. That is what Python is about. Then if we talk about more packages, we have SciPy. So SciPy is of course a beautiful library when you have to work with all of the statistical concepts out there, and we need a lot of statistics when you're working with Python as well. Linear algebra, calculus, integration, all of these mathematical concepts follow slightly behind in the world of statistics, and these form to be the foundation in my opinion. Making sure that as a developer you can work with these easily, well, that is all the goal about SciPy, to basically help you on your data science career. Now, if you're being worried about data visualizations or how we can create, beautiful looking graphs, well, let me tell you this, Matplotlib is a beautiful library to do that. In a recent survey conducted, it is noted that humans can perceive images 3000 times faster than numerical data. If that is the case, would you like to see an Excel sheet filled with thousands of rows and columns of data, or would you like to see 1 or 2 beautiful looking graphs summarizing all of this information? I'm sure you guys will say the graph, right? Of course, with this, you can plot amazing 2D figures, you can work with it as an object-oriented API, you can perform very good data visualization, and at the end of it, if you have to compare it to any other tool out there, it is very similar to the working of MATLAB as well, in case if you have used MATLAB. So on that note, again, to come into the side of machine learning, to come into the side of artificial intelligence, we have scikit-learn. Scikit-learn is a beautiful library which will help you by providing all of the machine learning algorithms out there. Be it supervised learning, unsupervised learning, reinforcement learning. You have everything from classification and regression for supervised learning, clustering for unsupervised learning, and of course, it will help you tune your model, work with model selection, and much more. Scikit-learn is again an amazing library to work with, and I'm sure if you guys have had experience and exposure to machine learning, so you would have used scikit-learn on a minimum of once or twice while learning on that. Coming to TensorFlow, TensorFlow is the gold standard for being the deep learning library, for being the library for neural networks when you're working with Python, and this forms a very important role of data science, because one of the majority goals of data science, as I've been repeating, is to ensure that you can achieve artificial intelligence. With TensorFlow, you can perform analytics on steroids. Yes, I just said that. Why do I say this? Because you can perform everything from sentiment analysis, voice recognition, face recognition, even TSA. TSA is basically time series analysis, and these are just the 4 things that I have put out here. When you're working with neural networks, such a complex procedure that you might think, we are trying to imitate how a human mind would think, and we're teaching a computer using those techniques, right? Now, you might think this is very complex. Well, let me tell you, it is complex if you probably work with any other programming languages. When you're working with Python, TensorFlow, and even there's PyTorch as well. PyTorch is basically another package for data science. So when you're working with libraries like TensorFlow and when you're working with libraries like PyTorch, it makes it so much easier to work with these. And I've been using TensorFlow and PyTorch for years together now, and I have fallen in love with it, guys. So again, if you've ever used TensorFlow or any of these packages, again, head to the comment section and let us know what your views on this is. And on that case, we've come to the section where we'll quickly check out a use case in Python to show you how easily you can handle data in Python. Just before that, let's talk about the use case. You might be wondering, so let's just say you're in the market for a new house now, and you might be wondering what concepts, what is the basic factor, what is the basic foundation of where the house pricing lies. So how will you understand how much price to pay for a house? What are the factors that is involved in knowing that one house is very expensive compared to the other? Is it because your house has a lawn that it is expensive? Is it because it has a swimming pool? Is it because there is a car parking available, a basement available, a lot of square footage of living space, and whatnot? Well, let me tell you that there is a lot more depending on this when you're considering about putting the most value to a house. What adds most value to a house is exactly what we're going to check out in our demo today. Let us see what are the factors which will play a very important role in assessing the price of a house and in validating on how people would like this based on those factors. Now, let me quickly jump to Google Colab. So Google Colab is basically a Python Jupyter notebook hosted on the Google platform. With this, we can basically write Python code online. It will be stored always, and it makes it very simple and nice to work with as well. So on that note, let us quickly jump into the code. The first thing you need to do when you're working with any sort of Python project or any programming project, in my opinion, is that you need to begin by loading all the files that's required, loading all the libraries that is basically required. Here, we're going to import all the libraries which is spoke about. We spoke about Pandas, we spoke about Seaborn and Matplotlib, which will basically create beautiful looking visualization for us. And of course, in some cases, data visualizations will not work, and this is just for the cases where it might not work. And we're going to be using a plot style called as BMH. BMH is basically Bayesian method for hackers, and it's a beautiful visualization way as well. So let me click this play button, and it is as easy as this. Now, as soon as that's executed, basically what it's trying to tell you is that it's done. Now, we need to load our data set. So how do we load our data set? And as soon as I run this without the data set loaded, it's going to throw an error now saying, hey, you know what? I cannot access the file that's present. So where is this file called training.csv? Well, let me quickly click on the tab on the left side, click on files, let me upload it. And as soon as I click OK, it'll start uploading. You can see here on the bottom left. And as soon as that's uploaded, it basically is in the current runtime now. It will basically expire as soon as the runtime is restarted. But until then, we will have our dataset loaded and ready. And as you can see here as well, we have the ID for the houses and we have a lot of information here. Everything from the lot frontage, basically telling you the square footing of the front lawn or the porch area. We have the total lot area, is the street which is paved, does the house have an alley. You can check out a lot of configurations as well. So is it inside a neighborhood, is it in the corner, what kind of a neighborhood is it in a college area and whatnot, what is the condition of it, what is the building style, what is the house style, is it a 2 BHK, is it a 3 BHK and whatnot, the overall quality based on a rating of 1 to 10, the overall condition right now, what is the year that the house was built in. This is of course a very important criteria to consider. When was it remodeled, if it was ever remodeled, what is the style of the roof, and what is basically all of the area which is available as well. You can find out even the type of concrete which has gone into building this house, and this data set is beautiful. The type of central air conditioning available, does the house have heating, does the house have a basement, if it has a basement, what is the square footing of the basement, what is the first floor square footing, second floor square footing and whatnot, total living area in the ground floor, how many bathrooms, how many full baths, half baths, and you can see that this is just a pool of data, right? And of course at the end of it you have the sale price at which the house is sold at. Now when we have to analyze what we're trying to do here, what we're trying to basically achieve here is to ensure that we can find a way where we can say, hey, these are the features, these are the factors which determine the price of that house. And as I just showed you, there is a lot of objects here to be considered. See, some places, some factors might mean a lot as well. In most of the cases, some houses might not have any of the miscellaneous features which is required. Some houses might not have fencing around it and whatnot. So when you have a lot of data like this, analyzing it, wrangling around with it and playing around with it is really fun in Python. But to do that, we need to perform some sort of cleaning, some sort of basic pre-processing. So what we're trying to do is, on an average, we can see that there's 1460 values for each of the features that we saw. If that is the case, then there is a good chance that if there are features which are very less in numbers, that they won't add any value to our analysis. For example, pool QC has only 7 non-null values. How will this stand a chance when you're performing analysis on an average of 1640 objects, right? So what we can do as a basic cleaning measure is to ensure that we can remove all of these values which are basically less than 30%. Or, so basically you can see alley is not a number, as you can see NaN denotes that it's not a number. So these will not add any value to our numerical computation, and we can drop all of these columns as well. And you can see that ID, alley, pool QC, fence and miscellaneous features got dropped. ID got dropped. Alley got dropped because, again, when you think about it, alley is not a number and much more. And just like that, you will understand that pool QC was less than 30% of the values, fencing wouldn't add a lot of value as well, and miscellaneous features are less here as well. So on that note, you need to check out how we can, analyze the data by actually taking a look at what it means. What does the data mean when you basically look at it? So since we're trying to figure out and map the way the sales price is actually given, you can see that the mean sales price of a house which is being sold in all of the data that we have is $180,000. So for around $181,000, this forms to be our basic mean, saying that this is where all the house prices might have clubbed on, and this is where they are structured about. So on an average, if you're thinking about all of these thousands of houses, this is where the house price is being sold at. And when you're working with numerical computations, as I just showed you, you can find out a lot about data frames when you're working with Pandas as well. And this is one of the biggest advantages. You can find the mean of it, you can find how many counts of data it's present, what is the standard deviation, what is the minimum value at which a house was sold, and what is the maximum price at which a house was sold as well. So all of this data is giving you a beautiful standard deviation curve, which will give you the mean, which will give you the 25%, 50%, 70%, 75%, deviations and much more as well. Now, if that is the case, the next step is to understand that what is the type of data that we are trying to pick up from the data set and what is the data that we will not require. As I previously mentioned, since it's a numerical computation based demo, we will not require any of the categorical data, right? So if that is the case, let us quickly print out all the types of data that is present. We have integer, we have floating, and so we have integer and floating as well. Now, when that is the case, we need to pick up only the numerical data. Now, here if you see, we have dumped all of the categorical data, which is not an integer, which is not a floating value. If I quickly scroll up to the data before performing pre-processing, you could see all these categorical data which are present here, which will not make any sense for the numerical computation that we're doing. See, for example, all pub or LVL or inside or FR2 will not add any value to the computation we're doing, right? So now after removing all of that, we have a very clean, elegant looking data set through which we can work with that. Now, before we begin any work on it, we need to understand that we have to take a quick look at the data to figure out all of these values that we have filtered. We have to figure out all of this. So we have to figure out all of this in a simple way. How do we do that? In my opinion, the most simplest way you can do is you can start plotting all of these curves and then taking a look at each one of these. So there's a lot of houses with a good amount of first floor square footing. So you can check out the average ground floor living area, the year on which the garage was built in the house, what is the square footing of that, and much more. So all of this data that you see on your screen right now in a very methodical way shown here will ensure that you can take a look at it and immediately grasp an idea saying that, hey, so this is basically what's happening. So for example, a lot of average garage area is basically somewhere around 0 to 1000 square foot. So this is somewhere around 500 square foot of average garage area, and I didn't need to perform any sort of analysis to tell you that. All I had to do was take a look at the graph, understand that this is a standard distribution, and all I had to do was trace the center and probably guess a value around that. So this makes it very simple to work with it at the same time. Now, on that note, let us start working with our data and let us hunt for things which will help us understand the sales price. So basically, we need to find out all of the features which will have the most impact with respect to sales price. In data science term, we call this as correlation. Correlation is simply the attachment that it has to one particular feature where it depends on it a lot. When that is the case, let us create a list, and this list will basically tell us that these are the values which have a strong correlation with respect to the sales price. See, 79% of the time, the overall quality of the area matters a lot. 70% of the time, the living area matters a lot. The number of cars you can park in your garage has a 64% impact, and even the basement footing, square footing of your basement adds a lot of value. And people say even the year it has been rebuilt was basically adding this much of correlation when we are thinking about sales price. Now on that note, we need to hunt for linear relationships where we're trying to functionate and we're trying to understand everything, saying this is the reason that the price is increased, right? So that is exactly what we're going to do here. Again, basically we are printing out all of these linear relationships out here, and you can, just by looking at it, you can understand that there's a lot of outliers in the data which might not have and add any sort of linearity to us. Well, as I told you, to keep it very simple, let us not be concerned with a lot of data cleaning, but understand how the data operations are actually performed. Well, after creating our list and after understanding that we need to find some sort of linear relationships where we'll be tracking that feature with respect to our sales price, then we need to understand there is one important thing. There is a lot of cases where there is a lot of zeros, right? So let me give you an example that the garage area is 0 in a couple of houses. So what this means is that there is no garages in that house at all. And how many cars can you park in that garage? If it is 0, it obviously means that you cannot park any car in the garage, right? And this is mapped against the sales price of the house as well. So if this is the case, if the number of cars you can park in that garage is 0, if the garage area is 0, if the swimming pools is 0, full baths is 0, then you need to understand that if it's 0, it will really not add any value to the computation. So basically, if that is not present in the house, if there is no garage in the house, if there is no swimming pool in the house, we need to remove that feature. And when we have to find out how many features we have to remove, and to understand that all of the and to understand that after removing all of these values which will not add any value to our sales price, let us see if we can find out any more correlated values out there. And after doing just that, you can see a lot of data printed on your screen. Whenever you see a 0 point number, understand that this is the probability and there is that percentage of chance. If it's 0.19, it means that there is 19% chance that this is adding a value to that. So after removing all the features which do not add value to our houses, after doing a little bit of cleaning out, finding out linear relationships, at the end of it, we can print out what we call as our golden features list that we just created a couple of steps back. And this here will ensure that these are the values which have a lot of these are the values that have a lot of say in correlating with that particular price. If the price is very high of that house, people are considering the year that is remodeled, the year that is built, the presence of a full bathroom, the first floor square footing, the garage area, the total basement square footing, all the way until the overall quality of the house. So these are the factors which are playing a very vital role in the price that's been quoted for those houses. And then now that we have our result, if we take a quick throwback to seeing this data, would we understand just by looking at this saying, hey, this is exactly what is adding value to the house? Well, no. You have 81 columns and you have 5 rows of data here. So basically, looking at this, you will get a clear understanding of what we are trying to do, but you will not get a clear understanding of what the result is. And now with the power of Python, with the power of simple programming concepts that's shown here at the end of it, you can confidently say these are the values and this is the list containing all of the features that is basically ensuring that it has strong correlation, and this is the reason the house is priced the way that is. How cool is this and how powerful this is, right? Well, exactly my point. This is again another reason why you should be considering Python for data science.
Let's understand what is statistics. Statistics is a branch of mathematics that deals with collection, analyzing, and interpreting large amounts of data. So we live in the world of data today. Data is everywhere, and you yourself are creating data merely by existing. Even if you're not interacting with any social media platforms, even if you don't have a phone, you're still creating data about yourself. Now, how is that? Your social numbers, such as your voter ID numbers, your Aadhaar card numbers, your employee ID numbers, they are data about you. They help to identify you or locate you in a specific context. What's more is your banking transactions, the things that you've bought online, your loans, your credit scores, all of that is also data about you, and they can help identify banks and companies and government to make important statistical analysis and inferences about you. Things such as whether you should be provided the next loan that you're applying for. This is what credit scores are there for. They help them decide whether or not you've taken loan previously and you were able to pay it off before or well before the expected date. Are you good for your money? All of these kinds of things that impact your daily life are predicted and calculated using statistics. It's not the only thing. In your daily life, statistics is being used all around you, all around the world, and we'll take a look at that one by one. But to understand what statistics is, it's a mathematical concept that allows you to derive information based on the data that you have about a specific topic. You can do this for yourself as well. You can take some data that you have collected about you, such as the daily expenses or monthly or yearly expenses that you have, and you can understand when does your expenses rise and when do they fall. What could be the reason behind that, and you can correct for them as well. So as you can see, it's a really important tool for anyone of any field to understand what statistics is. So why is statistics important? We've understood what it is and what can be done with it. But why is it important? What benefits does it provide to a normal person such as you and me? And is it really important for us to understand this? Let's take a look. So statistics allows us to derive knowledge from large data sets. As I've already discussed, data sets don't really need to be large, but if you have large data sets, then the knowledge that you have derived have higher chances of being accurate or reflecting the real world. And this knowledge can then be used to make predictions, decisions, and classifications. These decisions could impact your daily lives, and these decisions and predictions and classifications can be performed by you as well if you know these statistical concepts and if you have collected these data about yourself. So it's not just about yourself. You can compare your spending with other people by collecting the data that they spend, or collecting data about their spending or their expenditures as well. And you can also take a look at your career graph. You can take a look at salary hikes. You can compare whether you are getting the appropriate salary hikes that you should be getting depending on the kind of work hours that you've been putting in. There's a lot of things that you can do, and all of that could be performed using statistics. Now, statistics is really important in the sense that it's being used in daily life uses. So even if you are not using statistics to do something about the data that you have, many companies are doing it for you. If you're using Netflix, then many movie recommendation engines such as Netflix, Amazon Prime, and so on, they use statistical analysis to gather what kind of movies you like, what kind of movies do people of your age, your background like, and they recommend movies to you based on that. You can also make decisions based on that, such as whether you should take an umbrella outside or not, based on what the weather should be. Now, weather forecasting is also something that statistics is used for. You can also perform classifications, you can perform time series analysis, you can understand what would be the price of stock in coming days. Now, these are obviously not 100% accurate. Sometimes weather forecasts are wrong. Sometimes the decisions that you take about whether or not the weather is going to be like a particular thing that you have in mind, and it's not like that. Whether or not something is matching to the thing that you have, that's not really what statistics is about. It's about making a decision about a trend, understanding where things could go. It's not 100%, it's not exact science. You are not going to get a 100% answer for everything, but it's a good indicator of what you should do based on the data that you have. Now, where is statistics used? You've heard me say countless times that statistics is being used in your daily life, whether you use it or someone else is using it for you. Let's take a look at that. So, statistics is used in various fields. So, let's take a look at some of them. Medical research. Medical research uses statistics extensively, mainly to form hypotheses and reject hypotheses about drugs. So, if you've ever wondered how does a medical professional comes to the understanding whether a drug is working or not, let's say that they've created a new vaccine for a specific disease. Now they want to test whether that vaccine is working or not. How do they test it? If there's a person and they inject it with that vaccine and if he recovers, does that mean that the vaccine is working? Because if it's so, then just one person is not enough. There are in a particular vaccine test, there are hundreds of people, and if you inject them with the vaccine and if it's not working for everyone else but it's working for one person, do we reject the vaccine or do we accept the vaccine? If not, then what is the number of people that it should work on? What should be the profile of those people? Does the age of the person matter in this case? All of this is taken care of by statistics. So in medical research, statistics is used extensively. It's not just for understanding whether a particular vaccine or a tablet or chemical is working for a particular disease or not. There are many other things that statistics allows medical researchers to do, but this is by far one of the most important aspects that medical researchers use statistics for. Then comes stock market. Stock market is one of those fields where statistics is used extensively, and it's used especially by those who invest in stock markets, mainly because they want to predict whether investing in a particular stock is going to be helpful for them or not. Are they going to lose money, and if what is the risk of investing in a particular stock? Are they able to sustain themselves even after that risk provisions? If the worst case scenario happens, would they be able to survive? And if the best case scenario happens, what would be the profit? All of this is taken care of by stock market. In stock market, the data about a particular company's financial records, about their credits, about their stock market scores, everything is available for people to take a look at. So if they want to make predictions using statistical analysis, they can do so very easily because the data is already available. They just need to do the brunt of the work to get knowledge out of the data that is available for them. Then comes sales projection. In case you've worked in a company before where sales is important, you'll understand that sales is by far the most important aspects of many companies. If they're selling a product, they need to project what would be the sale of a particular product at a particular month, or at the end of a particular month, or a particular time period, such as a quarter of a year, that is, for 3 months, and understand, is the sale really up to the mark. So if a particular product that has been sold for the last 4 months, taking a look at the trend that it has shown, the trend of the sales that have shown, and we try to project it for the next 6 months, if it's not up to the mark, then that product is not doing well, and it could either be taken off the sale, or you could understand how what are the concepts, that what are the things that are not letting it be sold more, and you could correct for those mistakes. So a sales projection is what is used to understand, to project in future what would be the sales. Now, of course, as I've already told you, it's not going to be 100% accurate. If you have predicted that 10 lakh units of a particular mobile phone will be sold in the month of September, it's not exactly the case that exactly 10 lakh units will be sold. But if in the previous months 7 lakh units were sold, and in the next month 10 lakh units will be sold, then you can understand that the trend is rising. So in 2 months, in one consecutive month, we are getting an increase of 3 lakh sales. What could be the reason for that? Maybe proper marketing and all that. So all of that is understandable by statistics. Many companies hire really good statisticals and data science experts. They take a look at the sales projection, they try to isolate and identify the causes for it, and they try to replicate it more and more. This is what helps great companies survive. And then finally, weather forecasting. I think we all know what weather forecasting is. We all know weather forecasting uses statistics, but weather forecasting uses something called multivariate analysis. Multivariate analysis basically means there are several concepts or several factors that are influencing the weather on a daily basis. It could be the pressure, the air pressure, the wind flow, the direction of the wind. There could be a lot of things like the temperature and all that. And everything is important when you're trying to understand the weather forecasting. All of these things are taken into account, and then the weather is forecasted. Is it 100% accurate? Not really, but it tells you a general trend of what could happen. So it's more accurate than it's not. So that's what's important. So statistics is used in all of these fields. These are really small set of statistics and very well-known small sets of these statistics. We all know that these, or at least we know some of these concepts are using statistics in really in-depth analysis. So we understand that these departments are using statistics, medical researching, stock market, sales projection, weather forecasting, but there are many companies and they're using it for many other purposes. Now let's take a look at sampling. Sampling is the process through which we take a subset of our data from a larger set. So let's take a look at it. So sampling is the process of collecting data to perform analysis on it, or choosing a subset of data to perform analysis on it. Suppose you have 10 million records in your data set. Now, how do you choose a specific subset of data to perform analysis on it? Now, you might be wondering, why is this important? We can just select any random 10 points if you want to perform data on 10 points, or perform statistical analysis on 10 points, and then we do that. Or you might be wondering, why do we actually need to sample our data? Why can't we just perform statistical analysis on those 10 million records? Well, first thing to understand is that statistical analysis, although very important, is very time consuming. Even for a computer, it has to churn through a lot of data, perform a lot of complicated calculations, a lot of arithmetic, a lot of number churning is required for getting accurate results. So instead of doing it for the entire data set, we do it for a subset. Suppose that you have a data set of all this information about all these 7 billion people across the world. It's a hypothetical situation. You are not going to have information about that, but let's say that you have that. Now if you want to perform a statistical analysis on that, you want to check whether the whether something is true for everyone across the globe. You can, for instance, instead of choosing all the 7 billion people and then performing the statistical analysis and the numerical calculations on the entire 7 billion people, you can choose a specific subset of it. Now, how you choose the subset is really important, because you don't want to choose a data set in which you only include people from a particular country but not from the other country. That would, in some cases, lead to a biased data set, a data set that contains only a specific subset of people. So that's important. Similarly, if you're trying to perform an organization-wide statistical analysis, let's say that you are working in a multinational company and you want to perform some statistical analysis on an organization's employees, and there are, let's say, 25,000 employees. Now, for you to perform statistical analysis on 25,000 employees is not really viable. So what you can do is you can choose a specific subset or small subset of that data, make sure that it accurately represents, or make sure that you've selected in a way that every record in that 25,000 records had equal likelihood of getting selected, and then you selected them in that basis. So that's one way of doing it. So this is why we perform sampling, to get a small subset and perform statistical analysis on this. A small subset that accurately represents, or more or less represents it approximately well, so that could be performed. We could perform statistical analysis on it. The sample should represent a large subset. So that's what's important here. And before we begin, we should understand what is sample and what is population, because this is terminology that you're going to come across many times. And if you're trying to learn statistics, you've come across this already. So population is the entire data set, and such as the whole population of a country. And sample is a subset of that data. Population is the entire data set, and sample is the subset of that population which we are going to analyze to gain knowledge from. So suppose you're trying to perform some sort of an analysis on the people of a particular country, let's say India. Now there are 1.3 billion people in India. Now trying to perform statistical analysis on that big of a data set is going to be really challenging. So in order to reduce our burden and computational intensity, what we're trying to do is we're trying to choose a small subset of our data that is somewhat representative of the larger subset. So we try to gather data, try to choose around 20,000 people from 1.3 billion people that accurately represents the entire 1.3 billion people demographic. Now it's not necessary that we choose 1.3 billion. Let's say that we're trying to perform statistical analysis on people of India who are senior citizens, who are above the age of 60. Now, then that is our entire population. Everyone in 1.3 billion people who are above the age of 60 is the population, not the entire country's population, but just the subset that we're interested in. And if the size of that data set is really large, then we choose a small sample of it and we try to make it as fair as possible so that any person could have been randomly given a randomly chosen list. We choose someone randomly in that list. So that's the point. Population is the entire data set that we are interested in, not the entire data set that represents a particular group, and sample is the small subset of that population. If you're trying to perform statistical analysis on an organization, but only the senior members of the organization, then you have a smaller population. And from that smaller population, you can choose even a smaller sample. That's what's important here. Let's understand sample frame. So sample frame, or sampling frame as it's also commonly known, is a list from which a sample is selected. So this list could be anything. When I'm using the word list here loosely, list doesn't necessarily mean a physical list that you need to create, although it could be a physical list. It's just a collection of data points. That's a list. So for instance, the citizen register for a country. So if you're part of a country and you're taking a look at their population register and you're trying to understand the amount of people, their age, nationality, their income, family, number of people in the family, so on and so forth. So that's the sample frame. On the other hand, if you're trying to perform statistical analysis on an employee, on all the employees of a company, then that's your sampling frame. That is the data set from which you can choose your sample. So again, it's the same paradox that we had earlier. We need to just understand what is it that we're trying to perform the analysis on. If you're trying to perform analysis on every employee ranging from an intern to the CEO, then we use the entire company's list. Otherwise, we choose a specific subset. Let's say that we want to perform statistical analysis on the high paying side of the company. So we want only the senior members, people who earn above a specific threshold or per annum, and we perform statistical analysis on that. So that is what's important here. We're trying to choose a sampling frame is basically a list from which you choose a subset to perform statistical analysis on. Let's take a look at sampling error. So a sampling error is something that leads to a sample not being accurately represented in a population. Now, instead of me explaining to you theoretically, let us take a look at what that would mean. So I have this Excel sheet. I have bumped up the font size so that you can see what I'm trying to do. Now, let's say that I'm trying to take a look at a list of employees. So EMPLOYEE ID. Let me just expand the column. So let's say that the employees are, okay, there are 10 employees, and let's give them a name, A, B. So these are all the employees we have. These are just a sample list of employees. We have 10 employees. They have an employee ID ranging from 1 to 10, and we have employees with the name of A to J. Now, let's say that this is just for an example. Let's say that it's not 10, it's 10,000. So now I want you to select a subset of this employee. So how do you go about doing it? And the method you choose is incredibly important here, because if you choose, let's say, the first 5 employees, let's say that your threshold is that you want 5 employees, or you want to reduce this list by 50%. So you choose the first 5 employees. Now the problem is, let's take a look at that gender. So if the first 5 are all male and the last 5 are all female, and if you choose the first 5 employees to perform your statistical analysis on, then you have chosen a you have chosen a subset of your data, or you've chosen a sample that's biased. That's an error in your data. Now, everything that you perform is not going to represent the 50-50 gender ratio that this company has. So if you're trying to perform statistical analysis on what kind of products that does a company's senior level executives like, then you have only taken the male perspective into account and not the female perspective. So that could be a problem. Let's say that you don't do that first 5, you choose the last 5. You're running into the same problem again. You're choosing only females. And let's say that you choose this, then you are only getting one female out of all the females. And if you're choosing it like this, then these records, the first record and the last 4 records, they have no chance of being selected. So this is not an accurate way of doing it, or a correct way of doing it. There are many other ways that you can get errors like this. Let's say that there's age involved. Let's say that there's salary involved, and the subset that you're interested in is based on age, and then you're getting an error. Then you don't have if you don't choose it correctly, then you're not accurately representing or reflecting the entire population in your sample. So that is an important error to take a look at. There's also non-sampling error. So non-sampling error occurs even if you perform all this sampling correctly, even if you try to do it with all good intentions and do it with as much accuracy and as much good intentions as you can. There's still reasons that you get a biased data set. Let's take a look at why. Suppose that this is the information that I have. Now, non-sampling error mainly occurs because of you not getting you're not getting proper data or properly collected data. Instead of this, let's say that I got a data set to select from, in which I had 8 male employees and 2 female employees. Now, even though the company has 50-50 gender ratio, I've only gotten the data set that I've gotten is not accurately represented. So no matter how I choose it, even if I choose it like this, I'm still not going to get if I choose it like this, I'm still not going to get correct representation. Now that is a problem, and that means that our data set is not correct. Our data set is biased. On the other hand, if we get only the list of employees of young employees who were hired after 2010, then that is also a problem, because we want a wide spectrum of opinions. So we need people who have been hired before that as well. Now, it's not always the fault that you are getting incomplete data set. Sometimes what happens is the data was not collected. So let's say in the case of age of or the experience of a person, let's say the maximum experience that we're getting is 10 years of experience of a person, even though there are people in the company available who have had 25 years of experience. Now that could be that before the 10 years, they've only started keeping record of their employees since the last 10 years and not before that. Everything else is not in the list that you're taking a look at, so that could be a problem. So these are the kind of errors that you need to take care of. These are called non-sampling errors. Now if you take a look at the company and you don't get the accurate representation, then that is the problem that you're facing. And even though you try to perform good sampling analysis from that, you can still run into some great errors and incorrect or incorrect measurement or bias. So to understand incorrect measurement, let me just show you. Let's say that you're also calculating the temperature. Let's say that this is not the list that you're trying to do. Let's say that you're trying to calculate some statistical weather forecasting. You're interested in the temperature of the particular place. Let's say that the temperature ranges from 50 degrees to from 30 degrees to 40 degrees. Now, depending on how the temperature is taken and how long the period was, this is going to be a problem. Let's say that for some of the years the temperature has been taken in Fahrenheit. In others it was taken in Kelvin. And in others it was taken in Celsius. It could be that the company who was taking the measurement was going back and forth between what measurements to take care of. Now, if this is not mentioned and we are only given numerical details like 87 degrees Celsius, 84 degrees Celsius, 104 degrees Celsius, 107 degree Fahrenheit. Now let's say Kelvin is 275, 321, 320, and for degrees Celsius you're getting 27, 26, 31, 32, and 30. Now when you take a look at the data set, it's extremely varied. And this is not an information that you're getting. This is just for your reference. Let's say that this is the information that you're getting. Now the problem is that you have no idea why some temperatures are 276 degrees while others are 87 degrees, because if you take a look at it, you can't understand whether it's degree Celsius, degree Fahrenheit, degree Kelvin, and that could really lead into some errors. So this could be because of inaccurate measurements as well. Just delete that and let's move ahead. So when the data is being collected, that's also important. This is why we need to take care of that as well. Suppose we have census data from people from a country or a particular state or particular district. There also we could have incorrect samples. There also we could have problems. So we need to first analyze the data that we're getting the sample from so that we don't introduce a non-sampling error. Then we need to perform our sampling as accurately as possible. And let's take a look at some of the methods through which we can do that. The first is random sampling. So as the name suggests, random sampling is the process of selecting a subset or the sample from a population in such a way that every data point is equally likely to be included in the sample. So every data point has a fair chance of getting included in the sample that we're selecting from the population that we're selecting from. So again, to give you an example, let's say that now it's representing properly. Now I have 5 males and 5 females. Randomly selecting them is going to be a little difficult.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So let's say that it's not going to be very difficult, but it's easy to understand. Just make sure that you're putting your head in the right place. So if your thought process in the right aligns, we want to make sure that these 5 female employees and these 5 male employees are equally likely to be selected if we select randomly. So to do that, what we can do is, firstly, as we have already done, we have taken 10 employees. So we know that the employee IDs go from 1 to 10. If this is not the case, then we can take a look at some other measure. But here we have an employee and we have a list of employees. We are given a list index assigned to the employees. Now, if I want to select employees, what I can do is, firstly, I can decide the size of my sample. So let's say that I want to reduce it by 50%. So for that, I need to select 5 people from this list of 10 people. To do that, let's say that I just randomly select 5 employees. Randomly, that means from the range of 10. So I select 1, I select 5, I select 8, I select 10, I select 3, right? So these are all randomly selected people. Now I have 1, 2, 3 male employees and 2 female employees. So again, the sample is not going to be extremely accurate representation, but we're getting 60-40 representation, which is to say that we're getting around 50%, which is quite accurate of the one that we already have. Now the thing we need to understand is that since we have selected them, one potential issue that you can run into is that when you're selecting these samples, you are selecting them in and then reselecting the index. So let's say that I come up with 10 random numbers from 1 to 10 as 1, 2, 7, 2, 5, 4. Let's say 7, 2. Now the problem is that I've selected the index 2 twice. So make sure that you understand this. Many people just discard the next number to be something that other than what has already been selected. So that's one way of doing it. So just make sure that you're doing it correctly. The reason why random sampling works so well is because we are just randomly selecting any record that we can. And sometimes that's not always correct, because sometimes you get, if you're randomly selecting, you could put, if you have a large data set, then you could have 4 of male employees and 1 of female employee. So it's good technique, but it's not perfect. If you have a really large data set and you have accurate representation, then it's random sampling works really well in that scenario. But how do you correct for mistakes like this? That is for our next sampling method will tell us. So we understand random sampling. We just choose randomly out of a list of all the people from the population. We randomly select just a few people. So with that in mind, we run into an error in which if our data set is not really large, then the problem occurs that we might end up selecting data that's not accurately representational. Even though we might not be selecting it in a way that is completely malicious, we are not trying to select the people from a specific gender in our data set. We're just doing it randomly, but still there could be issues. So to overcome that, we come to stratified sampling. So stratified sampling is the process of dividing your samples into layers or groups and then performing random sampling on each group. So let me give you an example. Let's say that instead of 10, we have 12 employees, 11, 12. And yeah, so now let's say that I want to perform stratified sampling and the sample size is 12 and I want 50% of it, that is 6 employees. So to select that, firstly I take a look at the deciding factor. So I'm selecting them on the basis of gender. I want them to be accurately representative of the gender. So to do that, what I can do is I can firstly perform my stratified sampling in this group. It's an entirely male list. It contains only one portion of the entire group, and the other portion is contained in the list below. So let's say I wanted to select 6 people. There are 2 genders. So that means I want 3 out of each, right? That would be an accurate representation of the list that we have. Now, in case we have 40, 60, then we could select it in a different basis. So now what we can do, in this, I select 3 people randomly. Let's say I select 1, I select 2, I select 5. These are randomly selected. Let me just give them a color to tell you. And then in the other group, I select 3 people randomly again, 7, 8, 9, and 10. And you have a randomly selected list. It's accurately representing the population that we have. We have 3 females and 3 males out of 5 females and 5 males. So this is what stratified sampling does. The word stratified comes from the word strata, which basically means a layer. So we divide them into groups, or we divide them into layers, as many people would call it, and then we choose a specific subset of that layer or of that group to get an accurate representation of the entire population. That's one way of doing it. Random sampling is good when you just have people that you want to select and there's no need for accurate representation of a particular group. On the other hand, stratified sampling is good when you want to perform random sampling, but you have to take into account certain divisions in your data set, such as a group or division based on specific gender, specific age groups, anything like that. Now we come to systematic sampling. One major issue with the previous examples is that you need to have the entire list with you in order to perform the sampling. Let's say that I am working in some department in which data is coming in regularly. So I can't select data on this. I can't select data, or I can't select the data points that are going to be included in my subset or in my sample if I don't have the entire list. If I have 3 people, then I can only select out of 3 people in the next day. If I get 3 people more, then I can only select out of 3 people, and that is going to be a problem. And if the next day I get 7 people, then it's going to be incredibly difficult to make sure that I'm selecting them accurately. So I need to get the entire data set beforehand. Now, that's not always the case. It's not the ideal situation. Sometimes you can run into issues that are not based on that. So how do you correct for them? You come to systematic sampling. Systematic sampling is the process of selecting your sample by picking every kth element in your population. Now, k could be any number that you want, from range going from 1 till the number of people that you get. And you don't need a list for this. That's the extreme advantage of systematic sampling. Let's take a look at how to perform this. So let me just write the date on which these data points are collected. Let's say that's collected first of a particular month of a particular year. These are collected on the second, and these are collected on the third. Now, let's say that the k I choose is 2. That means I will select every second data point. This person comes in, I don't choose them. This person comes in, this is the second point, so I choose this. I move ahead. This person comes in, I don't choose it. The next day I keep the index and I choose this because it's the second person. Even though they have not, we have not seen them previously, they're still, the list is still going on and the calculation is still going on. Second person gets selected, second person gets selected, second person gets selected. As you can see that we are excluding the first person and including the second person. So that's how you can take advantage of the kth sampling. K could be anything that you want. Make sure it's not really big. Make sure that if you're only getting at max 3 people or 4 people in a day and you select 15, then you're never going to get the accurate representation or never going to select anyone that you want. So with that in mind, understand that this is going on. But one issue that you could run into is that this is not for every scenario. Let's say that I have a sample in which first person is male, second person is female, first person is male, second person is female, and this is the sample I have. If I choose k is equals to 2, then I only get female employees in my company to be taken as the subset or this sample of a population. That is going to be not indicative of the kind of problem that I'm trying to solve. So I'm not going to do that. So take a look at the dataset. If your dataset is arranged in a particular kind of group or a particular kind of pattern, that such as first employee is male, second is female, first is male, second is female, then kth employee is not going to kth or systematic sampling is not going to make sense for you. But if you have data set in which people are coming in regularly, this is for clinical studies or for test studies. If you've seen this, many people who go into a clinic to consult a doctor, the receptionists or people there sometimes give some of them a list or a questionnaire to fill out. That is to judge the performance of the clinic or some other problem that they might have, or maybe some medical survey to fill out. This is done using the systematic sampling because you have no idea how many people are going to visit your clinic in a particular day, in a particular shift of a person. So this is why systematic sampling is useful. You just take a look at the name of the person, mention them in a register, and then give them a number from, give them an incrementing number from the previous number. So the previous person was 1, then you give 2, 3, 4, and you select the kth employee for the scenario. And this is how that would work. So hopefully you've understood this, and let's go ahead. Now let's take a look at central tendencies. So central tendencies, as we've already discussed, take a look at the definition, is used to indicate where does the middle or the center of the distribution of a data lies. So central tendency basically is used to find out where does the most amount of values that our dataset contains cluster into. What is the range in which our dataset clusters into? So if we have a data set in which majority of the values are between the values of 4 and 10, then we have our central tendencies lying there. We have different ways of calculating different central tendencies, and they tell us different things about our data. So we have mean, we have mode, and we have median. So these are different metrics that all come under the umbrella term of central tendency. Central tendencies contain mean, median, and mode. These are different measurements of our data, and they tell us different things about the data that we have. Some are more important than others, and some have some categories as well, and we'll take a look at them one by one. The important thing to understand is the concept of central tendency. It tells us where does the majority of our data lie, what is the range in which the majority of our data lies, what does that tell us. And then when we go into detail, we try to understand what does this range of the data tell us, and what can we extract of value out of this information. Let's take a look at mode first. Mode is used to indicate the most frequent data point, or in other words, the one which occurs the most number of times. So if we have a data set in which we are trying to calculate the most frequent or the most popular choice, this is where mode comes in. Let's take a look at that. So this is what we have from previous data sets. Let me just remove it. Now let me just show you. Let's say that you are trying to perform a survey between three products. Let's say the products are P1, which is the first product, P2, which is the second product, P3, which is the third product. Given a choice, a customer is given a choice to buy one of these three products. Or considering all of them are of the same price and everything else is the same, and they are being judged on their quality of aspects, then which product will the customer buy? This is something that a customer will choose out of the three. So let's say that you perform this for 10 people, and let me just remove this. So these are our choices, and the first person chooses P1, second chooses P2, third chooses P1, fourth chooses P1, fifth chooses P1, and then the other one chooses P3, then chooses P2, then sorry P2, P1, P3, and P1. Now if I were to just calculate the number of people that chose P1, it's 1, 2, 3, 4, 5, 6. So 6 people chose P1. Then we have P2, and 1 and 2 people chose P2, and you can probably guess the 2 people chose P3. So if I were to ask you, okay, what is the mode of this data set? You're probably going to, I think the question is quite clear. Mode of the data set is the value that is the most frequent, or the occurs the most number of time. P1 is the most frequent choice, so P1 is the mode of our data set. So what does mode tell us? Well, not much other than the fact that P1 is the most popular choice among people. This kind of statistical analysis is useful when you're trying to perform some sort of an analysis of whether or not a particular product is popular among a particular group of people. Let's say that this was the result that we got from people of the age of 18 to 25. So a particularly young demographic likes the product P1 more. Now, if we were to, let's say, go the other way and ask senior citizens, let's say people over the age of 60, and if we were to ask them the same question, and let's say that the answer we get is, instead of me writing it out, we get P1 was selected by 2 people, P2 was selected, P2 was selected by 3 people, and P3 was selected by 5 people. Now, the most common answer in this scenario is P3. So this is what we try to understand using mode, which is the most popular. So if you're trying to figure out which product is more popular, what movie is the most popular among your friends, what kind of movies are most popular among your friends, what kinds of songs do a people of a particular country like, what kind of movies, songs, what kind of people, what kind of things, what kind of food, what kind of cuisine. These are the kind of things that mode helps us answer. So mode is very useful when you're trying to figure out most popular among a data set. Let's move on. So now that we know mode, the next thing we need to understand is median. So median is the middle of the data. So when I say middle, I mean if we are to lay out the entire result that we have in ascending order, median is the middle of our data. What does the middle or the value at the dead center tell us? So if the data is arranged in ascending order, then the data element that occurs right at the center is the median. So let me just show you. Let's say that instead of this, I have a particular group of people, right? And I want to calculate the these people are arranged in the number of years of experience. So let me just write it, years of experience. And let's say that we have a data set that looks like this, 9 and 10. This is what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the years of experience of people. 10 employees, all of them ranging from 1 to first employee has 1 years of experience, second 2, 3, 4. This is all arranged in ascending order. If you don't have that in ascending order, you can arrange it yourself. It's perfectly reasonable. It's like sorting a list. It's easy to do. And now let's say that I want to find the median of the data. To find the median of the data, what I can do is I can, for instance, take the middle value. So there are 10 values. I need to take the fifth value. But since this is an even number of results, I can't just take the fifth value, because if I take the fifth value, which is this one, there are 4 values on top and 5 values, 1, 2, 3, 4. Oh yeah, so that would be a problem. So for me to do that, 1, 2, 3, 4, 5 values at the bottom, that would not be an accurate mean. The accurate mean would be the average of the two values. Now, if I take the average of 5 and 6, I will have to do 5 plus 6 divided by 2, which is 11 by 2, which is 5.5. And that is our median. That's the median that we get by choosing these two values. So we have 4 values above the median, 4 values below the median, and this average is 5.5. Now if I didn't have that, if I only had odd number of values, that is 9, 7, 3, something like this, then I can easily take the middle value, which is the fifth value. 4 values on top, 4 values on bottom. So that way we can distribute our data and understand what is the median of the data. Now, as you already know, that mode is useful for, yeah, so we're trying to find out the most popular thing in our data set. So median is used to, it's not extremely useful, but it's useful in very specific use cases. When we're trying to find out the middle value of, we're trying to find out the median or the middle value in a group of things. So here it tells us that the median, you've heard of median salary, you've heard of median household prices. So these are the kind of things that we calculate using median. So median tells us the middle value. Now we can compare them and contrast them to the end values and find out what is the how the distribution is. So to give you an example, let's say that I have 2, 3, 4, 5, and then that's 10, 15, 18, 25. Now the median value is 5 and the value at the end is 25. So we can compare and contrast that there are some people that there's a disparity between the number of people that have particular years of experience, and this is the kind of thing that median is useful for. Now median isn't extremely useful. We don't use it for a lot of things. As you can see, it has a very niche use case, very particular use case. So we don't use median that much. And then comes something that we use a lot of times, mean. Mean is something that you must have all come across. It's a very popular statistical analysis tool. We all use mean in our daily life, even if we don't call it mean. So mean is basically the average of the data, or in simpler terms, it's the sum of all the values divided by the total number of values. It's presented, and it's called the Greek letter sigma is used to represent the summation of all that. So let me tell you how to do this. Let's say we have this, and I wanted to calculate the mean of the value, right? So I had 2, 2, 3, 4, 5, 6, 4, 2. So this is what we have. Now I don't need to arrange it in ascending order to calculate the mean. Let's say that this is the years of experience in a new startup. So I get 2 plus 2 is 4, plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 20, plus 4 24, and finally 26. So we have the cumulative sum is 26. Now we have 8 values. So if I wanted to calculate what does the mean of my data is, I need to firstly calculate the sum of the entire data set, which I have calculated to be 26, and the number of records I have is 8. So 26 divided by 8 is 3.25. So I get the mean of my data is 26 divided by 8, which is equals to 3.25. Mean is the average. We calculate average on a daily basis. We calculate the average income of a particular group of people, the average income in our household, the average incentive we get, the average tip we leave. There's the average annual income of a particular substrata of a person, of a group in a country. We calculate averages on a daily basis. What is our average expenditure? How much do we spend in our entire month? So to give you an example, let's say this is the most common thing you can understand. Let's say that you spend this many thousands of rupees per month. Let's say 12, 14, 15, 18, 10, 8, 5, 18, 15, 14, 12, 10. Let's say that these are the expenditures of yours on a monthly basis in thousands. So you get 12 plus 14 would be 26, plus 15 would be 26, plus 10 is 36, 36 plus 5 is 41, plus 18 would be 41, 51, 61, 59. Then plus 10 is 69, plus 8 would be 78, plus 5 would be 83, plus 18 would be, let's say that the calculation of all of this is done and the average is coming across 150, right? Let's just skip the calculation for now. We get 150, and now we want to calculate the average that you spend on a monthly basis. So what you can do is you can just divide it by 12. So what we're trying to do is we're trying to calculate the average. So we divide 150 by 12, and what we get is 12.5. So the answer would be you spend 12.5 thousand per month on an average. And then you can take a look at the data and you can understand, okay, so this is fine, this is fine, this is fine. In the fourth month of April, you spent way more than your average. In the other months, you're spending somewhere across it. In the sixth and seventh month, you spent really less, and then you can take a look at the influences that that month had. Maybe it was some party, maybe it was your birthday, and you spent a lot of money. So you can do these kinds of statistical analysis to understand where how do you spend the money, how does your expenditure goes, which month influences the majority of your expenses, which month influences the least of your expenses, and why is it so low in particular month and not in some other month. So it's very useful in those scenarios. Now, mean are of two types. First is the trimmed mean, second is the weighted mean. We'll take a look at them one by one. Let's take a look at trimmed mean. So trimmed mean is used to deal with outliers, data that is so far from what you do, one particular data that is really has a really high value that is influencing the mean of your data. So let's take a look at that. So to understand what trimmed mean is, firstly we remove some data from both the ends to get rid of the outliers. So let's take a look at that. Here we have our data set. Let's say that we get the same data set back, but let's say in the last 2 months, instead of 12 and 10, let me just get a new data set. So let's say that you spend less, you spend 5, 6, 7, 5, 5, 5, 6, 7, 9, and in the 6, 7, and the last 2 months you spend really high, let's say 20 and 25. Now, if I were to calculate the mean, let us just calculate it one by one. 5 plus 6 is 11, plus 7 is 18, plus 5 is 23, plus 5 is 28, plus 5 is 33, plus 6 is 39, plus 7 is 46, plus 9 is 55, 61, and now we add 20 to it, we get 81. Now we add 25 to it, so we get 106. If we calculate the average or the mean of this, we would have to calculate it by 106 divided by 12, which is 8.83. So 106 divided by 12, which is equal to 8.83. Now that's the mean, but as we can see that the last two values, they are really high. Maybe this was just some sort of an anomaly that these months you needed to spend really more because you were traveling some other places, or you needed to shift your house from one location to another, and that's why it cost you so much. So Let's say that this is just one time anomaly and this is not happening again and again. So, but this is a large data set and you don't know whether that's the case, and this is influencing your data really, really badly. So to get the mean, what you can do is you can take off the first two values and take off the last two values as well, and you get only this data. So if I were to take this here and then calculate it, 7 plus 5, what is 7 plus 5? It is 12, plus 5, 17, plus 5, 22, plus 6, 28, plus 7 would be 35, plus 9 would be 44, and plus 6 would be 50. So here, when you take a look at the average, it's 50 divided by, and what we have here is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 values, and the calculation when we do it, we have 50, which is the sum. So 50 divided by 8 is going to be equal to 6.25. So that's the mean that that we're supposed to have. The reason that we are getting 8.83 is because some expenditures are really high. So instead of it being 6.25, we are getting 2 point some value more than this, 2.5 thousand more than this, which is really, really high. So why did we scrape off the first two and the last two values here? Now, this is a little difficult to understand. So what we're doing is we're getting the first two values, we're getting the last two values, and we're scraping it off mainly because the outliers don't need to be right at the bottom. They could also be at the top, and we want to just make sure that we're getting the center of our data. So let's say that instead of 5,000, it was 1 and it was 1. Now this could also negatively impact your data. So in order to get rid of that, what we do is we remove this, and what we get is 6.25, which is the correct value. Let me just remove all of this. Hopefully this was easy to understand, and let's move on to the next one, which is weighted mean. Now weighted mean is used to calculate mean of certain values where a certain value is supposed to have more importance or more value or more weight. Now it's used to calculate certain values that are supposed to count more in some context. Let's say that we're calculating the average of a grade of a student based on the grade distribution. Now this is something that is done using weighted mean. Let me give you an example. So I prepared an example before so that I don't mess it up. Let's say that you have 3 quizzes in your entire academic year. The first quiz covers 10% of the syllabus, the second quiz covers 20% of the syllabus, and the third quiz covers 70% of the syllabus. Now, and then there's the final quiz, that's the final exam, we're not calculating that. Now what we're doing is we're getting these 3 values. Let's say that the weight of, you get whatever marks you get for the first quiz, you get the 10% of that mark. Whatever marks you get for 20% in your final grade, it would count as the 20% of your final grade. And whatever marks you get in the third quiz, the 70% of it would be calculated for your final grade. So if you were to get these marks out of 5, or let's say out of 4 or whatever, out of 5 of your average grade, then you will be getting 3.5 divided by 3 plus 3.5 plus 4, and 7 plus 3.5 divided by 3, which will get around 3.5, which is considered to be your average grade. Now we know that that is not the case because we have not taken these weights into account. We have not taken 10%, 20%, and 70% into account. So if we were to do 10% here, what we do is we take 10, we divide it by 100, which is the 10%, and then we multiply it by 4, we get 0.4. So out of 1 you got 0.4. So then you get 3.5, and then you get 3, and out of that you got 3.2. That's your average grade, not 3.5. So this is where weighted mean comes into play. This is not the only case that this is there. We can also take a look at other things like calculating the increment of a person based on the years of experience they have and many other factors. Many other variables come into place when we try to understand the averages of particular groups. So this is where weighted means come into play. And again, these have really specific use cases. So you need to take care of whether you to use weighted mean, to use trimmed mean, or very mean, mode, or median, depending on what you're trying to get. Mean is useful for calculating simpler means. If you have outliers in your data, you can use trimmed means. And if you want to calculate mean by giving certain values certain more value. If there are certain data points that are more valuable than others, then you use weighted. So now let's take a look at variation, or variation in our data to be more specific. So what is variation? Well, variation in statistics is used to show how data is dispersed or spread out in our data set. So several measures of variations are used in statistics, but variation is mostly used to calculate if we have a center of our data, if we have calculated the central tendencies, the mean, mode, and median, then how far away is our data points from the one that we have? How much is the variation? For instance, if we have a data set that most of its values are 4, then the variation is not that much because most of the data is 4 and the other values that we have are 3 and 5. So the data is quite compressed. So it's not extremely spread out if we consider it on a number line. On the other hand, if we have data set from 1 to 10,000 and every number has a value of 1, 5, 7, 4, 3, then it's very spread out. There's an extreme amount of variation. It's difficult to get sense of data like this. However, we don't get a data set which has that massive of a variation. We usually get data set that's a little more compressed. So let's take a look at how or what are the kinds of measures that we can take to understand the variation in our data set. So we have range, we have quartiles, and we have variance. Range, quartiles, and variance are a few of the ways that we can take a look at to understand the variation in our data. So quartiles are also known as quantiles. So if you come across this terminology, then don't be confused. They mean the same thing. We have range and we have variance. Let's take a look at them one by one. These are important concepts to understand once you're trying to interpret the data and understand how dispersed the data is, how different the data is, what's the variation, what's the variance, how much different is it from the mean that we have, how far away is one data point, or how likely one data point is to be far away from the mean of the data or the center of the data. Let's take a look at range first. Range, as the name suggests, is quite easy to understand. Range is the difference between the highest and the lowest value in our dataset. Range tells us the difference between the lowest and the highest value in our dataset. So let's take a look at that, because sometimes people get confused with what range means. Let's say this is the data and we have 5, 10, 12, 11, 2, 5, 1. Let's say it's 10, 11, and 15. So this is the data that we have. Now to do that, firstly we have to calculate the minimum and the maximum value. This is easy enough. You just go from top to bottom calculating the minimum and the maximum. Right now both are 5. Maximum is 10, minimum is 5. You keep going and you find minimum is 5 and maximum is 10. So when I ask people, maximum is 15. So when I ask people what the range of this data set is, many people get confused and they tell us the range is from 5 to 15. Now, if you are taking the word range quite literally, then this is exactly what it means. 5 to 15 ranges between the values of 5 to 15. However, in statistical sense, this does not make a lot of sense. So in statistical analysis, the way we do it is we go 15 minus 5, maximum minus minimum, highest value minus the lowest value, and we get 10. So this is the data that we have, and this is the range that we have, 10. So this is what we have. This is the range of our data. Now, as you can see, range isn't the most optimum way of doing it, or finding the deviation, or finding the spread or disperseness of our data, mainly because if the data has outliers, then range gets skewed quite easily. We have 15. Now, if I want to calculate the range of a data set that has 95, now the range of our data is, it looks like 5 minus 95, which is 90. So you would think that the data, whatever the starting point of the data is, it would have values ranging from the starting point plus 90. So if starting point is 5, which is the lowest value, plus 90 is 95. However, majority of our data lies between 0 and 12, 0 to 15, let's say. And only one data point, which is the outlier, is 95. So this could negatively impact our data really badly. So this is why range is useful, but once we make sure that the outliers are not there and the data is completely standardized, which is a little difficult to do. However, range is still useful for smaller data sets like the one we are seeing here. Now the question comes, that what does range tell us? Well, it tells us the width of our data. It tells us quite literally the range, the width of our data, how many, what is the range, what is the dispersedness of our data. So if we have a data set that has higher number of variations, let's say that I have 1 million records, but all the values range from 5 to 25. Yeah, Excel is causing some issues here. Never mind. So you get 5 to 25, right? 5 to 25. I don't think it was. Yeah. So let's say that this is the range that I get. So 10 million record, 10,000. Let's say 10,000 records, and the range is from 5 to 25. So you can easily understand that this data set is really concise, it's really clustered. So the range is quite small, range is 20, 25 minus 5 is 20. Now again, if we had the same thing, but the range was not from 5 to 25, it was from 5 to 5,500. This is a problematic thing because now our range becomes from 5,495. This is our range now. So as you can see, here the data set is quite dispersed. Assuming that these are not outliers, 5 to 55,000 are normal range of numbers, and numbers are equally distributed across this range. Then we have a really wide variety of data set, and it's got a really large set of variation. But here we only have 20 value. We have only the width of 20. Here we have massive width. It's 10, even more than 20, or 20 times more than what we have here. That's a problem. So we need to understand why we use something like this. It's because we needed to take a look at what's the variation, and this is only good. This is a really simplistic measure, but it guides us in the right direction. So that's why we use it. So let's move it to the next direction. We look at percentiles. Now, to be quite honest, percentiles are not really something that we use to calculate the range of the data, but there's when we are moving on to quantiles or quartiles, there we use percentiles. So it's important to explore what percentiles mean. If you're studying in a university, if you've studied in any sort of university, you've gotten a percentile score sooner or later. You come across this score in your schools as well, or especially in colleges and universities, the percentiles are used. Or if you want to take a look at percentiles used at other competitive exams as well, so that's where they are used. Now, percentiles are scores that are used to describe the value below which some observations fall. Now, that's a very vague definition, but it's quite accurate. I'll explain to you in a moment using an example, but to understand it right now, just take a look at the example that we have in the text format. If X is the 70th percentile, let's say that you are a person who's gotten a result, and at the bottom of your result, it says, congratulations, you've achieved the 70th percentile. That means that 70% of the other data points, you could think of it as 70% of the other students who took the same test that you did were below you. So you are above 70% of all the people that you took the test with. So to give you an example, let's say out of 100 you scored 95. Now, when you hear the word out of 100, many people think that out of 100 I scored 95. That means I got 95%, which is correct. But then they think they got 95th percentile as well. Now that is incorrect, mainly because it doesn't matter what the score is or how much you got it from. What we're trying to calculate here is not what the percentage is. That's what we use the percentage for. In the percentile, we're taking a look at how many people you've gotten more numbers from. So let's say that there are 100 students in your class and you got the 5th rank. That means or you can say you got the 4th rank. That means from rank 1 to 95 are below you, so you've got the 96th percentile. 95 people are below you. That's what percentiles mean. Percentiles are used to calculate how better are you compared to the rest of the people in the sample. Rest of the data points in the sample is you or rest of people, depending on what the data is all about. If you have a drug or you have a potential vaccine, and we take a look at how many people have, let's say there are 5 vaccines, and since there are 5 vaccines and you have one vaccine that scored the 4th highest, so If you take a look at it, that means that you are 80% in the 80th percentile. 5 people or 80% of other records are below you. So that's what this means. Depending on what data that you have, you can take a look at percentiles. You can understand what that means. But this is what percentiles are useful for. Now, why are we learning percentiles if they're not a part of calculating the variation or variance in the data? Mainly because it's not just percentiles that are useful, but we use quartiles. Quartiles are extremely useful. Ask any statistician that you can come across. Quartiles are used on a daily basis. So let's try and understand what quartiles are, and we'll take a look at a few examples along the way as well. So quartiles are used to break the data into 4 parts, so as to better find the spread of the data in a way that is not that influenced by outliers. So if you have some data and you're afraid that outliers might skew your data, what you can do is you can choose a quartile method that will tell you approximate answers. And you've already calculated one of the 3 quartiles that we calculate, and I'll show you what that means in a moment. Let's take a look at that. So quartiles are used to calculate the, firstly, there are 3 quartiles. Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Quartile 2 or Q2 is the 50th percentile. Just calculate it. The quartile 3 is the 75th percentile, and quartile 1 or Q1 is the 25th percentile, right? So now the question comes, what does that mean? Let me show you with an example. Let's say that we are calculating height of people in centimeters, right? So we are arranging that in a format. So let me just take it away from here, paste it here. This is just for our reference. Let's say 144, 155, 156, 157, 158, 159, 160, 167, 170, 171, 172. Let me just remove these two. So let's say that there are 9 records and we want the 50th percentile. 50th percentile would mean that 50% of the data is both above and below it, and we're right there. So in this scenario, 50th percentile, as you can, if you try to think about it, it's the median of the data. This is what I meant when I said that you have already calculated the one of the quartiles. So when we're trying to calculate the 50th quartile, what we're trying to do is, firstly, we have arranged it in ascending order. We take all the records, we take a look at the number of records. We have 9. Right in the middle would be this, and this is the 50th percentile. So Q2 lies here. Now, as you can see, we have 4 records below, which is approximately 50% of the records below our percentile. So that's what this means. So this is what Q2 is. Q2 is the second quartile. Now, how do you calculate the first and the second quartile? We can do it like this. Now, let's take a look at this. Don't think about this range. Just think that this is removed like this. And we're trying to calculate the quartile in this range. Okay.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit Intellipaat.com.
So in the range from 0 to 4 above the first quartile, the way we calculate it is we take a look at the number of records. It's an even number of records, which is 4. 4 divided by 2 is 2. These are the 2 records that are in the middle. Now we can't just choose one for the quartile. Instead of calculating the median, the quartile is considered to be between these two. So these 2 values are considered to be a part of the first quartile, not the third quartile, but the first quartile. Similarly, these 2 are considered to be part of the third quartile. So the third quartile lies here, second quartile lies here, first quartile lies here. So now if we are to understand what quartiles are, they are a way for us to understand our data more. You can think of it as range, but a little more subservient to outliers. So we don't have to worry about outliers that much. This is the third quartile, this is the second quartile, and this is the third quartile. We get three data points and we understand which one is used for what. Now the question becomes, what happens if we have an even number of data? So let's say I will paste this here. Let me just remove the quartiles. And now we have to calculate the second quartile. So we have 2, 3, 4, 5. So these two will be part of our second quartiles now because we have even number of data. And this is, if you want to calculate the median, then sum them up and then divide them by 2, it would be 159.5. So this is the second quartile. The first quartile would be 1, 2, 3, 4, 5. And so first quartile would be here. And the third quartile would be here. We just take a look at the numbers between them and find its median. We find the numbers above the second quartile, we find its median. That's the first quartile, that's the third quartile. That's what we mean by quartiles. So that's how quartiles are calculated. They are easy to calculate. They give us a better indication of how our data is spread out. Much better than range. They are less prone to outliers. Unless your data is so dispersed that outliers are really easy to catch, then that's a problem. Now that we're done with quartiles, now quartiles are expressed in percentiles. So first quartile is the 25th percentile, which we have already seen. Second quartile is the 50th percentile, which is also the median, which we just saw. And the third quartile is the 75th percentile. So again, let's take a look at the data to make sure that we understand it correctly. 75% of the data is above this. 50% of the data is below this, 50% of the data is above this, and 75% of the data or 25% of the data is above this. So that's how we calculate quartiles, and that's why percentiles are useful when understanding quartiles. Now let's take a look at interquartile range. So we had range before, but it was very easy to get influenced with by outliers. So the range was very much influenced by the outliers, but interquartile range is a little different. Let's take a look. Interquartile range is the difference between the lower and the upper quartile, that is Q3 minus Q1. This gives us a better idea of the range of the data. So this helps us understand how our data is spread out, and it's not that influenced by the outliers. So if we have this, we get this. Now we have 170 as the third quartile. We have 156 as the first quartile. So if I had to calculate the interquartile range, I would just do 170 minus 156. So 166 and 4, 14, and we have 14 as our interquartile range. So this is how much our data is spread out between our quartiles. If this is a massive difference, then our data is really spread out, and if it's not a massive difference, then it's not that massively spread out. That's the first thing. Now, many people think that median could be used to do the same thing. That's not really the case. We're trying to look at the extreme ends of our quartiles and find the distance between them. That's what tells us how spread out our data is. If this was a large data set and the quartile was 140, then we could probably understand that our data set is very widely spread out, or more widely spread out than it was when it had 14 as its interquartile range. So it's a really good measurement, but it's less influenced by outliers. Outliers are really the things that we need to watch out for when we're trying to calculate range of any sort, whether it's the interquartile range or the simple range. This is why we use percentiles, because percentiles are not that influenced by interquartile ranges. They help us understand what we're trying to do, and they give us a more accurate representation of the data that we have at our hand. If we were not using percentiles, then our range would be 144 minus 170, and since there are no outliers, it's fine. But let's say the outlier was 198, or even not 198, 222, or let's say some crazy number, 568. Now, even though there's an outlier, my range is perfectly fine. Let's say that the outlier here was 14. So it could be because of incorrect measurement. It could be that generally is an exceptional case in our data set. So that could be it. That's our data set. That's what interquartile ranges are all about.
So let's start with, what exactly is Panda? Well, Panda is an open source, simple and powerful Python library which is mainly used for data manipulation and data analysis. Okay, now you might be wondering, where does this name Panda come from? So what do you think? Is the name of an animal? Is it? Wrong. The name panda is derived from the word panel data. Okay. Now what is panel data? Well, this is our panel data. It's a multi-dimensional data involving measurements over time. Okay. So it consists of various attributes with different attribute value. Okay. So this is how the name panda came from the word panel data. Okay. Now the question arises, who created Pandas? Well, Pandas was created by an American software developer and a businessman named Wes McKinney in the year 2015. Okay, so this is the guy who created Pandas. Now let's move ahead and see some of the features of Panda. So on number one we have is series object and data frame. Well, this is the primary and one of the most important features of Panda. It allows it to deal with one-dimensional and two-dimensional label data in the form of series object and data frame. Don't worry, we'll discuss about them in detail later in our session. Okay. Next on number two we have is handling of missing data. Well, whenever you have a missing data, Panda represents it as NaN. Okay, so this is how Panda easily handles the missing data. Well, no matter where your data is a floating point data or it's a non-floating point data, Panda handles the missing data very easily by representing the missing data as NaN. Okay, next feature is data alignment. Well, this says that the object can be explicitly aligned to a set of labels, or the user can simply ignore the label and let series, data frames, etc. automatically align the data for you in computations. Okay. Next point we have is group by functionality. Well, this is a very powerful and flexible function provided by Pandas. It is used to perform split, apply, and combine operations on data for both aggregating and transforming the data. Okay. Next on number 5 we have is slicing, indexing and subsetting. Well, using Pandas, you can perform intelligent label-based slicing, fancy indexing and subsetting large datasets. So we'll see in this module how we can perform all these functions using Pandas. Okay. Let's see some more features of Panda. Next we have is merging and joining. Well, using Panda, you can perform both merging and joining operations on your dataset. Okay. Next is reshaping. Well, you can easily reshape your data and pivot your data points using Pandas. Okay. Next is hierarchical labeling of axes. Well, this hierarchical labeling of axes allows you to have multiple labels per tick, and this can be done using Pandas. Next is robust input-output tool. Well, Panda is a robust input-output tool for loading data from flat files including CSV and delimited files, from flat files like CSV or Excel files, databases, and saving or loading data from the ultra-fast HDF5 format. Okay. And finally, the last feature that we have is time series specific functionality. Well, this time series specific functionality include date range generation, frequency conversion, moving window statistics, moving window linear regression, date shifting, lagging, etc. So all these types of function can be performed in time series using Panda. Okay, so these were some of the features of Panda. Now let's move ahead and compare Panda with NumPy. So you might be thinking there are so many functions and features that make Pandas and NumPy quite similar. But what exactly is the reason that we are preferring Panda while dealing with some of the data then? Let's discuss that with the help of a comparison between Panda and NumPy. So the first point that we have is Panda works better with NumPy while dealing with data which has more than 500,000 rows. Okay, and when you are using NumPy, so it performs better for 50,000 rows or less. Okay, so in working with large real-world data, you would need Panda for computation. Okay. Next we have is Panda series object is more flexible as you can use it to define your own label index to index and access elements of an array. On the other hand, element and NumPy arrays are accessed by their default integer position. Correct? So this is how Panda is different from NumPy. So now that you know how Panda differ from NumPy, next we'll see how we can import Pandas in Python. So for that we have a command import pandas as pd. That's it. Okay. Next is what kind of data does suit Pandas the most? So we have tabular data, time series data, and arbitrary matrix data. All of these kind of data you can feed it to the Pandas. So now that we have learned the history, features, and how to import Panda, let us dive deep and see what kind of data suits Pandas the most. So it deals with tabular data with heterogeneously typed columns as an SQL table or Excel spreadsheet. You can also work with ordered and unordered time series data. And it also helps you to work on arbitrary matrix data with rows and column labels. Okay. Let's see what are the different types of data set in Pandas. So we have one-dimensional and multi-dimensional data. So you can work on one-dimensional, two-dimensional, or any multi-dimensional dataset in Pandas. If you are working on a one-dimensional dataset, it's known as a series object. If you are working on a two-dimensional, the Panda will create a data frame for it. If you are working on more than two-dimensional data, Panda would create a panel data for it. Okay. Now you might be wondering what are these terminologies, right? So let's have a look at them one by one. So for this session, we'll be mainly focusing on series object. So what exactly is the series object? Well, a series object in Panda is a one-labeled array which is capable of holding any data type like integers, strings, floating point number, Python object, etc. Okay, it can contain data of similar or any mixed data type. You can also say that a series in Panda is quite similar to a list or an array in Python, but yet it's more powerful. It represents a series of both numeric and non-numeric values as a column of data containing any type of mixed data. So you must remember the fact that a series can contain any type of data even if it's of a mixed data type. Okay. Now let's see how we can create a series object in Pandas. So here in this example, we have a list of numeric data stored in data. Okay. And now we want to create a series object out of it. So for this, Panda has a function series with capital S. So here we are calling that function using pd.series of data. Okay. And storing it in a variable or a series object name series1. If you print it, you'll notice that in the output you have one-dimensional array labeled as 0, 1, 2 and 3. Let's make it more clear using my Jupyter notebook. First topic is series object in Pandas. So the very first thing that I'll be doing up here is importing my Pandas library. So import Pandas as pd. Next, I need to define the list of the data. So let's say data equal 1, 2, 3 and 4. Fine. Now I want to create a series object out of this one-dimensional data. So how will I do that? For that, let's define a series object name. Let's say it's series1. So series1 equal pd.series. Make sure you are using capital S, not small. Series, and inside that pass data. Okay. Now if you print your series1, you will see that you have one-dimensional array of 1, 2, 3 and 4 which are labeled as 0, 1, 2, 3. Okay. So this was about series object in Panda. So let's move ahead. Next is how to check the type. Now what if I want to check if it is a series object or not? So you can do it simply by typing the command type and inside that pass the name of the object. So here we have passed series1 as the name of the object. Let's check it in our Jupyter notebook, what it has to say. So in order to check the type, all you have to do is mention type and inside this write the name of the series object, which is here series1. So if you execute it, you'll get the output as pandas.core.series.series. So definitely it's a series object. Okay. Now coming back to our PPT. Next topic is how to change the index name. Now what if I want to change the index name from 0, 1, 2, 3 to ABCD? So how will I do it? So let's see. So for that, all you have to do is add a new parameter index over there and define the index inside it. That's it. Let's see how. So what we are doing up here, changing the index of a series object. Okay. So I don't want to write the entire code. So let's just copy this thing. And all you need to do is specify index parameter over here. So index equal inside this. Let's say first is A, next is B, next is C, and the last one D. Okay. And now if you execute series1, you'll see that the index name is changed. So here we had index name as 0, 1, 2, 3, which here changed to ABCD. Or customize index name. Okay, so I hope this thing is clear to you. Well, next is create different series object data type. Well, Pandas is not just about the list. You can use different arrays, you can use dictionary over there, or you can use any scalar or any constant value to create a series object out of it. Okay, I hope the concept of series object is clear to you. Well, as I told you earlier, in Pandas, two-dimensional data is found in the form of data frames. So now the question arises, what exactly is a data frame? Well, a data frame is a two-dimensional label data with columns which can contain data of different types. Correct? Let me show you an example. So here in this example, you can see we have a two-dimensional data with the column label on the x-axis and the index on the y-axis, correct? So this is an example of a data frame. So now that you know what exactly is a data frame, let's move ahead and see what are the different features of a data frame. So a data frame contains column of different type. We can even change the size of a data frame as it is mutable. You can even have data access labeled, and you can also perform various arithmetic operations on rows and columns. So these are the various features of a data frame. So now that you know what exactly is a data frame, let's see how to create one. So you can create a data frame using this command, pd.dataframe, and inside that mention the data. Okay. Let me just open my Jupyter notebook and show you how exactly it is created. So this is my Jupyter notebook, and this is where we left in our previous session. So today we'll learn how to create a data frame. Okay. Let me just change it to Markdown. So again, in order to create a data frame, the very first thing that you'll be doing is importing the Panda library. So import Pandas. Let's say I want to import Pandas as PD. I don't want to use the name Pandas again and again. Okay. So now that I have imported my library, let me just define some data. So let's say data equal 1, 2, 3, 4, 5. Okay. And now I want to create a data frame. So let's say df equal pd dot data frame, and inside that what I need to pass is the data. In this, make sure that your D and F is capitalized. Okay. And let's print the data frame. Let's see what is the output. Okay, so here we got the output of data frame. So as you can see, on our x-axis we got the label as 0, and on the y-axis we got the index as 0, 1, 2, 3 and 4. Okay, so there's a simple example of a data frame. So this data frame was created using list. So let me just add this, creating a data frame using a list. Okay. So next what I'll do, I'll show you an example of creating a data frame using a dictionary. Okay, so let's define our dictionary. So let's say my dictionary equals, inside this I'll write fruits, and my fruits consist of array of different fruits like apples, banana and mango. So let's add one more key value to it. So let's say I'm adding count. So count equal, I have 10 apples, 20 bananas and let's say 15 mangoes. So here I have defined my dictionary. Now I need to create a data frame out of it. So let's say data frame equal panda pd dot data frame dnf capital, and inside this I'll pass my dictionary, and let's print it out. So as you can see here, we got a data frame with the labels as fruits and count, and the index over here as 0, 1 and 2. Okay, so this is how we create a data frame using a dictionary. So now that you know how to create a data frame using a list and a dictionary, now let me show you how you can create a series. Well, the series is the same which we learned in our previous session. It's a one-dimensional labeled array which is capable of holding data of any type. You can have any integer, string, float or any kind of value in it. Okay, let me show you how you can do it. So here what we are doing, so here we are creating a data frame using a series. Okay, so let's define our series. Let's say series equal pd dot series. Inside this, let's say I have 6, 12, and also let me specify the index. So let's say index equal a, b. So there's my one-dimensional array with its defined index. Okay, now I want to create a data frame out of a series. So how will I do it? So let's see. So df equal pd dot data frame with dnf capital, and inside this I'll pass the series. Okay, now let's just print it. So as you can see here, we got this output. So here our one-dimensional series got converted to two-dimensional data frame with index as a and b. Okay, so now that you know how to create a data frame using a series, next we'll see how we can create a data frame out of a NumPy array. Okay, so let's see how. So here, creating data frame using a NumPy array. Okay, so here the very first thing that I'll do is import my NumPy library. So import NumPy as np. Since I have already imported pandas up there, so I don't need to import it again. So after importing the libraries, next what I'll do, I'll define my NumPy array. So let's say my NumPy array equals np.array, and inside this let's have some salary value like 50,000, 60,000. Let's say these are the salary of employee whose names are, let's say, John and James. Okay, so now that I have defined my NumPy array, let me just create a data frame out of it. So data frame df equal pd dot data frame. So let's add the name of the employees over here. So name, and this will fetch data from NumPy array with cell first cell. Okay, and next let's define salary. So salary will fetch data from NumPy array 0th index, right? So my data frame is created. Now let's just print it, execute it. Data type not understood. Okay, so I've missed this opening and closing square bracket over here. That's why I'm getting this error. Let's execute it. Okay, that's resolved. So here you have just created a data frame out of a NumPy array with column name as name, salary, and here's the index numbers 0 and 1. Okay, so moving on ahead, our session will be on merge, join, and concatenate operations that can be done on the data frame. You will see how you can perform merge operation on two different data frames using pandas, how you can perform join operation between them, and how you can perform concatenation between them. Okay, so without delaying any further, let me just switch back to my Jupyter notebook and let me show you how you can perform these operations. So here's my Jupyter notebook, the way we left it in our last session. So today what we are going to do, today we are going to see how to perform a merge operation between two data frame. Okay, so for this, the very first thing that I need to do is create my data frames. So first of all, let's import the libraries. So import pandas as pd. I'll be needing this library only. And now let me just define two data frames. Now once I've imported the library, so next thing I'll do is define few lists over here. So let's say player equal player 1, player 2, and player 3. Okay, next let's define a list of points. So point equal, let's say 8, 9, 6. Okay, let's also add a list of title to it. So title equal game 1, game 2, and game 3. So now that I have defined three lists over here, I need to create a data frame out of it. So let's say my first data frame equal pd dot data frame, and inside this let's create a dictionary. Let's add a label, let's say player, and this player contains all the values from my list of player. Okay, comma points, and this points consist of all the values from the point list, and the title which consists of all the values from the title list. So I have created my data frame over here. So let's just print it. So this is my data frame which I just created. So one of the data frame is ready. Now let's define another data frame. For this we'll be needing different list. So let's say here player equal player 1, player 5, and player 6. Let's define another list as par. So par equal punch, kick, and elbow. Fine. Next I'll define a list of title. So here title equal player is from the game 1. Next is this one from the, let's say, game 5, and this one from game 6. Okay, here all our lists are ready. Now let's create a data frame for it. So here df2, that is second data frame, equal pd dot data frame. So inside this, let's define our dictionary. Say column name is player, which consists of the values from player list. Next is par. So my next column is which consists of the values from par list. And the next is title, again which consists of the values from title list. So there's my second data frame. Let me just print it. So here my second data frame is also ready. So this one is my first data frame and this one is my second data frame. So now that our data frame is ready, so the very first thing I'll be performing on it is inner merge. So what exactly is this inner merge? Well, the result of this inner merge would be that it will return you the row which is common in both the data frame on the basis of any key value. So let's have a look at our data frames. Any common value over here, like any common column you can say. So we have player and title in both our data frame, right? So we can perform the inner merge using any of these two columns, either player or title. Let me show you how. So let's say I want to merge my data frame 1 with data frame 2. So I'll write data frame 1 dot merge with what? Data frame 2. Okay. And on the basis of what? You have to specify your key value over here. So on, let's say I want on the base of title. Okay. And how I want to merge them? So how equals inner. So this will give you the inner join. So we got this result over here. So here player underscore x represents that this attribute is from data frame 1 and player underscore y represents that this attribute is from the data frame 2. Okay. So why did we got just one value over here? Let's explore it. So on the base of title, so we are merging on the base of title. So what are the common values in it? As inner merge give you the common set of values in both the data frame on the base of what attribute you are choosing. So as we have chosen title over here, so common attribute is game 1. So only game 1 is common, right? So whatever values are associated with game 1, you got that. Okay. If I change the value of title to player, let's see what's the difference. So here I got the value of player 1 as player 1 was only common in both the data frame, right? So here player did not get split into player underscore x or player underscore y. So instead of that, title got splitted up to title underscore x and title underscore y. Okay. So here title underscore x is game 1 and title underscore y is also game 1. So this is how we perform an inner join on two data frames. So just to tell you, by default, if you merge two data frame, it will perform an inner join. Okay, see. So this was all about inner merge. Now let's move ahead and see how you can perform left merge. So even performing left merge is quite similar to the one which you performed in inner merge. Just have to write data frame 1 dot merge data frame 2 on player, and instead of this inner you have to mention left. That's it. So in case of left merge, both of the table would be merged together, but in this case all the values from table 1 would be there. So our table 1 has, or the data frame 1 had player 1, player 2 and player 3, right? So all these values are over here, and apart from it, what else you will get? You will get all the values from second data frame, and here you will get all the common values from your second data frame. So here my player 1 was in both the data frame, right? So it merged both the table and it showed me these values over here, punch and game 1, right? But for player 2 and player 3, they were not in the second data frame, right? So that's why Panda was not able to identify what value should it give in par and title. So that is why it mentioned NaN over here. Okay, so this is how you perform a left merge. Now next, let's see how to do a right merge. So again, you don't have to do anything, just change left to right. So left becomes right. So you got this value. So why I'm getting this value? So similar to left merge, now it's performing right merge. So all the values from your right table would be here. Okay, so player 1, 5, 6. I'm getting all the values from my right table or right data frame or second data frame, right? So 1, 5, 6 are over here. 1, 5, 6, punch, kick, elbow, and game 1, game 5 and game 6. And apart from it, what are the common values from the left data frame, right? So from our first data frame, we got this value as player 1 was common in both of them, correct? And apart from it, we didn't had any value for player 5 or player 6. That is why we got NaN, NaN, NaN and NaN values over here. So this was about the right merge. Now next is how to perform an outer merge. Let's see. Outer merge. So here all you have to do is change this to outer. Execute it. So in this case you will get all the values, and wherever the value is not common you will get NaN over there. Okay. So this was about the outer merge. So guys, this was all about the merge. Now next, let's move ahead and learn about the join operation using Panda. There's a slight difference between the merge and join in case of Panda. Let me tell you what. In case of merge, the two data frames were getting merged on the base of their attribute name or the column name, right? So it's a must that both the data frame must contain at least one common attribute name, right? But this is not the case in join. It's a bit different. In case of join, the two data frames are joined on the basis of their index value. Join is generally used when two tables have completely different attributes, and this is the reason why you have to specify the set index while performing join. Okay, so here you can say that it's must to have a common index between the data frames. Okay, so let's move ahead and let me just show you how you can perform join operation. So here, how to perform join operation in Pandas. So similarly, the very first thing that we need to do is define our data frame. So let's just copy the one which we already created. So here I need to make some changes in it. What change? Here I have to add index value for it. So let's say index equal L1, L2 and L3, as this is my left data frame. Okay, and let's define our fourth data frame, and in this let's change the name of the attribute. So here let's make players and titles, and also let's change the index number. So let's say we have L2, L3 and L4. Okay, so our data frames are ready. Here I'll be performing the join function. So first let's perform inner join on it. Well, the concept of inner join and inner merge, everything is same. Okay, just the difference is how it is used. In case of join, the two data frames are joined on the base of their index name. In case of merge, two data frames are merged on the base of their attribute name. It's the only difference. Okay, and it's same with inner join, left join, right join, outer join, everything. Now let's see how to perform a inner join. So I want to join my data frame 3 with data frame 4. Okay, we have to change it. Let's name it 4. So I need to join data frame 3 with data frame 4. So df3.join inside this data frame 4. And how I want to join? So how equal, I want to perform inner join between them. That's it. Execute it. Okay, we are getting error of columns overlap. Okay, I guess we missed one value over here. Okay, now both our tables are also different. Okay, now let's perform inner join on it. So while performing inner join, you can see that it has joined both the tables on the base of their common index name, right? So L2 and L3 are common part over here. So that's why we got these values. So this player is from the left data frame and this player is from the right data frame. Fine. So this was about the inner join. Now let's change it to left join. So left join, let's copy it and just change inner to left. That's it. So here you can see that we are getting some null values over here. So why we are getting null values over here? So it's the same reason what happened in case of merge. So in case of left join, it is merging both the data frame with all the datas from the left data frame and all the common datas from the right data frame, right? And wherever the data in right data frame does not matches that to the left one, so there we are getting a null value. Okay, similarly right join, how? Right. In this we are getting all the values from our right data frame and all the common values from the left data frame. Fine. Next is outer join. Just write outer over here. So what it did, it just merged both the data frames. Wherever it was not able to find the common values, it assigned null values to it. Okay. So this was all about join. Now next we'll see how to perform concatenation using pandas. So here we'll write how to concatenate two data frames in Panda. So we already have defined data frame 3 and data frame 4, right? 3 and 4. So let's just concatenate them. So for concatenating data frame 3 with data frame 4, all we need to do is pd.concat, and inside it mention what all data frame you want to concatenate. So here data frame 3 with data frame 4. That's it. Execute it. So you got this value over here. Okay. So it is basically concatenating both the data frames. Okay. So in this session, you'll learn about how to import a dataset using pandas and how to analyze various attributes of the data. So without delaying any further, let's start and see how we can import a dataset using pandas. So for importing the dataset, the very first thing that you will be doing is importing the pandas library. So I'm importing pandas as PD. So next we are going to read the dataset and store it in a data frame. So I'm defining a data frame named cars, and inside this I'm passing the path of my CSV file, which is empty cars2.csv. At this point you can specify the path to your CSV file. Okay. And finally we are printing it. Let's see the output. So this is my entire data. So let's move ahead and see what are the various analysis we are going to perform on it. So first is type cars. So this type car is used to check the type or check the data type of the car. So it's a data frame, right? So as a part of output, we got pandas.co.frame.dataframe. Okay. So the type of cars is, it's a data frame. Next is cars.head. Well, this is used to view only the first 5 records of your data frame, which in our case is this. Okay. Next is if you want to view first 10 records from your dataset, you can pass the attribute over here as 10. And so as an output, you'll get first 10 dataset from the data frame. Okay. Next is what if you want to view last 5 records, then you can use the parameter dataframe.tail, which in our case is cars.tail. Okay. So this will give you the last 5 record of your data frame. Okay. Similarly, if you want last 10 records from your dataset, you can specify a value over here. So dataframe.tail, inside this I pass 10. So this is giving me last 10 records from my dataset of cars. Okay. Next is cars.shape. Now if you want to view the total number of rows and columns in your data frame, for that you have dataframe.shape. So cars.shape gave me the output as 32 and 13, which means I have 32 rows and 13 columns in our dataset. Now if I want to concise the summary of the column of my data frame, for that I have dataframe.info. And inside info, I'm passing null underscore counts equal true. So what it is exactly giving me, it is giving how many non-null values are up here. So as you can see in QSEC, we have 29 null values. So from here, you can say that we have 3 null values in our column QSEC. Okay. This is the data type of each column. The first serial number is of integer data type. Next is object, MPG is object, cylinder is integer, and so on. So in total, we have 4 columns which consist of floating data type, 7 columns which consist of integer data, and 2 columns which consist of data of object data type. Okay. And the total memory usage is 3.3 plus KB. Fine. Let's move ahead. Now if I want to calculate the mean of my data frame, I can just write dataframe.mean, which in our case is cars.mean. So as a part of output, it gave me the mean of each column. Okay. Next, if I want to calculate the median, similarly dataframe.median, cars.median, it gave me the median of each individual column. Okay. Next is standard deviation. Well, for standard deviation, we have dataframe.std. So if you see the output over here, you are getting the standard deviation of each column. Fine. Next, similarly, you can calculate the maximum value of each attribute by using dataframe.max. So we have cars.max, for which we are getting maximum of each attribute. So in serial number, we have 35 unnamed maximum value. This MPG, it's 33.9 and so on. Okay. Similarly, you can calculate the minimum value for each attributes using dataframe.min, and you'll get minimum value for all these different attributes. Fine. Next is dataframe.count. So if you want to count the total number of non-null record in each column, then you can use dataframe.count. So which in our case is cars.count. So here as output we are getting how many non-null values are in each column. So here in QSEC you can see that we have 29, which suggests that we have only 29 non-null records and there are 3 null values in it. Okay. Next is the dataframe.describe function. Well, it is used to print the descriptive statistic summary. If you don't want to calculate each of the feature individually, you can just write dataframe.describe, and this will give you the output of count, mean, standard deviation, minimum, maximum, 25 percentile, 50 percentile and 75 percentile values of all the different columns. Okay. So these were the various attributes you can use it for analyzing your data set. Okay. So without delaying any further, let's see what exactly is data cleaning. So data cleaning or data cleansing is a process of detecting, correcting or removing corrupt or inaccurate records from a dataset, table or any database. It also refers to identifying complete, incorrect, inaccurate or irrelevant parts of our data and then replacing it or modifying it. This is what a data cleaning is. So let's see how we can clean our data. So the first thing that we can do to clean our data is we can rename the column. Okay, so in our dataset we had a column as unnamed. Right. So instead of using the column name as unnamed, we can replace it by name of the model, which represents the exact name of the column, as the column contained different model of the car. Right. So here what we are doing, we are renaming the column unnamed to model. So as you can see here as an output, we got model up here. Okay. So this is the very first thing that you can do while cleaning your data. You can rename the attributes. Next is, what if you have some null values in your data? So for treating null values, what you can do, you can fill the null values with the mean of the column. And this is how we do it. So cards.qsec. So as we have analyzed in our previous session that qsec had 29 non-null records, right? So which it meant that it had 3 null values in it. So we replaced all those null values with the mean of the qsec column. So what we did, we took the mean of the entire 29 and whatever value we got for the mean, we replaced all the null values with that particular value. Okay. So replacing the missing data with the mean value will help analyzing the data in a better way. Okay. So this is how we can replace the null values with the mean of the column. Next is drop the unwanted column. So here we can drop all those unwanted columns which do not add any value in analyzing the data. For example, we had serial number previously, right? But the serial number was not adding any value to our analysis part. So for the further processing of the data, we can avoid or we can drop the column of serial number. Okay. So how we can drop any column? So for dropping any column, what we have to do is dataframe.drop, and inside that we have to mention the name of our column, just like this. Cars equal cars.drop, and inside this columns equal, we are mentioning the name of the column as serial number, and it got dropped. So as you can see here in the output, we don't have the column as we used to have it previously. So here a serial number column is dropped. Well, next is finding correlation matrix. Well, this correlation matrix will help you to find how a variable is correlated to other variable. So if the value of correlation is high, so that means the two variables are highly correlated to each other. That is, changing one variable by a factor of x changes other variable by a factor of y. Okay, so here as an output we got a correlation matrix, right? So from here you can see that cylinder to cylinder it's highly correlated, that is 1, obviously. Cylinder to displacement, it is 0.9. So it means that cylinder equals 0.9 times of displacement.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So it's like if you increase cylinder by 1 unit, your displacement would increase by 0.9 unit. Okay. So similarly for DRAT, you can see that cylinder equal minus of 0.69 times of DRAT, which means if cylinder increases by 1 unit, it means the value of DRAT would decrease by 0.69 units. Okay. So if while finding a correlation matrix, you get a very small value of the correlation. For example, let's consider this. So here, correlation between carburetor and DRAT is minus of 0.09. So it means they are very weakly related to each other. So it's like if the carburetor is increased by 1 unit, so it means that if the carburetor is increased by 1 unit, then DRAT would decrease by 0.9 unit, which is almost very less, right? So by finding correlation matrix, you can define the correlation between the variable, and from here you can decide which attribute to choose and what not to choose while working on the problem. Okay, fine. Let's move ahead. Next is changing the data type. Well, initially MPG was of data type string, right? Well, MPG had some float or numerical values into it, right? But with the string, we cannot manipulate it, or we cannot perform any calculation on the string data, right? So MPG has to be converted to float in order to perform some data manipulation on it. So here we are converting MPG from string to float. So how we can do that? So it's dataframe.mpg equal dataframe.mpg as type, and inside that we are mentioning the data type which we want to convert to, and here in this case is float. Well, now if you want to see the change, you have to see cast.info null underscore counts equal true. So from here you can see that my MPG has been changed to floating data type, right? And even for the QSEC attribute, we have replaced all the null values from its mean, right? So here it's giving me 32 null values. That is, now it is not having any null values in it. Okay, let's move ahead. So again we are finding the correlation. This time the MPG part is included as it has become of a floating type. Remember, while calculating the correlation between two attributes, both the attributes should be numerical in nature. No correlation can be found between attributes of string data type. Okay, if you compare it with our previous correlation, you can see that there was no MPG value, right? As initially the data type of MPG was string, right? Now since we have changed the data type of MPG to float over here, so next while finding the correlation, we are getting MPG value. Okay, now Python is treating it as a numerical attribute and it is using it to find the correlation. Okay, so this was all about how you can clean your dataset. Okay, so in this session you will learn about how to perform indexing on the dataset, how to set a value for a column, how to manipulate the data using lambda function, how to sort a column, and finally you will see how to filter your records. So without delaying any further, let's start with our first topic, manipulating dataset indexing by position. Well, what if you want to view a single column? So how will you do that? Well, Panda gives you a functionality of iloc function in which you can specify the parameters to view a single column. So for example, I want to view HP column only. So my HP column belongs to 4th row, right? So I mentioned the iloc colon, which means row. So entire row, comma, 4th column. Okay. So what it will give me? The 4th column of the data set, which is nothing but the HP column. Okay. Let's move ahead. Next is, what if I want to view first 5 record of the HP column? So in it, I'll mention this is the number of row. So iloc row starting from 0 till 5. Okay, actually 0 till 4, just before 5, and the column 4th. So it will give me the first 5 result from the column HP. Okay, next is, what if I want to view all the rows and all the columns? So all you have to do is iloc colon comma colon. Okay, first colon means all the rows, second column means all the column. So it will give you the entire data set. Next is, let's see, I want to see all the column from HP to carb and see all the record from index number 6. So how will I do that? So for that I have row start from 6 till the end and column start from 4th till the end. So 4th column till the end and row from 6th column till the end. Okay, let's move ahead. So now we want to look at all the rows from the first column. So again, so here inside iloc I have mentioned colon. So this represents the row. So we need all the rows. So for representing all the rows we have colon. Okay. And the next parameter is the column number. So our column number is 1. So as you can see in the output, we got all the rows from our first column. Okay. Let's move ahead. Well, you can even view your record on the base of the name of the attribute. Okay, so for example, I want to see all the record of MPG column. So how will I do that? So instead of iloc, first of all, I'll be using loc over here. That is location. Okay, then inside that the row and the column. So colon includes all the rows and the column is MPG. So what it will give? It will give me all the rows from the MPG column. Okay. Next is display the record from index number 0 to index 6 from MPG column. So similarly, so lock starting from 0 until 6 and from which column? In MPG column. So it gave me records from index number 0 to index number 6 from MPG column. Okay. Next is to see first 7 record from MPG to QSEC column. So here what I'll do, so inside location what I have mentioned, the row. So starting from 0 till 6. So how many records are over there? It's like 0, 1, 2, 3, 4, 5 and 6. So in total there are 7 records. And from which column? So a column should start from MPG and it should end till QSEC. So from MPG to QSEC, I need 7 rows over here. Fine. So this was all about how you can play with index values while manipulating your data set. Okay. Next is setting the value. Well, if you want to set a specific value to the entire column, so you can do that easily using Panda. So here cars is our data frame. So what we are mentioning, cars of AM. So AM is what? It's a column name. Okay. So data frame of AM equal 1. So what it will do, so it will assign value 1 to the entire column of AM. So even in the output, you can see that AM has all the values of 1. Okay, let's move ahead. Next is applying function. Well, now what if I want to double my record? Well, for that, I can use lambda function over here such that x is x multiplied by 2. So whatever value would be there, it will just double it up. So cars of AM equal cars of AM dot apply F. Okay. F is our function, this. So as you can see in the output, we got all the double records in AM. Okay. Next is sorting the data. So what if I want to sort a column in ascending order? So for that I have data frame dot sort underscore values, and inside this I'll mention the name of the column. Okay. So for example, here my data frame is cars and the name of my column is cylinder. So I'm mentioning cars dot sort underscore values by cylinder. So as you can see here, my cylinder column has been sorted in ascending order. Okay. Next is descending order. Well, all you have to do is add one more parameter over here, that is ascending equal false. And as you can see here, my column has been sorted in descending order. Okay. Next comes filtering the data. Well, what if I want to view the record which are having more than 6 cylinder? So how will I do that? So for that I have cars of cylinder is greater than 6. So wherever the value of cylinder is greater than 6, so we are getting a true value over there, and apart from that all are false. Okay. Now what if I want to filter my records and see only the data or only the model which are having more than 6 cylinders? So how will I do that? So for that I'm storing the value into filter 1, and next I'll apply a filter to my entire data frame. So filtered new equal cars of filter 1. So what it will give me? It will give me all the true parameters from my data frame or from my filtered cars of cylinder greater than 6. Okay. So when you view the output of filtered new, you can see that we got all the values in which the value of cylinder is greater than 6. Okay. Next, what if I want to filter my record and check for the model which are having 6 cylinder and horsepower more than 300? So for that we added this condition over here. That's it. That is cars of cylinder is greater than 6 and cars of HP, that is horsepower, is greater than 300. So we are using AND operator over here. Okay. So this will give me a true result only if both the parameters are true. And again, same, we are filtering the data frame and displaying the filtered data. So as you can see here, we have only one model, Maserati Bora, which is having a horsepower of 35, which is greater than 300, and number of cylinders as 8, which is again greater than 6. So both our conditions are true. So there's a filtered data over here. So our today's session is on Introduction to Machine Learning. In today's session, you will learn about how you are surrounded with machine learning, what exactly is machine learning, and what are the various myths related to machine learning. So without delaying any further, let's move ahead and see how you are exactly surrounded by machine learning. The first one we have is product recommendation. So have you ever shopped online on Amazon? So while browsing through the product, did you notice that it recommends you a certain list of products which are quite similar to your interest? So how do you think Amazon is doing this? Well, it is one of the applications of machine learning used in Amazon. Amazon is using the technique of machine learning to build a recommendation engine which recommends product to you. Okay. let's move on ahead. Next is Amazon Alexa. So how do you think whenever you command Alexa, it performs a particular function? Like, hey Alexa, play a music. So it plays your favorite music for you. Or hey Alexa, turn the light on. So it turns the light on. So how do you think these actions are performed? Well, this is again one of the application of machine learning. Or movie recommendation by Netflix. Again, one of the application of machine learning. Or Google traffic prediction. So how do you think when you're using Google Map to navigate from a place X to Y, then it suggests you route and it predicts the traffic on that particular route. Like from point A to point B, it will be huge traffic and that is mentioned in red, and after that there would be no traffic. So the pathway is shown in blue. So how do you think this traffic prediction is done? Well, it's also an application of machine learning, and these are the use cases which you are using in your daily life. Right, so these are the use cases of machine learning which you are using in your daily life. So now let's just move ahead and start with introduction to machine learning. So what exactly is machine learning? Well, machine learning is not just about the robots, right? Machine learning is a sub-branch of artificial intelligence which focuses mainly on machine learning from their experience. It is a subset of artificial intelligence which gives the machine the ability to learn without being explicitly programmed. Here, the data is the key and the learning algorithm. The data is the most important part of the machine learning algorithms. The machine trains itself according to the data provided to it. Let me explain you this with an analogy. Consider a newly born human child who starts learning in his primary and kindergarten. The child initially knows nothing, so the teacher starts with the alphabet. The teacher shows the picture of A to the child and tells him it's A. The teacher repeats the process again and again till the student learns all the alphabet. So this was teacher teaching the student. Now once the training is complete, teacher conducts a test to verify how accurately his student has learned. If the test score was not good, means that student has not learned. So more training is required in that case. Now compare this human child with a newly born machine. The machine doesn't know anything, right? So you start training them in a similar way the teacher taught to the child. Initially, the machine has no idea about what is A or what is B. So you start by showing your machine various pictures of A and telling that it's A. Now once the training is complete, you can test your machine by showing it different images of A of different fonts and style. If the machine is able to predict the image A with higher accuracy, then in that case you can say that your machine or the model is trained. Alright? So this is what exactly is machine learning. So now the question arises, how does the machine learn? So when you have the data set, you start by dividing your data set into two parts, the train and the test part. First 80% of the data is the training data, and rest 20% we use it as a test data to test our model. So you train the machine with 80% of your data and create a machine learning model. Now once the model is created, we bring in our test data and test our machine with it. If the accuracy is not good enough, then we repeat the process again and again till we get a final trained and tested model. Okay, this is how a machine learns. Fine. So this slide says that machine works with more data. So it's like more data you provide to the machine, more accurate it will get. For example, here on the screen you have some images of Chihuahua and Muffin. Okay, so you can see that they are quite very similar in their appearance, right? A human can easily tell that yeah, it's a dog or it's a muffin. But when it comes to the case of machine, it is really very difficult to tell which one of them is dog and which one of them is a muffin. So the more data you provide, the more accurate your machine get, and more easily it will be able to identify between dog and the muffin. Okay. Next. So I'm assuming that almost all of you must have come across this verification step from Google, right? Where it asks you to select all the images, for example here of a fire hydrant. So what you do, you just click on the picture of fire hydrant to verify that it's not a machine, it's you. But who knows, we are actually training a machine and telling the machine that these are the images of a fire hydrant, right? It might be possible that we are training a machine for something very big. Okay, let's move ahead. The machine learning popular myth. So let's bust out some of the popular machine learning myth. So the first myth that we have is most of the people consider that all the AI, machine learning, deep learning, all these are same. But just to tell you, there's a significant difference between them. So just to tell you, AI is a broader umbrella under which machine learning and deep learning comes. And deep learning is a subset of machine learning. Okay, so let's see them one by one. Starting with artificial intelligence. Well, artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that works and react like human. Well, it's a broader field, or you can say that the theoretical concept of machine learning and deep learning comes under AI. So the presentation part is AI and the actual implementation part is either machine learning or deep learning. Okay, next comes machine learning. Well, machine learning is a subset of AI which gives the machine the ability to learn without being explicitly programmed. Okay. Next is deep learning. Well, it's a subfield or subset of machine learning which is concerned with algorithm inspired by the structure and function of the brain called artificial neural networks. Fine. So get this thing clear that AI, machine learning and deep learning are not at all the same. Okay. So I hope now you know what exactly is AI, machine learning and deep learning. Okay, let's bust out another myth. So next myth that we have is robots will take up our job. So most of us think that robots is gonna take up our job. Let me give you a scenario. Every one of you know about Uber, right? Uber is using machine learning algorithm to simplify your life. So what do you think? Uber has taken up the job? No, right? So instead it has generated so many n number of jobs for the people out there. So many needy people are hired every day as Uber driver. So here my point is, machine learning or the robots might take up your current tedious job, but instead it will open up with thousands of opportunity for you and will definitely make your life more easier. Okay, so robots are not going to take up our job, but instead they are going to generate more jobs for us. Okay. So in today's session, we'll learn what exactly is supervised learning, one of the type of machine learning, what are the real life use cases of supervised learning, what is unsupervised learning, what are the various real life use cases of unsupervised learning, what is reinforcement learning, and finally what are some of the real life use cases of reinforcement learning. So without delaying any further, let's start with types of machine learning. So in general, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's see them one by one. So starting with supervised learning. So supervised learning is the one in which we have a training data set, or you can say in which we have a labeled training data set and the machine is trained on that particular label. For example, so there's a teacher or there's a supervisor who supervises the entire process and trains the machine according to the label. For example, you can see up here, here's a teacher on the screen who is teaching the machine by showing different images of the apple. So once the machine is trained, so in future, when we show a different image of an apple, the machine can easily identify that it's an apple with some accuracy. Okay, for example, the image shown up here is an apple with 97% accuracy. So this is supervised learning. So let's see some of the use cases of supervised learning. So first we have a spam classifier. So how do you think your mail is getting classified as whether it's a spam mail or not a spam mail? Well, the spam detection basically works on the basis of filter. These are settings that are constantly updated based on new technologies, new spam identification, and the feedback given by Gmail user about potential spammers. Spam filter uses either text filter or it eliminates the thread based on sender and their history, whether the sender was previously reported or not. Okay. So there are mainly two types of filters: text filters and client filter. Text filter work by using algorithm to detect which word and phrases are most often used in the spam email. Phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. Spammers have gotten wise to this and often use blunt misspellings or even substitute of characters like free dollar character in order to make it pass the filter. Fortunately, the modern spam filter can also make allowances for these type of misspellings, and if a word comes up, even with character substitution, the message will still be blocked. Next is the client filter. In addition to the simple text filter algorithm, the top spam filter uses client identity and history to block malicious or annoying spam email. Now, how does a spam filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. If they send out huge amounts of email constantly, or if several of their messages have already been marked as spam through the text filter, in that case their email will be blocked entirely. So this brings us to the use of blacklist. Spam filters also include a blacklist. Blacklisting is simply the process of adding the known email addresses of a spammer to a list. This list prevents any inbound messages from the email address going forward. If you have marked something as spam, it will directly go in this blacklist. And it also helped Google to make a note of certain keywords found from that particular spam mail. So that's the outline of spam detection. The real-time process are a lot more complex and consume a lot of data. Okay. Next is fingerprint analysis. So for fingerprint analysis, what you do, you save your fingerprint in the machine as a record. So the machine checks the data and verifies whether this particular data belongs to you or not. Okay. So once the data is saved into the machine, so from next time, whenever you put your fingerprint on the machine, what the machine does is scan through all of its data. And if the data is matched, then in that case, your fingerprint is verified. This is another application of supervised learning. Next we have is unsupervised learning. Well, in case of unsupervised learning, there is no teacher and there is no label. What the machine does, the machine identifies clusters in it. It finds similar images and group them into a cluster. For example, over here, seeing some pattern in different images, the machine divides the entire image into 3 different clusters. Okay, cluster 1, cluster 2, cluster 3. But the machine doesn't know that cluster 1 is an apple, or cluster 2 is an orange, or cluster 3 is a banana. All it knows that cluster 1 consists of similar item, cluster 2 consists of other similar item which are not at all related to cluster 1. And similarly, cluster 3 consists of different items which are completely different from cluster 1 and cluster 2. And cluster 3 consists of other similar items which are completely different from the item of cluster 1 and cluster 2. Okay, so this is what unsupervised machine learning is. So one of the use case of unsupervised learning is voice-based personal assistant. So the device which you are seeing on your screen is Amazon Echo, and the brain or the voice of Echo is known as Amazon Alexa. The device has many smart built-in to do a number of tasks like playback music, make the light blink. It also recognizes the name Alexa. It's like when you say the word, it recognizes the word and start recording your voice. Amazon calls this word as a wake word. So it's like when you have finished speaking, it sends the recording over to the internet to Amazon. The service that processes this recording is called Alexa Voice Services, or AVS. It's run by Amazon, thus converts the recording into command that it interprets. It's more than a simple voice-to-text service. It is a fully programmable service that can work with other online services to do a large range of things for you. Once authorized by Amazon, anyone can use this service for free to build a homemade Echo. Amazon has also offered sample code for building an Echo using a Raspberry Pi, which is a simple $30 computer. It might sound extremely selfless of Amazon to provide the service for free, but as always, they have their reasons. Amazon want others to build their service into their product so that they can sell you this stuff. So every product that has Alexa built in is a device that can be used to buy stuff from Amazon. These commands that Alexa interprets can be very simple. It's like if you ask for a time, the AVS sends back an audio file to Alexa telling you the time, which the Echo plays back. They can also be more complex. If you ask Alexa to play a Pink Floyd, AVS will search the music service to have you set up for Pink Floyd, and then send a command back to the Echo that sets it playing the requested music. Alexa can also work with other technologies in your home. It's like you can even set up your Philips Hue smart lights to be controlled with Alexa. You can ask Alexa to turn on the living room lights, and the Alexa will send a command to the Echo that sends a command to these light bulbs to turn on. It can also work with various online services. You can link Alexa to Uber, and you can request Uber by simply asking Alexa. You can link it to Domino's, and you can just order a pizza with your voice. So this approach means that Alexa can do a lot of things for you. And the list is just getting longer. Amazon is adding more features and skills to Alexa. And if you are smart enough, you can build up on their own. So it means that you can use Alexa to control things that are not even on the list. Okay, well, however, Alexa needs internet connectivity and AVS to work. If your internet connection is slow or it's not working, then Alexa won't be available and your Echo will be useless. So if Amazon decides to charge for a service or just close it down, then in that case, you'll be just left with a useless device. Well, Amazon is not the only one in town. We have Google, Apple, and Microsoft, which offers similar services that can perform tasks by voice command in the form of OK Google, Siri, and Cortana. They use similar approach, voice commands that are processed in a cloud service. But most of them are not as flexible or as integrated with other service as Alexa is. So whichever of these services end up being the one we all use, hopefully they will be as polite as Alexa. I'll just give you an example. When I asked her how she works, she replied, "Lots of people had worked hard to teach me, and I'm still learning more. Wouldn't it be nice if all of our appliances were that modest and polite?" Right? So let's move ahead. So another use case of unsupervised learning is Netflix recommendation. So more than 80% of the TV shows that you guys watch on Netflix are discovered through the platform's recommendation system. That means the majority of what you decide to watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. Let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you the list of movies and find shows that you might not have initially chosen. To do this, what it does, it looks through a thread within the content rather than relying on board genres to make a prediction. So this explains how 1 in 8 people who watch Netflix Marvel shows are completely new to comic book based stuff on Netflix. Let me tell you about a guy named Todd Yellen. He's the Netflix Vice President of Product Innovation. He has explained the working of Netflix as a 3-legged stool. The 3 legs of this stool are Netflix members, the tagger who understands everything about the content, and our machine learning algorithm that takes all of the data and puts them together. So Netflix has more than 100 million worldwide users. If we count the multiple user profile for each subscriber, it comes to around 250 million active profiles. Now Netflix uses different kind of data from these profiles, like it keeps a track of what you guys are watching from your profile, what do you watch after completing your current video, and even what you have watched earlier. It also keeps a track of what you have watched a year ago or what you're currently watching and at what time of the day. Well, this data is the first leg of the metamorphical stool. Now what they do, they combine this information with more data to understand the content of the show that you are watching. The data is generated from dozens of in-house and freelance staff who watch every minute or every show on Netflix and tag it. Now all these tags and the user behavior data are taken and is fed to a very sophisticated machine learning algorithm that figures out what's most important and what should it weigh like. Or how much should it matter if a consumer has watched something yesterday? Should that count twice as much or 10 times as much compared to what they have watched a whole year ago? How about a month ago? Or how about if they watched 10 minutes of the content and abandoned it, or they binged through it in 2 nights? So how do we weigh all that? Well, that's where machine learning comes in. What those 3 things create for us is taste communities around the world. It's about people who watch same kinds of thing that you watch. Viewers are fit into thousands of multiple taste groups, and it's these that affect what recommendation pop up on the top of your screen. The tags that are used for machine learning algorithm are the same across the globe. However, a small subset of tags are used in more outward facing way, feeding directly into the user interface and differing depending on a country, language and cultural context, as the tags have to be localized in a way that make more sense. For example, if you know English and you're watching Hollywood movies or movies in English, then in that case, Netflix won't recommend you German movies or Chinese movies or Japanese movie. Alright, the data that Netflix feed into its algorithm can be broken down into 2 types, implicit and explicit. Explicit is, for example, you gives a thumbs up to the series The Friends, so the Netflix get it. Okay, and implicit data is mostly the behavioral data. It's like you didn't explicitly tell Netflix that you like Black Mirror, but you just binged on it and watched it in 2 nights. So the Netflix understands that behaviorally. So the majority of the data is implicit. So this was about how Netflix is using machine learning to recommend you the movies. Fine. So next we have is the reinforcement learning. Well, in reinforcement learning, what we have is the agent and the environment. The agent selects some action using some policies. So there is no teacher in this case for training the machine. If the machine makes a right decision, the machine gets a positive point. If it makes a wrong decision, it gets a negative point for it. So repeating the process again and again and again, the machine learns it. So this process is of reinforcement learning. So let's take the example of a self-driving car over here. So initially, when the car was trained, so the car didn't know what way to choose. Okay. So what it did, it made an action, but the action it performed was wrong. So it got a penalty of minus 50 points for that. So from the next time, car realized that what it did earlier was wrong, and it updates its policy and then iterates the process. Okay, so this is reinforcement learning. So let me just explain you reinforcement learning with the concept of how Pavlov trained his dog using reinforcement learning. So this is a famous example of how Pavlov trained his dog using reinforcement learning. So it's like initially Pavlov gave food to the dog. So in response to the food, the dog started salivating. Okay, this was before conditioning. Then in the next phase, what he did, he just rang a bell, for which the dog did not respond anything. Okay. Then the third phase, what he did, he rang the bell and then gave him the food. So seeing the food, the dog started salivating again. Then after that, he repeated this third step again and again and again until the dog learned it. Then after conditioning, whenever Pavlov used to ring the bell, the dog started salivating. He understood that whenever the bell is going to ring, his master is going to give him the food. So this is how Pavlov trained his dog using reinforcement learning. Okay. One of the application or the use case of reinforcement learning is self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. To err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive number of unnecessary deaths, lives that could have been saved otherwise through self-driving. So this is where self-driving cars comes into picture. The autonomous car or the self-driving cars are much safer than human-driven car. They are unaffected by factors like driver fatigue, emotions or illness. This makes them very safe. Self-driving cars are always active and attentive, observing the environments and scanning multiple directions. It would be difficult to make a move that car has not anticipated. So how does a self-driving car work? Well, self-driving cars mainly rely on three technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensor available for a self-driving car. For example, sensor for blind spot monitoring, forward collision warning, radar, camera, lidar, and ultrasonic. So all of these IoT sensors work together to make navigation of a self-driving car. Next is the IoT connectivity. Self-driving cars uses cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditioning among others. This helps them to monitor their surroundings better and make informed decisions. And next is the software algorithm. All the data the car collects need to be analyzed to determine the best course of action. This is the main function of the control algorithm and software, and this is where reinforcement learning comes into picture. This is the most complex part of the self-driving car since it has to make decision flawless. A flaw like in case of Uber's self-driving car can be fatal. Okay? In today's world, the most famous self-driving car are those from Tesla and Google. Tesla cars work by analyzing the environment using a software system known as Autopilot. Autopilot uses high-tech cameras to view and collect data from the world, same as what we do with our eyes. It's called as computer vision or sophisticated image recognition. It then interprets this information and makes the best decisions based on it. So this was one of the use case of reinforcement learning. Okay.
To start with this linear regression, right? You all must be remembering the linear equation that we have, right? So what was that linear equation that we used to have in our school days? It was something like this, right? Y equals mx, sorry. So the form was y equals mx plus c, right? So the form was y equals mx plus c, right? This was the form of the equation that we used to be getting in our getting for a linear line, right? So we had this kind of line from that equation, right? It might be, it depends on the value of m and c. I am taking c somewhere is there, so this kind of lines we will be getting. And here let's say this point is x1 y1, so for this one is x1, so this point up here in the line will be x1 y1, right? This point up here will be x1 y1. So for the value of x1 we have this value of y1. So in here, if you see this variable, this was used to be called dependent variable, right? Dependent variable. Why dependent? Because it always changes with the value of x, but x doesn't have any limit. So this is called independent variable, right? This is called independent variable. So x is independent, y is dependent, right? So that kind of equations we used to have. Okay, and this aim here, right? This aim here, this aim used to be called slope of the line, right? This was used to be called slope of the line. This c was some constant which can be zero also, right? C is some constant which can be zero. So that's what we had in our linear line equations. Now the thing is, how do we use this for our class, like for this linear regression models to be built?
Okay, so the entire thing is based on this concept only, y equals mx plus c. It is as simple as that. So we will have some kind of a equation which will be in the form of y equals mx plus c. We will predict the values of the data points that is being sent to our data set when it is deployed, and then we will get the values of y. Okay, so that's what is the whole concept of machine learning, linear regression. So linear regression is a technique to find relationship between two or more variables. Yes, right. So if we have more than two variables, then how the equation will look like? It will be, let's say y depends on more than one, right? So it will be mx plus ny, sorry, nz, something like that. And so mx plus na plus let's say pc plus d, kind of this kind of equations, right? So here it will have three variables, three independent variables, x, a, and c, right? Three variables we will be having in that case, right? Three variables we'll be having in that case. So that's where this machine learning comes into picture, and that's how this machine learning thing works. Okay, that's how the machine learning works. Now let's see how we are going to use it for our model. So that's why, so this is called linear because it is based on the equation of a linear line. Okay, it is based on the equation of a straight line actually. Okay, so as I told, change in dependent variable is associated with the change in one or more independent variables, right? So that's the basic concept of the equations. Okay, next is this picture. This is called Rex Thor, the dog bearer. Okay, so if you see the right hand side, guys who are aware with Avengers, they must be recognizing the right hand side guy is some kind of a Thor. It's look like Thor. He carries a dog, right? Instead of carrying a hammer, he carries or a stormbreaker. He is carrying a dog, right? So he is named as Rex Thor, the dog bearer. So there is in the, we know, right, there are seven stars in the planet which has some kind of a shape. So it is one of them. Okay, this is a star pattern actually. So why we are taking this here is, this is the data point, right? In the left hand side, this is the data point, and this is how the thing looks like. So if you draw this line, then this is, I mean, you see like there is a lot of difference between lines, right? So that's how it looks, and there is a concept of r square. R square means mean squared error. Okay, that is also known as goodness of fit. So you will see when r square gets minimum, that means the model has huge error. So here see the r square value is pretty small, right? It is 0.06. That means this line up here doesn't at all represent this model. Okay, so that's how this linear regression works, and with the help of this goodness of fit r square value, we can somewhat check the model's performance also. So that is a statistical test. At the end of the class, I will be telling you that, like the theory behind it, how those are calculated, and those part. Okay, so that is what is about linear regression. It's that much easy only. Okay, it's nothing more complex. More, not much of a complexity is there in the in this linear regression. So it's far too easy. So next, there are a few examples of linear regressions. Okay, so where, yeah, I told, right, Ravi? So r square I will be coming later. It is a mean squared error. So it is a goodness of fit test. That is a r squared test, you can tell. So I will be coming to that in the last part. Okay, I will tell you the theory and everything also. No need to worry. Okay. So this is the regression is a technique that displays the relationship between y and x, as you already know. So if temperature drops down, the guys will start putting more jackets, more jackets to avoid the cold, right? To keep them warm. So that's a straightforward relation between two variables. This is an example of linear regression. Okay, temperature versus number of cones sold at the ice cream store. If it's gets hot at outside, then the number of ice cream sold will be more, right? Inches of rain versus new cars sold. So that means in the rainy season, guys would like to avoid going out without their car, right? So that's how. Daily snowfall versus number of skiers. So if snowfall is higher, number of visitors at the skiing park will be increased, right? So that's how this works. Now this is the base of it. So if you think there is a relationship between two things, regression would help confirm it. That means if at all there is a relationship between those lines, let's say I will draw you a plot first. Okay, so let's say here is a plot I am drawing. Come on, why it is too large? I want something smaller. So if you see, there is so some data points. Let's say this one, say this one, say this one, this one. So see, here is a perfect relation, right? But again, this is not a linear relation, right? So if you draw it otherwise, if we say there is kind of a this line goes in, so this is the best linear regression line that can be fit in, then also this doesn't seem to be a good relation between them, right? So linear regression will help you to understand if there is any relationship between two variables or not. Okay, so that's how linear regression works. So you will build a model. If the model performs poorly and no ways you can fine tune the model, that means there is not much of a linear relation between them, right? If there is a linear relation, then it will look good, right? So the goodness of it would look good. So here is an classic example. So if you see, the values here are categorical, right? Why categorical? Because y only has two values, y0, y1, right? Only two values. So in this two values, if you see, they are categorical values, and it comes under a lambda shift function, right? I mean, sorry, sigmoid function, this kind of, right? S kind of a function. So this is called sigmoid function, right? So that's how this thing goes in. Okay, so here if you draw the linear regression line, it will fail miserably. Okay, because if you calculate the r square fit for this, it will be too low number, because it is not at all a good fit, right? So this one is an example of linear regression. This one is for logistic regression. So to see how this linear regression helps here, if you draw this line, if you build this model using this line, then only it will be cleared that there is no linear relationship between these two data points. Okay, these two data points. Okay, so that's how it goes. Okay, so next we will be going to a few scenarios when we can use linear regression, and when do we go for logistic regression. Okay, these are a few types or a few factors which will help us deciding that. Okay, so see here, first of all, it will be continuous. For linear regression, the variables has to be continuous. That means it shouldn't be categorical or skewed at any 2 points, right? So it will solve regression issues. That means it should be a good fit. Okay, good fit to a point to some data points. Okay, and it should be somewhat it should be represented by a straight line curve. Okay, so in this case is match, so then it will be a perfect fit for linear regression. So it has to be continuous variables. That means the spread of the data, it shouldn't be skewed. So it should be somewhere, it should be spread out evenly among this in the xy plane. Actually, it should have a straight line kind of a relation between them, and it should solve regression issues. Regression issues means where we have a lot of data, we churn those data to find out some basic data, basic inference. Actually, when I say this, both of these are supervised learning algorithms, so don't confuse that. So here what we'll have, we will be, for both the cases, we will be having for both the cases we will be having this values, right? Like we will be having training values, right? But here we will have some output, that will be spread throughout the I mean that will be somewhat significant, not some classification things like 0 and 1, the gender split, male or female. It is a classification issue. A spam or not, classification issue. Predicting housing price, linear regression. Okay, this kind of things comes under linear regression. So if you see if you build a model of housing price predictor, there has to be some kind of a relation between all the variables, right? But for classification, it has to meet some criteria. There won't be any relation between those criteria individually, but there should be there should be a skewed value, and the variables will be categorical. Okay, when I say variables, so can anyone tell what is a variable? When we are telling variable, which one we are telling, like what we are actually trying to tell here when we are telling continuous variables and categorical variables? What are those? So if you get a data set, let's say there are 10 rows with 15 columns, so which one are we are telling about target variables? Okay.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Those parameters which impact the outcome, like dependent variables. So let's say if we have 10 rows and 15 columns, then 14 columns in that will be independent variables. Those are X values, they can go anywhere. Okay, the variables, the target variables will be the dependent variables, right? When we say continuous and categorical, that is the dependent variables, that is the Y values, that is the outcome values, right? Because independent variables can be anywhere, right? It can be anywhere in the plane, correct? So that's why when we consider fitting a model, we shouldn't be looking at the feature first, we should look at what kind of output we are expecting. So is the output is somewhat categorical or regression? What is it? The outputs will be in continuous variables. Let's say housing price. If you have 10 lakhs rows of data, so you are most probably will be having all the numbers between 20 lakhs to 1 crore, right? Depending on the scenario. So that's a continuous space, correct? But categorical things, when we are deciding on mail classifier, spam classifier, right? Spam or not, it's two values, 1 0 or 1, right? So categorical things, right? So that's how we decide on this linear regression and logistic regression. Okay, so it's Y here, it's Nancy, it's Y here. So when I tell the outcome, that is the Y, right? That independent variable. For X, those will be independent ones, they can go anywhere. Those will be the features of your data set on which you will build the models. When you say Y equals mx plus c, this X will be independent one, it can go anywhere, right? So you really can't judge from that, right? Because for a categorical, I mean, if you think for a spam classifier, what all things can be there, what all things, okay, let's forget it. Okay, think about Titanic survival dataset. So let's say you have the dataset of surviving from Titanic mishap, and you have all rows in there, right? So the values will be like sex, age, which parts they were in, right? So those things will be there, right? So let's say we have a housing price dataset. Okay, so in the housing price, what kind of columns you will have? Let's say area. So let's say we have a point called area. Okay, we have something called garden space. Okay, we have number of flats, amenities. These all can be realistic features. These all can be realistic features of your housing price predicted dataset, right? So with the help of this, we will predict a housing price, correct? Let's say we have a survival dataset. Let's say cancer dataset. Okay, so for predicting cancers, we have a dataset like that. For that, we will have internal or external. Let's say some kind of some things like that. Come on, again it went to scratch mode. Internal or external, right? Then we will have a size, we will have malignant or benign, etc. Okay, so what it will predict, yes or no? So you have a gland growth, is it a cancer or is it not? So yes, no. These variable types are called categorical ones. Okay, this kind of variables. So let's say if you are trying to buy a house somewhere in Mumbai, this value will range from 1 crore to 5 crore, and you are most likely to get this area because of this different size, different types of area values. You will get almost all the values between this range. Let's say 1 crore to 2 crore. Let's not go to 5, let's go to 2. Okay, so you will get all kind of values. So this is the things. Okay, so that's how you need to predict which one to use, right? So usually fixed number or possible. No, Saran, actually categoricals will be skewed. Okay, so it can be more than one also. Let's say we have, when we are thinking about this kind of categorical problem, it can be yes, no, it can be yes, no, or moderate, like that. So it can be anything, it will be fixed. Okay, as you rightly told, it will be fixed. But for continuous, it will vary, it will be in a range. Okay, so that's how we decide if the data set that we are having is categorical or continuous. Okay, so based on that, we decide, is it a regression problem or is it a classification problem, and based on that we are going to choose our models. If it's a regression, then we are going to go with this linear regression. Otherwise we are going to go with logistic regression, naive bayes, or xyz. Okay, that's how. Okay, let's go for some let's advance with the course actually. So here is something that I have already discussed, right? We have already discussed, and that's why I took some time, because this thing So that's the line equation. These are the some variables. These are called observables. This red points. This line is called line of linear regression. That means this is the outcome of your model. These points will be observations, right? And this will be regression line. And how do we decide if the regression line is a good fit or not? We use least square method. Okay, least square method that we'll discuss. Okay, so how do we do that? It's time to discuss that. I will show you with the graph. So let's say we have this kind of a line. Okay, let's say we have a point here. This is x1 y1. Okay, we have a point here. This is x2 y2. Okay, we have a point here. This is x3 y3. Okay, let's keep it to 3 lines. Okay, and somewhere down here, based on this line outcome, okay, this one is regression line. This will have separate kind of xy value. So for this one it will be somewhere here, for this one it will be here, and for this one it will be here. So these are like, here is the y value, here y value for this will be somewhere here, for this value will be somewhere here. So mean of them will be this one. Okay, let me change the color. Okay, mean of them will be this 3, so somewhere around here. This is the mean. Okay, this is the mean of y. Okay, which will denote as y bar. Okay, we will denote as y bar. Okay, now see the basic concept. How do we calculate? Okay, the basic concept of how do we calculate this? Okay, how do we calculate the r square? So these points, if you see, these blue lines are called error from line. Okay, error from regression line. Okay, if I write the equation, that is, we are going to, so as you know, the point distance, how it looks like, x minus x1 y minus y1, right? So that is basically this. So here x1 will be common in both, so it will be the value outcome of this AC line, that is squared error SE for line SE. I am scrolling it a bit up. So we will, what we have, SE of line will be y1 minus y squared plus y2 minus y squared plus y3 minus y squared up to n. This is the standard line error, because this is, if we consider this as y1 and all these values are x's, right? So when I write x, when I write y, that means y actual. Okay, when this y3 means y predicted. Okay, so sorry, I just reverse it. Okay, this is y actual, this is y predicted. So when I say y1 y2 y3, these are these points, right? So these are the original points that we have, so it will be y actual. Y means y predicted, that is outcome from this line. Okay, so y actual, y predicted, like that. Okay, for x1, for x2, for x3. Okay, this is what is denote squared error from the line of linear regression. Okay, this is what is denoted by this. Now I will change the pen color. So if we see squared error from y bar, that is y mean, that is from this red line. I was using a red, let's go back. So this is the point, this is the red line. So this one is the squared error from line. So here is the point. So this one will be the squared error from the mean of the data set. Okay, this is the squared error from the mean of the data set. So what we will have, we will have y1 minus y bar square plus y2 minus y bar square plus dot dot up to n. Right, now understand one thing, this value over here is how likely, how, what is the error between the linear regression line and the data points, right? This value up here is to find out the central tendency of the errors, right? So if you find out mean of these values, this y predicted values, and if you find out the difference between the actual points and the y predicted mean values, that means this is the variance. Okay, this is the distance and this is the variance. Okay, this part is the variance from all y values. This is the distance from each and individual y values. Now in order to get the r square estimate, that is the good fit line, or if it's a good fit or not, what we do, we calculate this value, that is SE line divided by SE y bar. Okay, we have this kind of a value. So what this denotes, how unlikely the line matches the actual values. Okay, this is what we denote by this part, right? Now if you want to know how good is the model, what we do, we subtract it from 1. This becomes our goodness of fit. For statisticians named it as r squared, or it is also known as least, this is also known as least squared error method. Okay, so this up here denotes goodness of fit. That means how good our model is. Now see what happens to this. Okay, so the value that we have, right? So the value that we have is somewhere like 1 minus SC line. So 1 minus SE line divided by SE y bar. So if AC line is pretty smaller, right? What does that mean? The line is a really good fit. So this is small divided by AC y bar. This will also get very small, right? If the difference between the each and individual data point is small, this will also get somewhat small. A small number by some number will yield you a small, even a smaller number, right? So that will approx reach to 1. Okay, but if for this equation, the the SE line gets higher and we have AC y bar which will get even higher, which will get somewhere around this, right? So, but it shouldn't be, as this is the higher but less than AC line. So we will have a high value up here. In the AC line, we will have a high value. Okay. So this, so how it works, this AC y bar, let's say for this equation, if we go back, if the points are even more down, right? So from, if the point is somewhere here, so somewhere here, all the values will be bigger, right? Based on this AC bar and the AC line, all the values will be bigger. So when we divide two big values, it will almost come to 1 and r square value will approx to 0. Okay, so that's what means when r square is small, bad fit. Okay, when r square is large, good fit. Okay, that's why this value r square is named as goodness of fit. Okay, so that's what is about this goodness of fit equation. Okay, these things I already told, this xy things. Now here is an example for you guys. Okay, so we have a few data points, we have plotted all this in the plot. Okay, we have plotted all these data points in here. Okay, now we will see using linear regression how do we calculate this. Okay, so x bar y bar is there, that is the mean of x and mean of y. Mean of x is 3, mean of y is 3.6. Now this is the line, this is the line, and this is the mean point is described with this red point, and this line, right, this green line is for the I mean the mean line. Okay, this is the mean line that we have, that is the y bar that we have. This is the mx plus c line that we have drawn till now. As we know from maths, this is the equation for m, that is the slope. That's how we calculate. So once we calculate m, you will see the value here. I am just scrolling through. Okay, these are some calculations, so I am not wasting time. So that's how we find out the value of m. Okay, so what does that mean? Let me show a few use cases. So if this is the line, now we need to find out value of m. M is x minus x bar into y minus y bar divided by x minus x square, x minus x bar square. Okay, now if we go in, so x minus x bar, when we calculate, that is the difference of the data points from its x mean. Okay, x mean. So these are the data point differences. We calculate this here, we put into the equation. Then we go for difference of y, that is y bar, because we need to calculate y minus y bar here, right? So this will be the differences. So this one will be the difference, this one will be the difference, like that we will calculate. Okay, so that's how we will have y minus y bar. We already have x minus x bar, we will square it out here. Then we will find out m by summarizing all this. We will sum all these things up and we will divide it by sum of this thing, and we will get the output. Okay, we will get the output. So here m value goes to 0.1. Okay, now y will be 3.6, m will be 0.1, x will be, let's say for 3 we are calculating. Okay, for 3, x equals 3 we are calculating, because as we see, for x equals 3, the mean is 3 and 3.6, right? So for x equals 3, the mean, we are calculating based on the means here. Now we will get the c value here, that is 3.3. Okay, so our straight line equations now becomes y equals 0.1x plus 3.3. Okay, so that's how we do calculate our linear equations. Okay, so this is the linear equation that we got from this data set. Okay, now what we will do, we will try to predict the values of x equals 1 2 3 4 5. Why this formula? That is the formula for m, actually. I'm good, that's why. Okay, so that's how. So now what we have the straight line equation, we have the actual values of x and y's from this data set, that is from x equals 1 2 3 4 5. We have the values of y 4 3 4 2 5, right? Now we will predict using the equation that we got, to test our model how good it is, how good our model fits our actual data points. Okay, so this is the line y equals 0 points y equals 0.1x plus 3.3. so 1 2 3 4 5 we have. Now if we go on calculating all these values, we will get something like this. Okay, so this is again calculated wrong, this will be 3.4. anyways, just leave it. Okay, no need to worry about it. The values here are might be here and there, don't think about it, it's fine. If they have made some mistakes might be, so just ignore this. So we will have these values as an outcome from our model. Okay, now we will find out the r square. Okay, we will find out the r square. Okay, so we will go to it and we will try to find out the r square values. Okay, so as you know, I told yp minus y bar square by y minus y bar square, right? That is r square, and it should be 1 minus. Okay, that's what would be r square. So y predicted minus y mean divided by y minus y mean square, like that. So okay, it is somewhat okay. So in this equation that I have shown, if you subtract 1 from it, it will be something like this. Okay, if you subtract 1 and if you solve the equation, it will be something like this, or else you can go with the equation that we have taken also, both are fine. Okay, this is the minimalized version. So when we say that, that means, when I say that, so we have 1 minus AC line by AC y bar, right? So if we solve this, it will be AC y bar minus AC line by AC y bar, right? So what is AC line? Is y1 minus y square, right? What is AC y bar? Y minus y1 minus y bar square, right? If you equate, how it will look like? If you equate how it will look like, it will look like y1 minus y square divided by, sorry, how it will look like is y1 will cancel out, so we will have, sorry, I wrote it wrong. What we will have? We will have, sorry, y minus y bar square divided by AC y bar. What is that? That is again y1 minus y bar square, right? That's what we will have, right? So when we do this, we get this equation. Okay, so that's why r square is written like this. Okay, that is also an equation. So if we go and calculate, we will see the r square value what we are getting. It is 0.36. Okay, so that is a small value, so this line is not good. So in the next step, what we will do, so we will just turn the line. Okay, we will just change the line equation, and we will just try to check how our model performs. Okay, so till we get a good r square value that is almost equals 1, we will keep on rotating the line till it fits the entire data point. Okay, till it fits the entire data point. Okay, that's how this goodness of fit works. Okay, so now let's see what is cost function. Okay, so we have seen this r square, right? R square is goodness of fit that we have seen, right? If you now what we will do, we will calculate cost function of h theta x. What will be the cost function? How do we go about it? So if we have m number of data points in our bucket, then this will be the equation of cost function. Okay, so what is it? R theta is square. This is for each and individual point value of r square, we will sum it up and will divide it by twice the number of data points. Now our model's target will be to minimize this to get the best model. Okay, we need to minimize this cost function value to get a good model. Okay, so for that, what we can do, as I was telling, for goodness of fit, we need to change theta values to achieve this. Now graphically, if you see, I will draw some kind of a plot which is known as contour plot. If you don't know it, don't think of it. Okay, this kind of plots are called contour plots. Sorry for my bad drawing. So let's say this is the mean of the data point. Some data point is in here. So by changing the theta values, we will come inside. We will come here, then we will come here, then we will come here, then we will come here, like that. Okay, so this is called gradient descent algorithm. This is not at all required, just telling you the basics. This gradient descent just to show you what is it. So using this gradient descent, we try to arrive at the minimalistic cost function. Then we will have the values of theta, like from the gradient descent algorithm itself, we will get the values of theta for which the cost function gets minimized, and then we will apply those theta values into this equation. So that will yield you the machine learning model that you are trying to build. So the concept is, using gradient descent, we will minimize the cost function for the data set. And after that, once we get the hyperparameter values, that is the theta values, we will replace those in the main equation, which will yield you the best possible values, the best possible equation that can be derived from the model. Okay, so that's how your entire linear regression algorithm works. Okay, so how do we go about it? Let me tell you in 3 simple steps. First step, we will take a null hypothesis that will be theta 0, theta 1 x1, theta 2 x2, like that, based on the number of features that we are going to supply to the model. We will find out the value for the predicted value, that is the value for the h theta x for all the data points. Then the next step will be to calculate the r square value for each individual sets. Okay, so we will have some kind of theta 0 values, right? So for that, we will calculate the r square values for all theta sets. We will sum it up, and then we will find the minimum value. So how do we find the minimum value? We do it using gradient descent. So gradient descent itself has a very large base. I am not going into that much detail, that won't be required. So there will be derivatives and all involved to get you the minimum value. Okay, to get you the minimum cost function value. For some theta value, you will get the minimum cost function, which will then yield you a good result. Okay, which will then yield you a good result. So using that, you will get the value of it. Okay, So using this, using those theta values that is returned by the gradient descent algorithm, you will get the model equation. So you will arrive at your original model, and after that you can start predicting. Okay, after that you can start predicting with that model. So whatever unseen data comes into picture, it will be predicted, and with the help of this gradient descent and goodness of fit test, it will yield you the ideal theta value of theta. Okay, ideal value of theta. Okay, so that's how we have it. Okay, that's how we have it. That's what is about this linear regression as a whole. Okay, that's not much we are doing. What we are doing, we are at first we are calculating the coefficients. Okay, the theory part that I have told till now, it is just to visualize that. So if you see, we are taking a data set that is x equals 1 2 3 4 2 1 to 10 and y some arbitrary values. We are trying to calculate our line from it. Okay, we are trying to calculate a line equation from it. So see, for the first step, what we are doing, we are trying to calculate the coefficient of it. So from the formulas that we have seen, np dot mean x, np dot mean y, like that, those things we have calculated, and we have calculated the calculated using the same formula that we have. So ssxy divided by ssxx, that's how the formula was, right? That's how the mathematical formula of slope is. So b1 here refers to the slope, okay, and b0 here refers to the coefficient, so that is y minus mx, right? So these things we have calculated, b0 and b1, and then we have plotted this x, y, and b, right? We have passed in x, y, and b to the plot regression line function, in which we have calculated the predicted y values, that is b0 plus b1x. Okay, then we have plotted those values of x and y predicted with a green line. Okay, with a green line. So this is the predictor line. Okay, in the x-axis we have set the size, and y-axis we have set the cost, and we have shown the line. So that's how your models will look like in the real world. Okay, so these data points will be your feature vectors, and that's how your model will look like. Okay, that's how your model will look like. And and we have printed the values of estimated coefficients as well. Okay, so that's how you by yourself can build this. Now in the next step, what you can do for getting linear regression, you can try adding the r square to it and looping it through. Okay, looping it through all the steps, but that won't be required as we already have this functionality available in scikit-learn package. Okay, in the scikit-learn package. So when we see examples of logistic regression, I will show you this. Okay, so we have seen two kinds of linear regressions, right? For one type of linear regression, I have shown you like theta 0 and theta 1 x1. Okay. For the other one, I have shown like there are x1 to xn values. So the first one is called single variable linear regression. If you have only one independent variable, that is single variable linear regression equation. If you have multiple, univariate and multivariate, right? So for multivariate, you will have more than one those things, right? Those what are those called? Those are independent variables. More than one independent variables. Yeah, so more than one independent variable, multivariate. A single only one value we are taking, that is univariate. Okay, now we are looking at this fancy Boston house data set. Okay, so this is for calculating house prices. So if you see here, these are the data description. So see, this is our target variable, median value of owner occupied home in thousands. So whatever values you see, those are in thousands. Okay, so LSTAT is percentage lower status of the population, and all those kind of stuffs are there. There are some fancy explanations are there. So what we will do for the first example, we will take these two variables like LSTAT and MEDV. Okay, so let's see how it works. So also, in order to go through that, checking correlation is a very important thing. Here it is not given, it is just to illustration purpose, but in the real world you will need to do it. Okay, you will need to check that. Okay, so here is the data set. As you all know, we read it using pd.read.csv. We read that, we check the step, we check the first 5 rows, then we are checking the mean, median, mode, and standard deviation, these equations. So now what we are doing, we have taken out the the dependent and independent variables. So LSTAT here will be independent variable, and MEDV will be dependent variable. So this is what we are going to find out. So here is how we read the files, right? Read.csv. Then we are seeing this data.shape head and all those. Then last we are checking the distributor stats. Now here we are taking out the independent variable here and dependent variable here into another data set, because this is a univariate example. So we will take only 2 data points. Okay, we will take only 2 data points. Now see here, I am we are seeing a kind of a, we are now plotting the data points, right? We are plotting the data points. So see, this kind of equations are there. Now there you can see the some kind of straight line will get automatically fit here, right? Let's see how it works. Okay, next is preparing data. So what we are doing now, we will be, what will be our next task? Our next task will be to prepare the data to see if there are any anomalies or not. So we have taken out LSTAT and MEDV, these 2 points from the data set that we have, okay. Then what we are doing, we are now doing a train test split of 80-20. We are taking out the split. Now see the size, it is like that. So we have 404 values for training and 102 values for testing. Okay, so when I told you, right, for scikit-learn we have everything handy. See now what all we have wasted time for last 2.5 hours comes down to this single line: regressor is equals linear regression. That's it. All the things that I explained is there inside this linear regression model. Okay, linear regression function. What we are doing, we need to pass the x values, x and y values. So x train it. So next line, what we are doing, we are fitting the line, right? Regressor dot fit x train, y train, right? So now we have a model ready. That is the theta parameters and everything, those things are done already, and we have a linear regression model in hand. So now we can use this to predict the outputs. So see, these are the coefficients and intercept values that is being calculated from the model itself. Okay, these are the regression coefficients. So if you count the the regression coefficients are basically the values of theta that it has taken for all the iterations, and intercept is the intercept value that it has chosen. Okay, now we have this y predictor. What is the y pred equals predict progressor dot predict x test. So again I told, right, so coefficient is fixed for a iteration, right? So that's what
Yeah.
is regression coefficient. So these are the iteration values for each and every iteration. This type of values got changed. Okay, so that's why this matrix has thrown out, and intercept is 37.9. That's how. So next task will be to get you the predicted values. Okay, we will now predict the x test, I mean predict the values using this model. Okay, so that's why. So but this is not working somehow, I'm not sure why. It was running before, I think I haven't run something, that's why. Let me run this once more. Yeah, okay. Oh, okay, not x test. Sorry, I messed it up. Sorry. Yeah, see, this regression coefficient is single value, right? The earlier why it was showing multiple values, because I ran these examples also, this multivariate examples, right? So those regression coefficients were for all the terms that we have, that I will come to later. So this regression coefficient, as you see here, returning single value, right? So this is the regression coefficient value that you have. Okay, so that's why it was not running. Okay, so this is the value for regression coefficient for the single one. I was just out of context. I was thinking that I am explaining multivariate, but this is a univariate one. So that's how it will be. Okay, so for a univariate one, it will be returning one value. That is it. This is the last value of regression coefficient. Okay, m is the intercept value. That is what is called intercept. Is m is called intercept. Okay, so that is the value of m. So now our equation be like y equals 34.33 x plus c. X is LSTAT, like that. So next what we have done, we are seeing the y predicted values. Okay, and we have y test values. Okay, now what we can do, we can plot this also. Okay, we can plot this also. How do we plot it? We can plot it like this. Okay, so let's move on for now. So now if you check the statistics of it, so that's how you check it. So from scikit-learn, you need to import the metrics package, and in the metrics we will have mean absolute error, mean squared error, And so these things we will have. So first one, see here, the mean squared error that we have, root mean squared error, it is too large, right? So this is a good fit for our model. So, okay, so this is a good fit for our model. So that's how these things are calculated. Okay, so that's how these things are calculated. Okay, for multiple linear regression, again we will have the same thing into picture. Okay, here instead of taking one, we will take all, and we will see how the things differ. Okay, how the things differ, we will see that now. So let me run it once more. So we are reading the data here. Okay, next step, we are dumping the last last column, right? In the first one we are dumping the last column. Why we are dumping the last column? Because that is going to be our target variable, so we won't be having it in the train set. So we have dumped it over there. Okay, we have taken out the y variable, that is the last column, in a separate list of y, and in the x we have all the features. So x is becomes our feature vector, y is our target vector. In the next step, again 80-20 split. Okay, again we have 80-20 split. Okay, then we have we are printing the values, 80-20 split we have. Now the difference is here we have all the variables in x train and y train. Okay, we don't, I mean in x train we have all the features. In the earlier example we had only one feature, but here we have all the features. Yeah, so in LX train now we have all the features now we will pass the X train and Y train values, and we will run these things. Okay, we will run these things. So see here we have created a regression line. Again, as a similar way, we have taken the regression coefficients, and we have taken the regression coefficients. Here we have multiple columns, so multiple regression coefficient will be there, and we have the column names also. So that's what we have taken. So 12 columns, 12 multiple regression coefficients will be there. So these are the theta vectors. Okay, these are the theta 0, theta 1, theta 2, theta 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, these are the theta vectors here. So if you see, there are some negative weights also, so that means these are insignificant. So they are I mean for those the values got I mean what, for larger value of those the value got decreased. So that's why we have a huge negative parameter for those. Like let's say for 4 NOx, for this NOx, what is NOx? If you see here, nitric oxides concentration parts per 10 million, so that is toxic, right? So if the value is more, the housing price will go down. So that's why it has a huge negative parameter. Okay, so that's how in the real world machine learning models work. Okay, so decision tree is again used for classification, or it can be used for regression also. The same algorithm, it can work for both. So decision tree is that much of a powerful tool. Okay, so it can be used for both classification and regression, but for ideal scenarios we use it for classification because it suits it better in a better way. Okay, regression also you can use, but it is not suited. It will still yield you some good result, but still it is not preferred. If you want to go for a regression kind of thing, go for linear regression. Linear regression, that would help you getting much better result than decision tree. Okay, so decision tree can work on basically both continuous values and categorical values. Okay, so it can work on both of this kind of data, and how it can work I will just show you in a few minutes. Okay, so these are just basic things. Logistic regression, the decision tree. So decision tree is nothing but a, so see how a tree grows, right? Tree has a root at the bottom, then as it starts growing it will be divided into branches, right? Branches will again be divided into sub branches, like that a tree grows, right? So here also we have the same approach. Okay, here also we have the same approach. Just a minute, I will take up my pad. I want to show you something. I will just draw a picture that will help you to understand this decision tree clearly, and you will see why the name is decision tree. Okay, why the name is decision tree. So if anyone here from computer science background, you must have learned binary trees or n-ary trees when taking classes, right? When taking data structure classes in the college level, right? So this tree is also similar to that, but there the branching was based on some decision. Here also branching will be based on some decision. Okay, so how the branching is done, we know if some condition is set to be, I mean if some value is set to be smaller than the root, then it will go to the left hand. If it's not, if it's greater than that, it's gonna go to right hand, right? That's how it used to work, right? So if I just draw a small thing, so you will see why this name decision tree is so is used here. Okay, you will see that. So let's say we have a root node. Okay, we will have a root node, that is this node will be blank. Okay, this node will be blank, and here we will have it, this is called root of a tree. Okay, in the it will go to left, it will go to right, it will have some nodes, intermediate nodes. Okay, the values of intermediate nodes, then it will again branch, it will go to left and right, like that it will go on till it reaches the endpoint. Okay, till it reaches the last level. So this level is called root level, right? This is called root level. This is called the leaf nodes. This is called leaf nodes. What do we mean by leaf nodes? Leaf nodes are the end nodes, right? After this, the tree cannot branch anymore. Okay, these are called branches of the tree. These decisions are called branches. Okay, so branches will be based on some decision. Okay, let's say, so if you consider this from a top-down approach, if you reverse it out, you will see almost a tree-like structure, right? First root is there. From that, as a tree grows, it will be divided into two parts based on some conditions. So there will be branches, there will be leaves also. So see, so the tree starts from a root level, right? So root level is the starting point of the tree. Now it will keep on branching based on some XYZ decisions. Okay, and wherever each branches ends, those are called all these things, right? All these square boxes are called nodes. Okay, these square boxes will be nodes, and each of these nodes represents a scenario. Okay, so each of this node will represent a particular scenario. Okay, so that means that will be your output. So each of this node means some of the outputs. So let's say the classification problem of male classifier. If I draw it, so it will have a leaf node, right? That male classifier will have a root node. So this is root. Root doesn't have anything. It is just the male object. Okay, so the one of the lines in the CSV. So then it will branch. Okay, it will branch like spam words, we used it, right? So spam words greater than 3, spam words less than 3. Okay, so here if I come, it will be spam, it will be not spam, like that. Okay, it will be not spam. So this is a state, this is a state. Okay, this is a scenario. Now if we come here with spam word 3, and if we have some other conditions also, then we will keep on branching. Okay, so wherever we found this nodes will be a individual scenario for that data. Okay, for that data, this nodes will be the individual scenarios, and where the tree stops. Okay, where the tree stops, like for this case, if I remove this line, so it's here. So wherever the tree gets stopped, those nodes are called leaf nodes. So they will be your ultimate outputs. Okay, they will be your ultimate outputs. That's why this is called a like decision tree, because this structure branches in and out like a tree. So there will be root, there will be branches, there will be leaf nodes, there will be nodes, and everything will be there. So this is how a tree grows. Okay, now let's go ahead with the PPT. Let's get into detail. How do we use it? So see, this is an example. So age less than 30, if it is a yes, then it's a lot of pizzas. So first we are checking, is a person fit or not. We are checking if the person age is less than 30, right? So if it is a yes, then we are checking if he hits a lots of pizzas or not. So generally less than 30 guys will be fitter, right? So if he doesn't eat some junk foods daily, so that's what we are checking. If he eats it, then unfit. If it doesn't, he is fit, right? But for less than if it's greater than 30, then you need to exercise, because after 30 your health starts degrading. If you does, you are fit. If you're not, you are unfit. So that's how a decision tree grows. That's how a decision tree works actually. Okay, so for random forest, what we have, random forest will be having multiple decision trees. Okay,
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
it will have multiple decision trees, then we will be calculating all the decision output of the decision tree. We will take all those, we will merge those to get some accurate and stable prediction. Okay, so this is but what the problem with random forest is, why we don't prefer it, because random forest, as we have multiple decision trees, we will be having a problem of overfitting, because we have n number of decision trees based on number of features. So if we create a decision tree for each of the features that we have, it might overfit the training data. So it is a good algorithm, but for data science or machine learning anywhere, you need to use it carefully. So that's why we kind of try to avoid this. Okay, we trying to kind of avoid this. So there are many scenarios when you need to include multiple decision trees. There you need to take care of the decision tree sizes and all. Okay, so that's why for the beginners it is not it is not advisable to go for random forest at the beginning, because random forest can have a problem overfitting. As you can see, if you have 5 features in a data set, and if you create decision tree for each one of them, right, let's say for age, so here we have seen age less than 30. If you try and create a larger decision tree, if you start from age less than 10, then 50, then 15, then 20, 25, 30, if you keep on growing the age group like that, if you, let's say in the data set you have, so in this you let's say you have something called like age, and in the data set that you have number of, let's say, a number of age groups, and you are creating models for, you are creating nodes for each of the age groups. So then that data will be overfitting. Okay, naive bias is another like classification algorithm. Okay, so naive bias, as you know, right, in the probability theory we have conditional probability theory, we have it, right, Bayes theorem. So that is what is the basic of this naive bias theorem. So what we have, probability of A given B has happened, then the how we write the formula, probability that B probability of B given that A is happened, multiplied by probability of A divided by probability of B. This is what is the basic of naive Bayes theorem. Okay, so this is this takes into account some historical knowledges. Okay, so as you see, you are trying to predict probability of some event A with respect to probability of and you know that that B has already happened. So you are taking this as a historical factor, probability of B given probability of A has probability of B provided A has already happened. So this is a historical factor. So you need this historical knowledge in your when you have this historical knowledge, then you can go for naive Bayes theorem, like let's say for cancer prediction, right? So it doesn't mean that a test, if it comes to be positive, will definitely mean that that someone has a cancer or some other diseases, right? So what you can do, you can I mean, if you have this so let's say in past you have seen like guys like 70% of guys who has a positive result in the test. So let's say in past you have seen the 30% of the guys having positive test means they have a cancer. So in those cases, naive bias you can use, because you need to have a historical thing. And next thing that you need to take care of is the features in the data set should be unrelated to each other. Okay, it shouldn't be related, because as you can see, like this depends on some other, so feature X depends on feature Y, the probability of feature X depends on if feature Y is present or not. So that's why the features should be like unrelated to each other, otherwise it will be a problem and this theory will fail. Okay, so this is a classification based on Bayes theorem, as I already told. Presence of particular feature, this also I told, right? So presence of a particular feature in a class has to be independent of any of the classes. So any calculated feature shouldn't be there, otherwise this will fail, because that probability it will yield as 1. So see, probability of disease you know as 0.1, and probability of disease bar, that is 1 minus probability of disease, is 0.9. So you know that probability that someone has tested with positive, given that he has the disease, is 80%, and it is the reverse, like probability of negatively tested having a disease is 20%. So this kind of historical knowledge you will need. So these are the historical knowledges that you have. Okay, so let's say you are running a diagnostic clinic, so you are gathering this historical data to find out the actual values. Okay, so that's what we have. So this is what is the basic of this thing. Now first we will we will go for decision tree, then we will be going for the example. Decision tree and logistic regression you can use anywhere, so you just need to practice it, you will get the idea better. So whatever can be solved with logistic regression can be solved with decision tree also. Okay, but building decision tree takes up some time. So for beginners, go for logistic regression, try to move into decision tree slowly, but decision tree will yield you accurate result, but you might run into overfitting problems also. Next is, let's say we are doing fruit classification. Okay, so we have color and diameter. Okay, we have color and diameter, these two labels. We have color green, mango, yellow, lemon, and all these things, and diameter of those are 3 and 1. Okay, so this data set is not clear, so let's just adjust it for a moment. I will explain how it works. Okay, so before that I will show you all this. So how this decision tree works, and how do you know when to stop, right? So we have a factor called entropy, information gain, and Gini impurity. Okay, so you need to check those things. So if you remember the laws of thermodynamics, right? What does entropy says? Entropy is entropy will be zero if the set is perfectly ordered, right? Entropy will be zero if the set is perfectly ordered. It will be high if the set is perfectly disordered. So you need to calculate entropy. There is a formula I will show you shortly. So from that entropy, you need to calculate this information gain. These formulas I am coming to it. So you need to go on calculating this. So if any point you see the information gain is not something positive, then you need to stop it, because there is no need of splitting the tree, because that's not gonna yield you something, right? So that's how you need to figure out about this decision tree. So see, this is the ideal scenario. Is diameter greater than equal to 3? Then if it's less than 3, then we have only cherry, right? Because it is a R1 and cherry, so diameter of cherry is 1, so it will be cherry. If it's greater than 3, then we have two options, like mango and lemon, right? Like mango and lemon. So now we will be checking color. So if the color is yellow, then we will say it's lemon. If not, then we will say it is a mango. Okay, so that's how this decision tree works. That's how the decision tree is built. Let's see with the example now. Okay, before that, these are a few terminologies: root node, leaf node, parent, child, and branch and subtrees. You can see like these are all related to the like present world only. So the root node, leaf node I have already covered. Parent and child node, like the predecessor node is called parent, the successor is called child. It's that simple. Okay, branching and branch and subtrees are, you can see like if you it can have multiple subtrees. So so these are branches, as I told. So this left subtree can be one subtree, this right subtree can be one, this subtree can be one. So it is basically independent parts of the decision tree. Those are called subtrees. As you see from the tree itself, it's identical to the tree. In the real world nature, it's identical to the trees. So that's how. Okay, so next is coming two important terms: splitting and pruning. Splitting means dividing root nodes into different parts, or the different child nodes, right? That's what is splitting. So splitting is the heart of decision tree, because if you don't split it wisely, then your decision tree can be a mess. Okay, so splitting is a part of it. So splitting means splitting the root node into splitting the root nodes into child nodes. Okay, so pruning, it will be, and random forest we would be covering in that much detail, so let's not worry about it for now. For now, just have the decision tree into mind. You will see you are getting confused with the decision tree alone. So let's just grab this concept first. Okay, pruning, that's a very important thing. Okay, so if you are trying to build a decision tree, you can run into one of the two problems. Like you can either underfit the training data, or you can overfit the training data. So how does it happen? So if you see, like if you build a small tree, right, then you are not gonna fit the data, you are going to underfit the training data, right? But if you are trying to build a huge tree, like a huge bush kind of a thing, then you will be overfitting the training data, because you will analyze the data, you will break down the data into so much nested levels that it is going to overfit the data. So that's where pruning comes very handy. So for making ideal decision trees, what we do, we don't care about what are the levels, if it underfits or overfits, what it does, we don't care about it. Okay, we let the tree grow. As soon as you have decisions, we let the tree grow. Then we come back and prune the branches where we see the information gain is not that valuable, or where we see the information gain is or entropy is too low to consider. So those things we can take care manually by pruning the branches. Okay, so that will make the tree shorter, which will in turn give you a good result, which will in turn give you a very good result, because in that way what you can do what you can do, I mean, first you can if you build a small tree, then you won't be able to optimize the tree, right? Because it will be small and it will be underfitted already. So if you build a big tree, a bush you can consider it as, so then what you will have lots of training example, lots of branches, lots of decisions that were there in the tree, and from that you can choose wisely, like which one to use, which one not to use. These are theoretical concepts. Have these things clear, because if when you go for interview, interviewers are not going to ask you how to make a decision tree out of a scikit-learn package. They know you know it, because that's just a one-liner syntax. So they are going to hit you in this core concepts. Okay, they are going to hit you in core concepts. So they can ask you how to solve the problem of overfitting in a decision tree or underfitting in a decision tree. These things then you need to answer. We can have splitting, we can have pruning, we can check the entropy, information gain, and Gini impurities, Gini index values to check it out. Okay, to check that out. So if it's still splittable, then we can have it go ahead and we can split it. If the information gain is 0, then we can stop. Then we can prune those branches like that. Okay, so that's how. And for all the algorithms, it's the same thing. They can, for linear regression and logistic regression, they can ask you why you don't use logistic regression, linear regression function in logistic regression, right? Cost function in logistic regression. Those things are theoretical questions will be asked. So they are not going to ask write a code that will implement decision tree. It's not possible for anyone. It's not possible to learn to write that entire code, but they might ask you for the algorithm. So go ahead and show them this. Okay, like that. You can say like I can show you graphically how a decision tree works, like that. Okay, let's go ahead and see how do we create a decision tree manually. Okay, I mean mathematically. Okay, so see, this is our data set: outlook, temperature, humidity, windy, and play. So these all are features from outlook till windy. These are all our features, and play is the binary variable that we are going to predict. So if the outlook is sunny, temperature is hot, humidity high, windy, it's not windy, should we play or not? So it's a no. So this is our labeled data set that we have. So now let's go ahead and see how do we decide whether we play or not. Given a condition, how do we decide if we play or not? And how do we pick this first and second things, right? How do we pick that? So like which one among them should you pick first? That means we need to start our branching from somewhere or something, right? So should we start branching with outlook? Should we start branching with temperature? How do we go about it, right? So we need to determine the attribute that best classifies the training data. What does that mean? Let's go ahead and see the answer. Okay, I mean, how do we decide where to split? So these are 4 things that we're going to check. Okay, so first one is entropy, that defines a randomness. This is a metric which measures the impurity, right? As I already told, so this is the first step to check the data. So what we can do, we can split the data based on anything, and then we can go ahead and check the entropy, and then we can decide on it. Okay, so and we can decide on it. So that's how we can that's how we can go ahead and do it. There is reduction in variance. So as you can understand, if this yeah, so reduction in variance, as you understand, like if you keep on reducing, if the entropy is reduced, then the variance will also be reduced. Okay, so we will be start to split the data based on the lower variance value. Then there is information gain, that is calculated based on entropy actually. And if you see, if where the information gain is highest, from there we will start splitting the data. Gini index is also the same thing. So that is again used in cart model of so decision tree in cart. When we do, like, cart means classification and regression trees. Okay, so when we use cart model of decision tree, then we do it. Then we use this, like what, this Gini index to have the Gini index to calculate this. Okay, and and the how this Gini index is calculated, we will be seeing that in a moment. Okay, so see now entropy formula is here, right? Negative P of ES multiplied by log of PES minus P of no into log of P no. So that is how entropy is defined. That means we need to add the entire thing, like, and the probability of both the events multiplied by their log likelihoods. Okay, so that will get you the likelihood of the event. Okay, we need to add those both, and we need to put a negative sign. We need to calculate the entropy like that. Okay, so P of yes means probability of yes, P of no means probability of no, like that. And if you going to draw this curve, then you will get, so negative sign is given just to make it positive, because log P can yield you negative result somewhere, because log value will be pretty small, so it can yield you negative. Just to make it positive, the negative sign is given, nothing else. Okay, if you draw this curve of this kind of a function, you will get this kind of a hyperbola kind of a shape, right? So number of yes, if it's 0.5, then entropy will be 1. So as you see, for 0.5, that is the perfect equilibrium, right? When the data is perfectly in equilibrium, we will have the highest value, that is 1, right? When the data, so that means here the disturbance of the data is highest, right? Because it has both the components, right? It is both the components. Why? So true and false are mixed, right? True and false are mixed, so it is the highest of impurity. So let's say if you have a 30% yes and 70% no, then also the data is somewhat skewed to no part, right? It is not that much of a what should I say? It's not that much of a impure. It doesn't have that much of a impurity, so it's not in the it's not in the chaotic state, right? So you will see the value is reducing. So if you have 0 and 1, for this the value is maximum, that is value is minimum, that is 0, right? Why 0? Because the data is in perfect equilibrium, because we have either all yeses or all no's. There is no other values, so either all yes or all no. So in that case it goes to 0. So that is the perfect equilibrium scenario, right? That is the perfect equilibrium scenario. So that's how entropy works. So entropy is a measure of impurity in the data set. So as it lowers, the value of entropy will be lowered. As it gets higher, the value of entropy will get higher, and the 0.5, it will attain its maximum value of 1. Okay, so that's what is about entropy. And how do we calculate? We calculate like that. So P of event multiplied by log of P of event minus P of another event multiplied by log of P of that event, like that. These are entropy calculations. So this is just, we have just proven that this formula can be this formula yields you 0 or 1, 1 at 0.5 and 0 at 1. So that's what. So it's not that much, where you'll just skip it, and we will go to this much, right? This one, the main thing that we have in the question. So we have 14 instances of the data here. Now we have 9 yes, 5 no, right? So we have calculated the entropy to be 0.94 here, right? We have calculated the entropy to be 0.94. So see here, 9 yes, 5 no, that is chaotic, so value is really high, right? Value is really high. Now our object is to like divide it into subtrees, so that the subtree can yield a perfect value. Let's see how we can do it. The initial entropy value is 0.94. Now we have this concept of entropy. Okay, like information gain, sorry. So information gain will be entropy minus weighted average into entropy of each feature. Let's see how do we calculate. How many features do we have? Outlook, temperature, humidity, windy, right? 4 features. We will calculate entropy of both, entropy of all. Okay, so here see, now this is the information gain. This is the information gain. How are we calculating? Weighted average multiplied by entropy of each feature. Okay, so we have 4 features: temperature, outlook, humidity, windy. Now in order to calculate like this information gain for some node, we need to split the tree, we need to start it from somewhere. Let's go ahead and start with outlook. Okay, so from outlook, when we started, we have sunny, overcast and rainy, right? Three things. So for each of the features, we are going to do this. We are starting with outlook just as a basic. You can start with temperature also, that's up to you. This is not just that doesn't mean much. Okay, so outlook has 3 values: sunny, overcast, rainy, and it has some yes no kind of things, right? So for sunny, 2 yes 3 no's, overcast 4 yes, rainy 3 yes 2 no's, right? Let's go ahead and calculate entropy and information gain in this outlook node. Okay, so see, E outlook equals sunny is minus 2 by 5. Why 2 by 5? Because we have 2 yes 3 no's, right? 2 yes 3 no's. For sunny, 2 yes 3 no's, right? So we have minus 2 by 5 multiplied by log of 2 by 5 minus 3 by 5 log of 2 3 by 5. So 0.97. See, the value is getting higher. So in entropy for outlook equal to sunny is 97. For overcast, it is all yes, so it is 0. For rainy, it is 0.97, right? Because it has same thing, 3 no yes 2 no's, doesn't matter, it will yield you same result. So this is entropy of each of these subsets. Now we are going to calculate their average weights. Okay, with their we are going to calculate the information gain from the entropy. Okay, so how do we calculate information gain from all this small all this entropies of this outlook feature? As you know, it is weighted average. Weighted average means how many examples you have under sunny as yes no, right? So here see how many of this data has outlook sunny, 2 2 4 1 5. So weighted average for sunny will be 5 by 14, number of that feature occurring in the dataset divided by total number of samples in the dataset, multiplied by what is the entropy of outlook being sunny, 0.97, right? We have calculated the information gain to be 0.693. Okay, this is not information gain, this is the information that we get from the outlook variable. Okay, this is the weighted average multiplied by this. So let me write it down to clear your doubts here. So for information gain, right, we have 93 in deciding the outcome of the data set. So this is called information that we have from the amount of information that we can get from this outlook value. Now what is information gain? It will be when we subtract it from entropy, right? Because the data set is already impure and we have some kind of information from a feature. If we negate those, then we get the information that is really meaningful to us. Because in this data set, right, in this data set, when we calculated entropy, we taken into account all this, right? All this 14, right? We have taken into account. Now now we have the total entropy, that is a total information, there is a total entropy of the sample space. Now we have the amount of information that we can get from outlook, only outlook, no other parameters are included, only outlook. What is the information that we can have, the amount of information that we saw to seem to be 0.693. But the entropy that we have in that, we already calculated this 693 part, right? We already had the 693 part included, because when we calculated entropy, we taken the entire data set into account. So if we negate this two, then we are getting the information gain of the data set. That means information gain from the outlook is 0.247. That's one measure. Okay, now next what we are going to do, we are going to calculate information gain for all other nodes in the similar way, and you will see the max gain that we can have is 247, right? We can have is 247. So max gain will be 247. So we are going to start splitting with outlook. We will first split with outlook, then we will check for the next is what, humidity, then we'll check for temperature. Like that we are going to create our tree. Now that's where we use entropy and information gain to decide on this data set, and we will keep on calculating this at each level to see if anywhere information gain becomes 0, we are going to stop it. Okay, so that's what is about the concept of information gain and entropy and how we can use it to decide the best feature. Let's go ahead. So for temperature, as you see, we have hot, mild, cool, 3, right? So for hot, if you need to take out these data sets, no, no, yes, yes. So 2 yes, 2 no's. So it's in 0.5. So entropy will be highest for this. Like that, for mild also you can check, for cool also you can check. You can fit in into this formula and you can check the manual result also. That we can clarify the results. Yeah. Okay, so let's go ahead and see how do we split. So outlook, sunny, rain, overcast, right? As you see, that's what comes into picture when an entropy is 0, right? Outlook, entropy of outlook being overcast is 0 because all the examples here are ES values, right? So when we start splitting on the outlook, what we will do for overcast, if the condition is overcast, we no need to consider any other variables into account. We can say the output will always be yes. So that's what happens when entropy becomes 0. Okay, so whenever you see outlook is overcast, tag that to yes, no need to check other conditions, so that we will stop here. If it's sunny or rain, we still need to go for other features to see if it's a yes or no. So let's see how we go about it. So now next is windy. Why windy? Okay, windy we don't have, but windy's information gain is in the second hand. Okay, windy's information gain is 0.048. So okay, so for humidity we have 0.152, right? We have 0.152 for humidity, we have 0.029 for temperature, and for windy we have 0.048. So the next two nodes of the split will be humidity and windy. Okay, humidity and windy. So windy here it is calculated in the same way, not explaining that. Let's go ahead. Then we will be calculating with humidity and windy. Okay. So if humidity is high, then no. If normal, then yes. If windy is strong, then no. If weak, then yes. So if you go ahead and check, let's say humidity high, right? So how can we check this, right? How can we check this? So see here, if outlook is sunny and humidity is high, what is the output? Outlook is sunny, humidity high, output is no. Outlook sunny, humidity high, output is no. Outlook sunny, humidity high, no. Outlook sunny, humidity normal, yes. So if outlook is sunny and humidity is high, we are going to have a default no. So we no need to take into account other variables, right? But if it happened that for humidity high we have one yes, then we would have taken into account the temperature feature. Okay, but here we no need we don't need that. Okay, here we don't need that because outlook and humidity, outlook sunny and humidity combination can yield you a perfect equilibrium state where entropy becomes 0. So you can stop it there. But if you didn't had this kind of a thing, then you would have gone for the temperature variable or the windy the temperature variable, right? So that's how it calculated. Now go for outlook. Is outlook overcast? Always yes, leave it, no issues. Outlook rain and there is a strong wind, right? Let's see. Outlook rainy, windy falls, right? From where it got to strong weak. Okay, windy falls, that means weak winds. We have yes. Outlook rainy, windy falls, we have yes. Outlook rainy, windy, we have no. Outlook rainy, not windy, we have again yes. So if outlook is rainy, outlook rainy, windy true, we have no. Perfect equilibrium, no need of further split. So if we have outlook to be rainy and if the wind is weak, we are going to play. If not, we are going to we are not going to play. So that's what you can see from the data set itself, right? So thus the tree reaches. So if you calculate equilibrium of each of these nodes, you will, I mean, entropy of each of these nodes, you will get a 0 because the subset that the data contains here at this point of time, like what I showed manually, right? If you calculate entropy of it, you will see all the variables are the same result. So it will be having 0 entropy. So the tree stops here. If it didn't had this kind of a thing, we would have gone for the temperature variable, but whereas this is not needed here, this is not needed. Okay, so that's how we have it. Okay, that's how we have it. So humidity and windy, Ankur, will always be on the always be down the outlook, right? That's what it is. So both are on the right, left, doesn't matter. You can have it in the any way and anywhere, right? Why humidity below sunny, not windy? Because humidity's information gain is the highest after outlook. Humidity is the highest, wind is the second highest, right? So we will go with the two nodes. When you are going to branch, it will have more than one branches, right? If for overcast it didn't had this, then we would have gone for windy here, here temperature, like that. So when you are branching the trees, you need to select the nodes having highest information gain. Okay, and the highest ones will always be on the left. So that's how you can exchange the right and left subtree also, that doesn't matter. It's just a you can take it in any ways, the result will be same. So after humidity, we don't need anything, right? So humidity windy combination won't yield you any result, as you can see, because if it's sunny and based on humidity only, you will get the perfect equilibrium. So we don't need to go about it. Okay, that's right. Okay, so that's what sums up this example. Okay, next we will be going to naive bias. So what is it? How do we use it? We have shown, right? Now let's get a deep dive into it. So naive bias will assume that presence of any particular feature in a class is unrelated to presence of any other feature. In short, we can say in naive bias there will be no calculated feature. Okay, there will be no feature engineering will be there. Otherwise, naive bias can't work. Okay, so let's say here we have for identifying an apple, we have three parameters: red, round, and 3 inches in diameter. So these three all are independent of each other, right? These three are all independent of each other. So here we can use naive bias in this case of this kind of scenarios. So why it is naive, right? Because a naive bias algorithm will have many limitations, right? It won't be sophisticated, it won't be experienced like that, right? So that means in naive bias we are solely dependent on the past data that we have, the historical data that we have, plus we need to use the exact features which are given in the dataset. We can't do feature engineering in that. So in many cases, naive bias will fall short. So naive bias we generally don't use much, but still in some cases where we have this historical knowledge, in those cases naive bias proves to be good, so we use it. But in naive bias, prediction accuracy can be really low. We will see that. Okay, next is the fundamental of Bayes theorem and its proof. Okay, so this I have already told. So let's go ahead and prove this. Okay, so calculate the probability of a second event B given that the first event A has already happened. Okay, so that means when this kind of so this is a concept of conditional probability. So how it works? It works in such a case where where we try to calculate probability of some event provided some other event has already been happened. Okay, so drawing a second ace from a deck given we got the first ace, right? So what does that mean? We already have drawn a ace from the deck. We will have 4 aces in the deck, right? So we have already drawn a first ace. Now we want to go ahead and draw the second ace. So it will directly become a conditional probability, right? Why? Because total number of cards in a deck will be 52, right? If we have the deck intact and if we try and draw the ace, in the first card that we are going to draw will be a ace. In that case the probability of it would be 4 by 52, right? It will be 4 by 52. But if we have drawn that card, then we will be have left with 51 cards, among which 3 will be aces. So the probability of drawing a second ace from the deck given the first ace is already there will be 3 by 51, that is 1 by 17, right? Yeah, correct. So that way this conditional probability works. So that means finding a probability that you having a disease when you are positive to that, right? When you are tested positive, but the test result can be non-negative, right? So like that. So if someone likes Game of Thrones, what is the probability that he will like fiction movies, right? So this kind of probabilities are called conditional probabilities, right? So here you need to understand, when we apply to data science, we need to have a prior knowledge, right? We need to have a prior knowledge on what has happened in the past. So in that way only we can use this naive bias, when we have this prior knowledge. In no other cases we can use this naive bias theorem, because the entire theorem is dependent on conditional probability, which differs you to have a prior knowledge, a historical knowledge. So let's say we have we want to check if a person likes fiction movies or not, right? So how do we can't apply naive bias, right? We don't know anything. So when we know the person has already liked Game of Thrones, then what is the probability of him being liking fiction? That comes a conditional probability way, or that comes to be and that becomes a good example where we can use naive bias classification, naive bias classifier. Okay, so that's how this thing works. That's how these things work. Okay, so that's how it is. Okay, next if we go ahead and see like event, yes Ravi, somewhere it so in movie recommend so for recommenders there is a separate topic called recommendation recommender system, but yes, you can use naive bias to calculate those kind of predictions. So given up, if you have the prior knowledge you can use it. Okay, if you have a prior knowledge of the system you can use this concept there also in the classification, I mean in the movie recommender system. Okay, you can do it. Okay, next is so probability of A, given that probability of B is already happened, we can write it as probability of A intersection B. That is probability of both the events, probability of occurrence of both the events divided by probability of B. So that's what is the probability of A given that B has happened. That's what the formula is. Now, so that is the formula, probability of A intersection B divided by probability of B. Okay, that's the formula. So we can prove it. Like the earlier the formula that we have seen, from that to this we can prove this. There is a mathematical proof, not going into that detail. So I think we have it later. Yes, we have it. We will show you. Okay. For now, let's assume this only. Probability of A that B has already happened is probability of A intersection B by probability of B. Okay. Now let's go ahead and see some examples how this works. Okay. Suppose we have a jar of 6 marbles, 3 black and 3 red. What is the probability of getting a black given the first one was black 2, right? Let's go ahead and see how can we calculate this. Probability of A is getting a black marble, probability of B is getting a black marble in the second turn. Okay, so probability of A will be 3 by 6, probability of B will be 2 by 5. So A intersection B will be 2 by 5 into 3 by 6, that is half, so 1 by 5. So probability of B given that A has happened will be probability of A intersection B, that is 0.2 divided by 0.5, that is 0.4. So probability that the second marble will be black when the first marble is already black is 0.4. Okay, that's how these calculations are done. Okay, that's how these calculations are. Okay, next is John's favorite breakfast is cereal and his favorite lunch is pizza. Okay, probability of John having cereal for breakfast is 0.6. Probability of him having pizza for lunch is 0.5. Now what is the probability of him having cereal for breakfast given that he eats pizza for lunch is 0.7. Okay, so see here, when John given that he eats pizza for lunch is 0.7. Okay, pizza for lunch is 0.5. Probability of him having a cereal for breakfast given that he eats pizza for lunch is 0.7. Okay, so probability of John having cereal for breakfast, let's have it as A, 0.6. Him having lunch as pizza will be 0.5. Okay, so probability of B 0.5. Probability of A with respect to B, that is John having cereal for breakfast given B has happened, that is he eats pizza for lunch is 0.7. Now calculate the reverse. Okay, what is the probability of him having pizza for lunch given he has cereal for breakfast? What is the probability of that? Let's go ahead and calculate that. So if you want to know the probability of having a pizza given that he has cereal in the breakfast, what is the probability? So it will be the reverse probability, that is probability of B by A. So here in this kind of scenarios, Bayes theorem comes into picture. Okay, this kind of scenarios, Bayes theorem comes into picture. Now Bayes theorem so here if you see both this event in the first run, we were able to calculate A intersection B, right? Because the events are interdependent, right? Because the events are interdependent. So, but here the events are totally different from each other. They are unrelated. So in these cases, Bayes theorem comes into picture. Okay, so if we have a conditional probability of A when B has already happened, then using Bayes theorem we can find the reverse, that is probability of B given A has already happened. Okay, we can do that using Bayes theorem. So we know probability of A by B is probability of A intersection B divided by probability of B. B by A is the reverse way. From that we can come to this conclusion, like probability of B given A has happened is equals probability of A given B has happened multiplied by probability of B by probability of A. This line at the bottom is called as Bayes theorem. Okay, so this comes into picture when we cannot calculate probability of A intersection B because the events are not related to each other, they are totally independent, right? In this case or this kind of scenarios, Bayes theorem comes into picture. So probability of A given B has happened. This is the probability that we are going to calculate. Probability of B where given A has already happened. This is the probability of B being true given that A is true. This is the prior knowledge that we have. Probability of A and probability of B, this knowledge will also we have. Okay, so this probability of B by A, this is the historical knowledge that we have. Okay, this is the historical knowledge that we had to have for applying Bayes theorem into our algorithm. So probability of pizza given C as cereal for breakfast is 0.7 into 5 by 6, so that is somewhere around will be 3.5 by 6, so somewhere around 0.6, right? Somewhere around 0.6 it will be. Okay, so where do we use this kind of Bayes theorem, right? Find out a patient's probability of having a liver disease if they are alcoholic. So here in this kind of scenarios we have this kind of Bayes theorem we can use. Okay, so a patient has liver disease, so past data tells you that the probability of a patient having liver disease who walks into your clinic is 0.1. Probability of patient being alcoholic, these are from all past data that you know, is 0.05, and from the patients who are alcoholic, from them the patients who have liver disease, 7% of them are alcoholic. Okay, so this is our B by A. Now we want to calculate probability of a patient who probability of a patient who is alcoholic having a liver disease. What is the probability of a patient having liver disease who is alcoholic? Okay, that we gonna find out. Okay, that we gonna find out. So according to Bayes theorem, 0.07 into 0.1 divided by 0.05, so that is 0.4. That means, so if the patient is alcoholic, then their chances of having liver disease is 14%. Okay, so that's what is we find out using Bayes theorem. Okay, that's what we find out using Bayes theorem. So next slide, it shows you already the things that I have shown. So probability of A by B, this is the posterior, that is the one that we are going to calculate. Probability of B by A, that is a historical knowledge that we have, the prior knowledge that you have, we have evidences of it, we have the past data records like that. Probability of A, this is likelihood of seeing that evidence of your hypothesis is correct or not, right? That means probability of A is the probability. So this is what we are going to test, right? This probability of A we are going to test, and probability of B is likelihood of that evidence that we are using, that B has happened. What is the probability of that event being happened? Okay, so that's how is Bayes theorem. And it's just a 12th class math. We already have like we all already have done these things in 12, so that's this only. Okay, so again the same example that we have. So total sample is 14, total yes is 9, total no is 5, so P yes is 9 by 14, P no is 5 by 14, right? Now okay, so let's go ahead with the example for now. So let's just focus on this this example. So see, for outlook we have sunny, overcast, rainy. So 2, 4, 3 yes, and 302 as no, right? For temperature also, okay, so we create this kind of frequency tables for each of the conditions that we have. So for outlook, temperature, humidity, windy, we have created this kind of tables. Okay, now we will calculate the probability of each of the attribute. So probability of an attribute being sunny is 5 by 14, right? Because we have 5 examples for that. So that way we go ahead and calculate each one of them. Okay, we go ahead and calculate each one of these attributes probability. 5 by 14, 4 by 14, 5 by 14, like that. Okay, we keep on calculating this probability for each of the we have this probability. We calculate the probability for each of the attributes individually. Okay, we create one by one. Then so this will be probability of A. All these attributes will be probability of A. Now probability of each attribute, that is probability of B, will be should we play or not. So 9 by 14 or 5 by 14. Okay, now we are going to find out probability of A given B. Okay,
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
that means here when we calculate probability of yes in outlook sunny, That means what is the probability that the outlook will be sunny when it is given we are playing? That is 2 by 9. Okay, probability of no will be 3 by 5, like that. So if we keep on calculating this, then we will have all this p of yes no values. Okay, we will all have this p of yes no values. That means these are conditional probability of the events. Okay, probability of event A happening, that is probability of the event being sunny, the outlook being sunny when we are playing is 2 by 9. Like that we calculate for each of the steps, each of the attributes, we calculate all these things. Now we have to calculate probability of B that given A is true. Like we will be playing when it is given outlook is sunny. We will be playing when it is given outlook is like overcast, like that. So we will apply Bayes theorem. So probability of outlook equals sunny is 5 by 14, as we know. Probability of temperature being cool is 4 by 14, like that we all know this, right? So now we just go ahead and multiply this result to have the probability of ideal condition, which will be 0.029. That is the probability of ideal condition. Okay, when we multiply all this, so that means those will be the ideal probability for each of the event being happened. Okay, each of the event happening. Okay, so outlook sunny is 5 by 14, temperature cool 4 by 14. So we will just take the highest values from each of them. Okay, highest value from each of them, we will multiply those, and that will yield you the result of the result of ideal condition. So probability of ideal condition is 0.029. Okay, now ideal condition to play the game. So probability of outlook sunny when and play is given, play is yes 2 by 9, temperature cool, play yes 3 by 9, like that we have. So now we are going to calculate probability of playing a game in ideal condition. Okay, we will again multiply all these values to have a value of 0.033. So see here, we have probability of ideal condition into happens 0.029. We have probability of ideal condition when given that we are playing is 0.033. So we have probability of A by B, and we have probability of A into account. Now we will find out B by A. That means when what is the probability that we will be playing when there is an ideal condition? That will be XES into PES by PX, right? Px is again, Pes is 9 by 14. So 0.033 into 9 by 14 by 0.029, which will yield you a 73% of a result. So that's what is about this conditional probability. So we have a 73% of playing when ideal condition is there. Okay, so that's how this Bayes theorem works. Clustering algorithms. Okay, those are unsupervised machine learning algorithms. Now, just to reiterate, what is unsupervised learning algorithms? Unsupervised, as the term suggests, there won't be any supervision for the algorithm or for the model to learn from something. The model won't have a definitive value to predict. The model will try and learn on its own to get the output. This kind of scenarios are called unsupervised learning. That means our model is working on to get something fuzzy, that is the clusters, right? So cluster means, what is clustering? Clustering means to divide data set into groups consisting similar data points. So that means cricketers, footballers, hockey players, lawn tennis players, they are all players, but we can cluster them like that. Okay, so all the cricketers will have the same kind of attributes, same kind of nature, that they will be playing cricket for their country. They are playing cricket, and they are I mean, their profession is playing cricket. So that's what their similarities will be. They will either be a bowler or a batsman, again subclusters among the cricketers. Like that we can think of it as clustering. Okay, so this kind of data sets are random in pattern. and we don't really have anything critical to predict in there except this clustering. Okay, except to divide those data points into similar groups, as many similar groups as possible. Okay, so that's what the idea of clustering is. Okay, now cluster, if you see here, there are cluster of different colors. There are cluster of different colors of fruit, cluster of different types of garbages. So all this can be shown as clusters. Okay, so these are basically clusters. These are examples of clusterings. Now we will see how do we use it in machine learning. Okay, so use cases of clustering. If you see here, we have Netflix, we have Amazon, right? So there is a concept called recommendation engine or recommender engine. What it does, it recommends the products or movies to the similar type of customers. So what it does, it clusters all the products or all the movies that it has to some specific groups, and based on the liking of the customers it suggests. So if a lady logs in, if she has browsed through some lady's product, it will try and show her those kind of products as a recommendation, so that she might be buying one or two items from that list. Okay, for a man it might be cool, like it might be a belt, a wallet, specs, trimmers, and all those kind of stuffs will be shown for guys, or t-shirts for boys, like this kind of things will be happening. So these are basically two kind of filtering algorithms are used in this kind of recommendation engines. One is collaborative filtering, and another is content filtering. So what is the difference? The difference is, in case of collaborative filtering, the products that are recommended based on the customer type. Okay, if some customer has liked some product or bought some product, then the similar type of customer, how do they know similar? They take into account many parameters, let's say age, sex, and their work. Let's say someone is working in IT company and someone is a housewife, so their choices might differ, right? So that's how they show the products into products as an products to the customers, product as a recommendation to the customers. So the customers are grouped, then the products are shown to them. That is collaborative filtering. Content filtering is based on the contents. If someone has bought or liked some product, then the same those items will be shown to other customers, so that they might buy that. So content filtering based on the content, collaborative filtering based on the customer or target group. So that's how you can think of. So these are also some few examples of clustering that is being used in the real world. Okay, this kind of clusterings are being used in the real world. Okay, so Amazon, Netflix, Flickr, and all those places, this clustering is used. Now we can see there are three types of clustering: exclusive, overlapping, and hierarchical. Let's go through those one by one. First type of clustering is exclusive clustering. That means there can only exist, or each data point of the total sample can exist in only one of the clusters. Okay, it cannot coexist in multiple clusters. So k-means clustering is a good example of that. So what it will do, it will take the data points into account, the samples into account, and it will split the values based on that, and it will split it into as many clusters as possible. Okay, as many clusters as possible it will split it into. So in all those clusters will be pure clusters, and it will have only one type of data point. How we do k-means clustering we will see in the next few slides. Okay, so that is the idea of exclusive clustering. Now next comes into picture overlapping clusters. So here it will be overlapped in nature. In data science we really don't use this kind of clusters. In our data science the clusters will be exclusive, and will be used maximum cases we will be use k-means only. Okay, now for this kind of overlapping clusters, the data points are allowed to coexist in more than one cluster. So that means the example, that means it is some kind of fuzzy clustering logic is being going on the behind of this going behind the scenes. Okay, so that is how this fuzzy clustering is done based on the data objects. It can belong to multiple clusters. Okay, next comes into picture hierarchical clustering. So how it is done? It is so the graph that you are seeing in the bottom of the screen is called a dendrogram. Okay, that is called a dendrogram. So how do we do it? First we group the nearby items that is possible. So if you see the leftmost picture, we have A, B, D, E, C and F. So A, B and D, E are pretty close to each other, right? So that A, B will be clubbed together in the same cluster. Okay, so A, B in one cluster, D in one cluster. Now C is near to B, F is near to D. So now in the next step, C will be included in the AB cluster and F will be included in the will be linked to the DE cluster. So that DE as a cluster, F as a cluster will form a new cluster. Okay, so that's what is being shown in the dendrogram also. So C comes into AB, so that is another cluster, and F comes into DE, so that becomes another cluster. So these are two clusters are there, two definitive clusters are there. Okay, and inside each cluster there are two segregated clusters. Now if you see in here, the distance between C and D is also minimum. So C and D is again clubbed and again another cluster is formed. So that's what the dendrogram also shows in the bottom and at the end of the picture. So the cluster DEF is pretty near to the point C. So those two clusters are also linked. So if you carefully see the dendrogram, you see there is an hierarchical relation between all this data point in this sample set. So this is again this is an example of hierarchical cluster. Okay, so this hierarchical cluster is also not much used in data science. So we will be only focusing on this exclusive clustering for this class. Okay, so this is what is the example of hierarchical clustering, and we discussed exclusive clustering and overlapping clustering as well. So, as we discussed, exclusive clustering, and the type of exclusive clustering algorithm is a k-means clustering algorithm, right? So, what is k-means clustering algorithm? How you can use it, and how the algorithm actually looks like? We will see that in next few slides. Okay, k-means is a clustering algorithm which focuses on to group similar elements or data points into clustering. Now you might be you might be wondering why k and why means, why no other name, right? So k in the k means represents the number of clusters that we are going to make. Okay, so if a data point has 3 clusters, that means it will be 3 means algorithm. Now why means? Because it calculates mean of the data, distance between two data points, and distance between mean of a cluster and each data point. It calculates the entire calculation of k means depends on the mean calculation. So that's why means. So that's what k-means clustering does. So what does k-means clustering do? K-means clustering clusters the data into k number of clusters. Okay, that's what is the use of k-means algorithm. How k-means algorithm finds finds this how this k-means algorithm how this k-means algorithm groups those into different clusters. It uses the difference between the mean of the data points and the difference between the mean of the cluster and the data points, and it keeps on grouping those. Okay, I have a question like, is hierarchical is used in real world? No, Tom, it is not much used. There are use cases where it is used, but not much used for data science. Those are for astrophysics and high level of physics and maths research that is being used, and there hierarchical clusters do exist. Okay, so for machine learning it is used, but not for data science. Okay, for data science our world is really small. We only play with data. we will only play with real world data, so there won't be much of an scenario like this. As you can understand, that's something when you work with electron, protons, neutrons, you might get those kind of things. Okay, that's what. So that's when you get those kind of things. Okay. Next is this is an example like pile of laundry. So we just clear this thing. Next is business application of k-means. That means real world scenarios. Where do we use it? So we use it for behavioral segmentation, like kids, adults, something like that. Sorting sensor measurements. Yes, we do take the sensor. We have a lot of sensors, right? So we take those data in and we can parse it using this clustering algorithm. Let's say this is a home. This is a big home. This is a multi-storied building. This is a small home. This is a hut. Like that, we can do detecting bots or anomalies. Yes. So the behavioral pattern of the users can be clustered, and we can directly see the anomalies when a bot entered in a system, right? Next is inventory categorization. That means we can group different items and we can keep the inventory like that. So how much item is needed for which item is needed in what quantity, we can take into account all those things. And bots and anomalies, we can directly segregate the human behavior and the bot's behavior from the if a bot enters in our system. So in these cases, k-means algorithm is really very helpful to cluster these things. These clusters means a lot. Okay, so that's how it works. Now we will be going through the example of k-means clustering. Okay, let's go ahead with this example. So what do you see here? We see four balls in different positions, right? So how many clusters do we have here? Three. One, two, three. So here number of clusters will be 3 and k equals will be 3. So this is what we need to get from the data point. Okay, we need to segregate these three cultures based these three clusters using k-means algorithm step by step. So this is the final requirement that we currently have. Okay. Next is, what is the steps of k-means algorithm? We select the number of clusters to be identified randomly. Okay. Let's say we are assigning the first point to the nearest cluster, that is red. Okay. So for this point, this is the nearest cluster, right? So this is red. We are assigning it to red cluster. This we are assigning to purple, and this we are assigning to blue. Now we will see how we can go through step by step, and we can get this thing clustered into this four are red, this four purple, this four blue. Okay, so the first step will be we assign the first point to the nearest cluster, that is the red cluster. Okay, that is our first point. Next is we calculate the mean value including the new point for the red cluster. That means this one and this one are the two values. So this will be the mean point of the new cluster that is formed, right? This will be the new mean point of the new cluster. Now, which cluster does point 2 belongs to and how? So this cluster is now for second point, we will calculate the distance between the red second red point. Okay, that is this mean point. Okay, we will calculate the difference between this point. So the idea of k means is, let me show you this first. You will get a clear idea for that. So see, initial cluster center is mu1 to mu k, where this all belongs to random number, real number. Okay, then repeat until convergence. So till when should we repeat and what should we do? For every I, we need to set the distance or the minimum distance between a point and its mean of the cluster squared. And then for each j in the set, we calculate the mu j. Mu j means, so j is the number of clusters that we have, which will run till k. Okay, so we find the mean of each of the clusters. So we find a new centroid, and find a new centroid, and then we assign that value to some clusters j. Okay, ci equals j. So we are assigning the value to the cluster, and then we are calculating the mean of it. So this is the two-step algorithm that we have shown. Okay. So what we are doing here, first step we are assigning this point to red. Okay, this fourth point to red, this point to purple, this point to blue. Now what we are doing next, from the first point we are calculating the distance from the from this red point, purple point and blue point. Nearest is red one. We are assigning this to red cluster. We are calculating the mean for these two. So these two are in a current cluster. So we are assigning a mean for it. So the mean comes in somewhere around here, just an arbitrary value. Next, what we will do, we will find the distance between the next point, that is this point, and all these points from this mean point. So let's concentrate on this point only. So for this point, we will calculate the difference between all these three values that we have for the cluster. So the minimum difference will be this one. So we assign this to red cluster again. Now we have 1, 2 and 3 elements. We shift the mean. So it will be somewhere around here, right? So that would be the next step. The mean now shifts in, right? So mean now will be somewhere around here. So now we are calculating for this third variable. Okay. And again we calculating distance for these three centroids. We find this to be the nearest and we assign it to red also. Okay. So now the red mean shifted to here. So it is nearer to the red mean. So third point also gets into red point. Now the red mean shifts to somewhat right. Okay, now we calculate mean of this 4 and we have it here. Now we go to the next point. We calculate distance from this red mean point, this purple point and this blue point. We see the distance from blue point and this one is minimum. So we purple and this one is minimum. So we assign it to purple. Calculate mean comes in here. So this point now, so which cluster it should belong to. Okay, so to which cluster this point belongs to, this will seem to be this belong to this blue cluster. So this blue is now printed and now this is the mean. So again what we will do, we will take this 4. So this all these 4 are located close to blue, right? So we will assign all this floor one by all this 4 one by one to this blue cluster. So that's how it will look like. So 6, right? So 6 is the six values are there in the blue cluster. That is what is the result from one iteration. Now what we do now, how this works, this k-means when the convergence comes into picture, just have it in mind theoretically. So when this k-means stops, ideally k-means doesn't stop its iterations till it has all the data points are in equilibrium. That means the data points are not changing. Okay, so after we included this 4 points to the cluster, you see radically these 2 points distance from this blue one gets increased, right? So this point's distance from purple one now much closer than its distance from blue line, right? So we will mark this cluster to purple. Then this point again this will come to here, we will mark this to this purple cluster. So till like this it will start. Okay, so this time we will that's how we will be assigning the clusters. Okay, so that's how we will have the 3 points in a particular equilibrium. Now if you see here, all the points are located in their nearest clusters only, and we don't have any other alterations won't be there in this cluster, right? So that's what is k-means does. Okay, so first iteration it will do somewhat, second iteration it will do somewhat, and the third iteration it will give you the perfect result. So that is a 3 means. Now the next question comes, how to find the value of k. That's a big interesting question. So how do we know it? Okay, so to find this value of k, what we do, we take a value, we do use Witten trials in here. Okay, so what we do, we take all we take the value of k as 1. That means we think there are only one cluster. Okay, so what we do, we color all the points to red. Okay, because if we think that if we have one cluster, we paint all the points to red color. If we have two, then we have now okay. So but how do we find out the value of k? Okay, how do we find out the value of k? What we do, for the previous example that we have solved manually, we see that k value of k was equals 3. But how do we know it? How do we calculate in the algorithmic perspective? We won't be knowing the data set that we are working on. How do we calculate? Okay. Now next step is to calculate the total variation. So we will calculate distance between all the data points from this mean point. We will see a large variation. We will change the value to 2. Okay, k equals 2. So we will have two clusters like this. So this so now if we have total variation calculated, then we will see it is somewhat better. Now we go for k equals 3. Okay, so now if we see the total variation, it is much better. Okay, now it will k equals 4, then it will still be better. Okay, so till like this we keep on continue. Okay, but how do we stop this algorithm from growing, right? It might go with all, I mean it might go. Okay, now this is a graph. If you see this graph, this is an elbow shaped graph of cost function for this. So this elbow where it comes in, the curve bends near the elbow. So this elbow point is the best case scenario. Okay, so this is the best number of clusters that can exist in a data set near this elbow point. Okay, so that's where when you see, so what do we point? We just plot the total distortion or the total variation in the data set with the number of clusters. Now if we keep on plotting this, it will bend at some point, and this bend is the ideal number of clusters. So that is 3. Okay, so that's how k-means works. So that's how k-means has its k-means knows where to stop. It has this elbow value. Okay, it has this at elbow point, it stops. So k equals 3 is the ideal cluster number for this. Okay, that's how it works. Y-axis is the distortion. That is the variation that we were discussing. Okay, so if we keep on increasing the clusters, after some point the variation will be parallel to the x-axis. That is, it will have some definitive value of y. Okay, so it will be stuck at some point. So till which point the variation decrease, that is this elbow point is the required number of clusters that we take into account. Okay, so that is the idea of this k-means clusters. And for this example, if we plot this, the total variation, we will see for k equals 3, it is taking a slight bend. So we stop it right there. So that's how k-means understand where to stop. And at this point, we say k-means algorithm has converged. Okay, so that is the convergence criteria of k-means. So that's what it is. Okay, next is what if we had our data plotted in x and y axis. Okay, so the same thing, right? The same thing. So what we will do? So let's say for here we have shown in a linear line, right? Like a linear plane we have shown. Now let's say the values are in this plane, xy plane. So what we do? Let's say we start from k equals 3. So we will take 3 random points in there. Okay, we will calculate the point distance. As you know, that is Pythagoras, root over of b square plus b square. So we will find the distance between these points and its nearing points. We will then assign that nearest point to the cluster. We will calculate mean. We will keep on calculating the means and all and all and all. We will keep on going till this cluster reaches its like convergence criteria, until we have all the convergence criteria are met, until we have this happening. Okay, till we have this thing in optimal number of clusters as an output. Okay, so that's how we can do.
Consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo. And they are facing a major problem, and that basically is their customers are churning out to other competitors. Now, you as a data scientist at that particular company have to make sure to stop this churning out, and also how to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you'll go ahead and build the ML algorithms on top of this data set. So you'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right. And we'll be working with this customer churn dataset. So this is our dataset which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on, right? So yeah, so this is our first task, data manipulation. And to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd, and then I'll also load the numpy library. So I'll type in import numpy as np. I'd also need the matplotlib library. So I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read_csv, and inside this I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used. And then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year. And there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the 5th column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my 5th column over here. And I will store this in, let's say, C_5. And I'll have a glance at the head of this, C_5.head. Right, so we have successfully extracted the 5th column from this entire data frame, and this is the head of it. Similarly, we'd have to extract the 15th column and store it in customer 15, right? So if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0, right? I'll store this in C_15, and I'll also make this to be C_15. I'll click on run, right? So this is the streaming movies column, and I get the same thing over here. This is column number 15, and I've extracted only this particular column from the entire data frame. Right. This was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right. So there are 3 conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these 3 conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender, and the gender needs to be equal to male, right? I'll cut this and paste this inside this. Of this, I'll use the AND operator and then given the second condition. So the second condition would go something like this, customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. Right. So I have all of my three conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these three conditions and I will paste them inside this, and I will store it into a new object and name that object to be crandom. Right now I will print the head of this, crandom.head. So we see that this, so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given three conditions over here, and all of these conditions have been satisfied. So next up, we have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the two conditions. So either the tenure of the customer needs to be greater than 70 months, or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below, and all I'll do is cut this and paste it inside this. Right. And I will store this in, again, crandom. Now let me again print the head of this, crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here. Let me delete this from this. Right, so we have these conditions over here. So we'd have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes, right? So I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just three records, or there are just three customers who satisfy all of these three conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these three customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these three conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here, and I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn, and then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers who will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'd have to create a simple bar plot for the internet service column. And yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt dot bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in two parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Right, so the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this value counts, and from this I don't want the values, I just need the keys. And again, I'd have to convert them into a list. So I'll use list over here. Now I'll click on run. Let's see what do we get, right? So these are the 3 levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has 2 things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421. And number of customers who don't avail the internet service are 1526. Right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, I had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the x label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. So this would be plt.ylabel, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt.title, and I'll set the title over here. And the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, this is where you understand all of the patterns in the data set and you get insights from the data set. Right, so next up we have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So yeah, so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here. And the title of the plot needs to be equal to distribution of tenure. I'll do that. All right. So I have created this plot, and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right. So next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right. And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot, And now all you have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data. We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and yep, we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Run columns, customer churn. What seems to be the problem over here? Monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two. Y dot head, and x dot head. Right. So these are the values from monthly charges column, and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are X train, Y train, X test, and Y test. These are actually the labels which we conventionally use. I'll explain what these are exactly. X train, Y train, and then we have so this would actually be X test first, X train, X test, Y train, and Y test. So over here, X train represents all of all of those values of your features which are present in the training set. X test represents all of the features which are present in the test set. Y train represents all of the dependent values which are present in the train set, and Y test represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of X train and Y train. Let me also show you the shape of all of these. So X train dot shape. Let me do the same for the rest. X train dot shape. I'll make this to be Y train. I'll make this to be X test. And I'll make this to be Y test. Right. So X train, Y train. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. So these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have X train, Y train, X test, and Y test, then let's go ahead and build a model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, and but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. but when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail. Right? So this is the reason why we divide the data into training and testing set. Right. So now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X train and Y train. Right, so I've fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done. And for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this and let me ease this to be in this over here. Right, so we get a root mean squared error value of 29.39. Right, so now let's say if we build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and if the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here, we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here, what we're basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges, and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test, right? So this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into X train, X test, Y train, and Y test. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. Right, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set, and then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So X train and Y train, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right, so this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again y pred. Right. So we have predicted the values now. Right. So when it comes to a classification model, we can use the confusion matrix. Right. So let me import the confusion matrix. So from sklearn.matrix, I will import the confusion matrix, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in y-test and predicted values are present in y-pred. Similarly, accuracy score, I'll do the same thing. Y-test and y-pred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651, and I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model, or the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charu, the question which you're asking, what if we had multiple independent variables, right? So over here, we have two independent variables. So this time the independent variables are monthly charges and tenure. And I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same. And the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model. I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion matrix and accuracy score, right? Now over here, again, I'm calculating the confusion matrix and this time I get an accuracy of 77.50, right? So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211. Right, so we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right. Now I will go ahead and also import the decision tree classifier. So from sklearn dot tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree, right? And I'll go ahead and fit the model on top of the training set. So my tree dot fit, this takes in two parameters, which are x train and y train. I fit the model. Now it's time to predict the values. My tree dot predict, and I'll be predicting on top of the x test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion metrics now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys. Right, what we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the train data, and then we'll take the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part, right? So because to the model building the, so it depends on your problem statement, Aditya, right? So let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories, or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest, random forest is always better than decision tree because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees. and the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same x and y values. No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally, we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn dot ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and with the model on top of X train and Y train. X train and Y train I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion matrix over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in y test and y pred. Y test, y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. You'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set, and then you'll break the values on top of the test set, and finally you'll calculate the accuracy, right? So this is your entire end-to-end project on the customer churn dataset, which comprise of data manipulation, data visualization, and implementing all of the machine learning algorithms.
So, did you know that whenever you talk to any of the customer services, customer supports, or any of the other tools out there, there is a 90% chance that you're actually talking to a chatbot and not a human being? Did you know this? Well, 90% of the time. So, let's say you respond or you communicate with certain companies, for example, like 10 times, out of which 9 times you're talking to an artificial intelligence powered machine and not a human being. Did you guys know this? Well, this is a fact, and I think this is amazing. amazing to begin with. Because whenever you are concerned with talking to Amazon, for example, Amazon is a very famous e-commerce site, as most of you would know. So you can leave them a message saying, hey, where is my order? I ordered, for example, this item, this mobile, or whatever it is, on this date, and I don't know where it is. So certain responses like this, instead of having a human reply to you, they can actually program in such a way that there is a chatbot sitting at the background, and this bot will basically have all the details about your order, and it can tell you where your order is, when it will reach you, if there are any delays, why there are delays, or much more.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So, for mundane tasks like this was just a very quick example for you guys. Chatbots have been implemented everywhere. For example, when you think about Netflix as well, even Netflix, for example, let's say your subscription was ending or something, and you just ping them asking, hey, I just paid, but my Netflix still says, my subscription is not paid for. In that case, there is a chatbot which will actually reply saying, it takes 20 minutes or 30 minutes for your payment to be confirmed into our systems. And I mean, this happened to me just 3 days ago. So basically, I was working on chatbots in Python, and again I realized I was actually talking to a chatbot when I just went to watch something on Netflix as well. So that's just, I was saying, these are two very simple examples. 9 out of 10 cases you will actually be talking to a chatbot. For example, if you just check out the Intellipaat website, we have Alex is an AI powered chatbot as well. So basically, whenever you use the live chat option on the Intellipaat's homepage, you are actually talking to a chatbot as well, and it's a powerful chatbot. So if you haven't checked it out, make sure you check out after the video. Again, I'll be showing it to you at the end of the session as well. So if you want to check it out, make sure you stick till the end. So on that note, we need to understand what chatbots actually are. So as the name suggests, chat and bot has something to do with a robot imitating a person, while chatting to another person. So when we have to break it down into a little bit of simple terminology, basically it's a software which is based on artificial intelligence, and this software will try to imitate humans. It'll try to basically, perform the same actions as us human beings without the person, having a very good idea if they're talking to a human being or an AI. If your chatbot is very good, if the chatbot which is being implemented is amazing, well, the human can be fooled enough to not know if they're talking to a robot or if they're not talking to a human as well. And most of the time you wouldn't even require that kind of a complexity, because let's say when you're in the Amazon case as well, where is my order, or why has my payment declined, or whatever it is, you will have a very simple question to which there will exist a straightforward answer, right? So it'll not like Amazon's chatbot will start telling you stories about why your payment failed or why your order didn't come or whatever. So when it comes to that, if it is very subtly implemented, if it is very complex in the back end, you will not find a difference between it being a robot or it being a human being as well. Way back in the 70s and 60s, there was a test which was very famously implemented across the world. It's called as the Turing test. If you guys didn't know on that, make sure you read up on the Turing test. It was amazing on how artificial intelligence is such an old concept, but it's being used a lot in the 21st century. So whenever you think about artificial intelligence, ladies and gentlemen, the first couple of things that should come into your mind is, for example, Siri of Apple, Alexa of Amazon, or the Google Assistant. These chatbots again have been in our lives most of the time, right? For all the Apple users, you guys have Siri. For Amazon, we have Alexa, and for the Android phone mobile users, we have the Google Assistant. So you might have been using these on a daily basis, because I use Siri a lot and I use Google Assistant a lot as well. And I do know people who use Alexa for their home automations and much more. So when it comes to stuff like this, from the simple Amazon chatbot all the way till a complex powered bot such as Siri, Alexa, or Google Assistant have been helping us daily. So in fact, you can ask the Google Assistant or Siri to play any song for you, and in fact, let's say you're sitting at a restaurant or something, you listen to a beautiful song that's being played, and you just want to find out what song it is. Instead of going through all the pain of installing a software which will listen to the song and tell you what song it is, or you asking the restaurant manager what song it is, just pop out your phone, say, hey Siri, what song is playing in the background. Siri, or in fact even Google Assistant, will actually analyze the song, it will listen to it, and it will tell you, hey, this is the song that's being played. How simple is that? For example, you want to set a calendar invite for the next month, or let's say, you have a meeting which you want a reminder for, you want to set an alarm. So all these manual tasks which you could do basically with one voice command, you can get all of it done very simply. And I think that's the essence of chatbots, ladies and gentlemen. So again, coming to emphasize on why we require chatbots, well, when you look at it, the first thing, it's cost and time effective for the companies, because developing a chatbot does not take a lot of money, and it makes sure that it can be done in a quick and a rapid way. As you'll see in the demo which I'll be showing at the end of the session, it will basically validate this point on how time effective it can be when we are working with chatbots, because it's pretty simple, it's pretty straightforward, and at the end of the day, even when you're working on an enterprise level, basically you're working at a level where you have a huge organization which requires a chatbot, it will not really cost much to build it as well. And of course, adding on to the last point itself, coming to the second point, it's cheap development cost. When you're working with chatbots, you need to understand that there are only certain things at this point of time that we can do with chatbots. Of course, with every passing day when we're talking about technology, there are again thousands and thousands of things which keep coming into the market. But with chatbots, you can have it respond, you can have it imitate a human to the best of its ability, right? And with the current power of AI, I think the entire world is pretty much just trying to make sure that their chatbots are as human as possible. So with cheap development costs, there are again a lot of companies which are jumping on the need of chatbots as well. So how would it help the companies, you might be asking? And the best thing is human resource. See, if you have a person who is responding to live chat, which is basically a mundane task, right? They keep doing it again and again and again. So this person as a human resource can probably put into a more effective role. This person can be put into a more productive role rather than answering the queries of customers, which can easily be done with the help of chatbots, right? So it's saving time, it's saving money, and pretty much it's increasing the productivity of the company as well. This is the primary reasons why thousands of companies across the world today have implemented chatbots. And the next point again adds on to the previous point as well. So since your company is being more productive now with the help of chatbots, again you can pretty much give that wow factor to your customers. And if it's not the wow factor, which is basically what you're looking for, you can help your business brand itself through all the social medias out there by showing the world, what, I've implemented artificial intelligence here. And you would invite the world, you would invite the developers, customers, or whoever it is to check it out and see if they like them, to see what's going on. And this again directly translates to you talking to your customers in a more customized way, and this will probably help your business in the short term as well as the long term as well, right? So it makes sense. So what do you think? I mean, there are millions of other chatbot cases that we can think of as well. For example, there are doctor apps and health apps which will basically diagnose any condition that you might have. So you can pretty much type in the symptoms and say, this is what I'm facing, and it will probably give you a very vague outcome of saying, hey, you might have this kind of a condition. Of course, you should consult an actual doctor and not rely on these chatbots at this point of time, but then we're getting there. Who knows, probably 10 years from now, the world of medicine can be revolutionized by keeping chatbots very accurate with respect to the field of medicine as well. And that's the thing about artificial intelligence, right? So when you think about it, the possibilities are actually endless, and we've started seeing those endless probabilities in the last 10 or 15 years or so. Coming to the next point, which is chatbot evolution. So this is one important concept, because when we talk about traditional chatbots, so all these traditional chatbots that we have seen all these days basically are system driven. So by system driven, what it basically means is that they have access to a small amount of data, and they have responses which basically they know what to reply for when you ask. For example, if you have to take the Amazon case again and simplify it to a level where there is a possibility is that the customer might ask two questions. The first question is, where is my order? And the second question might be saying, why is my payment failed? So when you have to break it down into simple terms, and the bot recognizes what question you might throw at it, giving the answer to it becomes very simple. So that was system driven. And automation scripts, as I just mentioned, if there are a certain number of questions which the business things that you can ask, they can program the answers automatically for this as well. And this relates to a minimum amount of functionality, because the chatbot cannot really think and grow and understand from what the customer asks. So it already knows the question, it basically maps that to an answer, and it just gives an answer. So it's basically a give and take policy where the bot might not be learning anything. And then coming to the current bots of today's world, these implement task level automation. So basically with task level automation, they know what they're seeing and they can understand the context between the tasks and all of the system requirements that exist. So basically if you're asking a question, the simple question again saying where my order is or why my payment has failed, it'll already have a system context there in place, saying this is the question, this is the answer, give the customer the answer. With task level context, it will know what task has to be done to arrive at that answer. So it's not like take a question, find the answer, give you the answer. So it's take a question, analyze, and then give you the answer. So with current bots, that analyze part that exists right now. So the communication level is intermediate. So probably 7 out of 10 times or 6 out of 10 times, you will not figure out that you're talking to a chatbot. So that's how interesting and intimidating it's become right now, that it's getting good. We're getting there. And customer help. Well, current bots basically have been put into a use of, for example, project support, customer service, front desk management, and much more. So if we have to talk about the future bots will have multiple levels of communication which are cross-linked with each other. What this means is that at the end of the day, when you are talking to a bot, you can ask the bot to get some task done for you. You can ask it queries and get questions. It can perform analysis for you and much more. And all of this coincides to one thing called a service level automation, basically, which will ensure that all the tasks which are to be done manually, all of these can be automated easily as well. So it understands system level context as the traditional bots, it understands task level context as the current bots we have in place, and the best part is it'll get people context as well. So it'll understand who you are, and it can start generating and recognizing patterns in between people, what people are requesting for, why they're requesting for, who requested it. So out of billions of people across the globe, if you keep asking and training your future bots on a certain number of questions, or you keep asking it something, it'll recognize that the question is coming from this particular person. So that's how powerful it can actually get. And of course, in the future as well, there are multiple concepts such as bot OS and master bots. So bot OS is basically an operating system which is completely revolutionized and revolving around the usage of bots for your use as well. And master bots are basically bots which can control a certain number of chatbots under them and control some amount of context, some amount of functionality which are given to them to handle, basically. So they are the bots which will handle other bots, something like these. So something like this. So again, when we have to get a quick vivid comparison, I thought it was very vital for you guys to understand this about the traditional, current, and the future bots as well. Going to the answer of how does a chatbot actually work? Well, there are two types of chatbots when you have to think about it. One is something called as rule-based bots, and the other one is called as self-based bots. And the other one is basically self-based bots. So when you talk about rule-based bots, as the name suggests, there are some rules on which these bots will basically work on. You ask a simple question such as where is my order? Your bot will recognize the word where is and probably order. And this is a rule which is programmed in the backend which says when you find all these keywords, just give them an answer saying, hey, your order is here. Your order is on the way. Your order is delayed, whatever. So you cannot ask any complex queries to a rule-based bot because it will not have rules in the backend which will basically help it understand. So think about rules if they are like a book, all right. So it will basically look into this book for an answer. If it can find it, it will tell you, or else it cannot. So it's as simple as this. And most of the time, the training of these bots are really simple and it is not complex. And what this coincides to, it basically means that you can ask simple queries, get simple answers. If you ask complex queries, it might fail. And now coming to self-learning bots. Self-learning bots will make use of concepts such as machine learning. It will make use of concepts such as deep learning to basically understand what you're trying to tell the bot. It's not like there's a book, it will blindly refer the book and give you an answer. So it'll try to understand why you're asking this, what you're asking, and how best it can think it can give you the answer. So this line that I just said, this is very important for self-learning bots because this is exactly what makes it highly efficient, and it is basically a trick to learn and to basically fool you into thinking that it's a human being, and that of course is very good for us. That is what we're looking for here as well. But then training a self-learning bot will take a lot of effort, because it is a very complex process to think about working with a lot of data. It will be terabytes worth of data for a very simple response generation as well. So training it with a lot of data, helping it analyze, and helping the bot give us an answer based on an analysis rather than a textbook definition is something which is very complex as well. So these two are the basic types of bots which we work with in today's world. But then when we have to talk about self-learning bots a bit, because again, when you're talking about artificial intelligence, when you're talking about machine learning, there are again two more types of self-learning bots. So they're called as generative bots and retrieval based bots. So let me talk about generative bots for a second here, and it's going to give you an answer. So basically you might be wondering, okay, so if I ask it any complex query, will I get an answer because it's using artificial intelligence? Well, the answer is no, because even though it can do word-to-word analysis, there are certain limitations here which will not allow it to give you an answer every single time. So in that particular case, generative bots actually have the upper hand when you think about retrieval based bots, because retrieval based bots are, again, they have predefined responses. So there are so you ask a question, it will go somewhere, pick up your answer and give it to you. So it's content based. No, so it's context based. With context based, it knows what you're asking, but it does not know. So it does not know how it can improvise its answer to basically give you the best answer out there. It knows that it can give you an answer, but it doesn't know how it can give you the best answer. For that, you need generative bots. Your generative bots will analyze the accuracy, it will analyze the likeness of its answer, and then it will give it out to you. So with self-learning bots, these are the basic examples. I'll quickly repeat it. So with generative bots, it knows and analyzes your answers before giving it out. With retrieval based bots, there are certain predefined responses where it just picks it up and it learns a little bit on that and then gives it to you. With generative bots, there's a comprehensive analysis which goes on with every single word that you put in, and then it learns. With retrieval based bots, it will look and hunt for a context, and once it finds that context, it will go back to the responses which are stored again, and then map those contexts based on responses and give you those answers as well. So on that note, next we'll have to check out something called as the chatbot chart. So basically, when you're working with a chatbot, right? So, there's a good chance if you're either talking to the chatbot via messenger, you're communicating via website, or, you're probably using a mobile to talk to Siri, Alexa, or all of the chatbots that we discussed. So as a human, you will be giving it certain inputs, and the chatbot will give you an output. So whatever inputs you give, right, so it will go into something called as a chatbot server. So the chatbot server will have three important things if you're talking about self-learning bots. So it will have certain knowledge, and this is like the book that it will go on to hunt. And it will have rules. Rules is basically like an index to the book saying this is where you need to look for the answers in the book. And then of course it will have machine learning, it will have artificial intelligence saying, hey, learn to understand these rules and learn to understand where you can apply these rules to find the context in the knowledge. So it's something like that. And to do all of this, it needs a lot of data, right? So there are numerous data sources across the world. It can be something as simple as learning from Twitter, all the way to learning from certain studies, which is like probably 35,000 pages long or whatever. So everything from simple to complex data sources. It might be on the cloud, it might be social media, or wherever it is. Your chatbot server will pick up all of these data sources. It will try to understand what knowledge can it learn based on machine learning and what rules it has to apply, so that it can arrive at this stage where it knows stuff. And then it's not important that it has to know stuff. What's important is that it has to find a way to convey all of this it knows in a human way, imitating a human, right? So that is again an important thing. So basically this is like a one picture, one stop solution to understand the basics of how a chatbot would work. On that note, we can actually go on to building our own chatbot. To do that, there are certain things we need to walk through as well. And the first thing is prerequisites when you're working with Python. There are two amazing libraries, and two among, let's say, thousands of beautiful libraries of Python, because I'm a huge fan of Python for the reason that it has amazing libraries. So there are two main things which we will be using to build a chatbot, and it's pretty common and obvious as well. So we have scikit-learn, which is basically used as the machine learning library for Python, and there is NLTK. So NLTK is again another amazing library, as we'll be walking through step by step to understand what makes NLTK what it is. So it's an amazing natural language toolkit. That is what NLTK stands for, and it's widely used in today's world to ensure that they can make a very good chatbot as well. So to give you a quick revision of what NLTK is actually used for, so this natural language processing, this natural language toolkit is actually used to process certain human language data. Well, mostly it's English, because again, English is a widely used language. So it is basically used to understand how this chatbot can be built by making it understand the words. See, for example, you will know what an apple is, you will know what a ball is, you will know what a cat is. This is because from your childhood till today, you've been taught A for apple, B for ball, C for cat, or whatever it is. So you have been programmed over the years where you know what all of these are. But then as soon as your computer sees a cat, there's a good chance that unless it has any training, it is just a text which says cat. It will not understand that it's seeing a cat, or that the context is a cat. So to teach it that context, saying whenever I type a cat, you think of cats. So that aspect is basically where NLTK comes into play. And to do all of this, there are many concepts. There's classification, there's tokenization, there's stemming, there's lemmatization, there's parsing, and all of this. But to get to all of that, of course, we'll be checking out all of these. The first thing you need to do is you need to install NLTK. And to install NLTK with Python, there is a very simple command with pip, the package manager. It's pip install NLTK. And once you clear this step, you have NLTK installed and you can work with it. So coming to the terms that we have put down there, classification. So classification, when you're working with data, basically is where you help the chatbot understand what type of data it can see. For example, there are certain words, which are used very commonly. They're called as stop words. So, for example, the, is, that, was, all of these are stop words which will arrive, and you will be using it multiple times in a given sentence, right? So I might have used the word like 100 times or more than that in this live session as well. So you need to understand to classify what words are very commonly used, what words are not very commonly used, and more. And then tokenization. So tokenization is this process where each of your words are actually broken down into events. And so tokenization is this process where each of your words are broken down into single entities, and these entities are called as tokens. Tokens are basically the input to the chatbot that you give, saying, hey, you know what, this is a word, understand what this means. And then coming to stemming and parsing, we're going to check this out in a bit of detail in a second now. So to make your bot understand text, the problem here is that your machine, when you're using machine learning, when you're using artificial intelligence, deep learning, whatever it is, it will require some numerical features to work with. It will require numbers, it will require vectors, it will require matrices to work with. It does not require strings, and with the help of strings it cannot learn. So how do we solve this problem? Well, let me tell you with pre-processing how basically the text pre-processing works. There are two things. One is case conversions and the other thing is tokenization. So again, before we delve into tokenization and case conversion, let me repeat why we are doing this. So when you're using machine learning, when you're using artificial intelligence, your bots or whatever you're building, it will require to understand zeros and ones. It will require numbers to understand, and it cannot work with text. So we need to find ways to convert our text into these numerical graphical features, right? And hence we're doing the text pre-processing. Okay, so coming back to the methods, so there is case conversions and tokenization. With case conversion, for example, lower cases might mean different and upper cases might mean different. Let me tell you. So when you're starting out a sentence, you always start with an uppercase, but in the middle of the sentence, you will not be using any uppercases unless it's like a proper noun and certain reserved keywords, right? So your computer needs to understand this, and basically to do all of these, we will be converting everything into one case, usually when you're working with building a chatbot, because when you're thinking about keeping the same case and helping your machine teach, it becomes a very complex process. So to keep it very simple, we'll have the cases converted. So everything in a sentence, it'll either be lowercase or everything in a sentence will be uppercase. So that's why we need case conversions. And when we talk about tokenization, as I just said, you'll be breaking down your sentences, your words into a list. So that's basically sentence tokenizers and word tokenizers. With sentence tokenizers, each of your sentences will be broken down into singular entities. With respect to word tokenizers, each of your words are broken down into structured entities called as tokens, and these form as the input. So when we have to talk about how it works in NLTK, we have something called as the NLTK tokenizer. And since we're working with the English language out here, so there is a pre-trained tokenizer which will already understand what you're typing in, and it's basically the pre-trained punct tokenizer which is present as a part of the NLTK library. Alright, so one important thing you need to understand is that your text might contain a lot of things which is not required. For example, there are a lot of numbers or letters which you might not make sense of, or your computer might not sense of. So basically we need to remove all of these words, and this process is called as removal of noise, because this is noise through which it will not help us in any way building our chatbot. And then stop words, as I just mentioned, right? So is, was, and the, all of these are very common stop words which need to be removed to ensure that your chatbot is not confused when it's working with words. So stop words have been removed, or they are pretty much categorized differently. And then stemming and lemmatization is where things starts getting really nice, because when you're thinking about stemming, so stemming is basically a word which is derived from its stem. So let me give you an example of a stem word. A stem word may be learn, Learn, learn. So when you're talking about stemming these words, think about the concepts such as learnt, learning, learned, learn. So these four words, right, which basically has something in common, which is Learn. You can have Learnt, Learned, Learning, learning. So learn is common in all of these words. So learn becomes a stem word through which you can give context to all of these other words, right? So that is stemming. Now talking about lemmatization is a little bit different from stemming, and here is why. Here we talk about context rather than the words itself. See, for example, if I tell you good, better, and best, it gives you a positive connotation and it gives you a general meaning of something is good, right? So good also means it's good, better means it's good, best means it's good. So you need to make your computer understand that good, better, best all have a positive connotation and it means something is good in general. So lemmatization, all of these lemma concepts that we talk about is basically this, giving your context some meaning. So I hope I was clear with stemming and lemming. Stemming is where we use these stem words and basically derive something out of each word's process, processing, processed, all of that. With lemmatization, it's basically context-based learning, good, better, best, where you're giving meaning to the words you're checking about. And then talking about the input to a chatbot, it's of course when it has to learn, it needs input, right? So basically as I just mentioned, since it cannot understand strings directly, all of these strings are converted into numerics. So basically we are doing this by converting text into numerics based on their requirement. If they're required, they're considered. If they're not required, they're not considered. And you might be wondering why a concept like this is called as the bag of words. Why can't you just call it input? So it's called bag of words because here we're trying to consider the words which have come in. So we do not care about the order of words which come in. So if there is a sentence which says, I like Intellipaat, with the bag of words, think of it like you're dumping the words in the bag where you do not care about the order. For example, I like Intellipaat can become Intellipaat like I like Intellipaat I, or whatever order it is. So your sentence might not make sense grammatically, but all the words are there in a jumbled order. So it's like taking these words and putting them in a bag and jumbling them up, or even just putting it inside without any order. That is why it's called as the bag of words. And now coming into how it is basically processed. Let us take a raw input, and this raw input is something like a sentence which says, I do not like chocolates. Of course, there's not a lot of us who do not like chocolates, right? So ladies and gentlemen, again, let's keep this session interactive. So head to the comment section and put in your comments so we can understand and help each other out better here. So again, coming back to this, with respect to raw input, it's let's have a sentence which says I do not like chocolates, and you want your computer to basically understand I like chocolates part of it. So I do not, that do not part, we do not want it. Are you getting it? So your input is I do not like chocolates. You want your machine to pick up I like chocolates, and this is how it does. So I is required, so it becomes 1. Do not is not required, so do becomes 0, not becomes 0, like is required, like is 1, chocolates is 1. So whatever words you want to be picked, those words are 1, and whatever words you do not want it to be picked, those become zeros, right? So this is how, in a very, very simple way, it's called as vectorization, and of course each of these entities will be separated by a comma, but then just to keep it more readable for you guys, I'm just showing you a general way on how an input can be vectorized and what is the result that we can obtain by converting this grammatically correct or incorrect sentence, for that matter as well, into a mathematical vector. Alright, so I hope this is clear, and with that we need to check out something called as the TF-IDF formula. So guys, again, if you know what TF-IDF is, head to the comment section and let us know. So what is TF-IDF? Well, it's actually an acronym for term frequency and inverse document frequency. Well, fret not if you don't know what this means, as I'll be explaining all of this. So with respect to bag of words that we just discussed, right? So when you have an input which is a bag of words, it'll have a lot of words. So basically I told you we are ditching the order and we're just considering a lot of words, right? So that is the advantage and the disadvantage. The advantage is that there is a lot of words. The disadvantage is that your bot will not have a lot of information there. So there is a difference between having a lot of words and helping your bot understand all of these words, right? So this is where bag of words has a little bit of a downside which can be fixed, and it's fixed by giving it context and making it understand about these words. And to do that, we have something called as term frequency and inverse document frequency. So let's talk about term frequency before. First, basically, term frequency, when we're working about it, you need to understand that we need to find out how many times the term is occurring. So this might be because of classification. We need to understand stop words. We need to find out how many times one word is occurring. So if you have a sentence which has the word apple like 100 times, let's say it's a 10,000 word essay and you've used the word apple 100 times, you know it because probably you have used it. Now to make your computer understand that there is apple there 100 times, we need to find out how many times it has occurred divided by how many total terms there are in the document, right? So this will give you a term frequency saying, for example, if we do 100 by 1000, so there is a chance that 0.1% of every single time your word apple is occurring. So if you have like 1,000 words which says apple 1,000 times, and then if you want to search the term frequency of apple, what do you think it is? So it's going to be 1,000 itself, right? Because there is nothing else in that. So I'll give you an example again in the next slide. You will get a lot of clarity on this as well. For now, you need to just know that the formula of term frequency, where we are trying to find out how many times a term occurs, is basically the number of times it appears in a document divided by the total terms in that document as well. Now if we talk about IDF is basically inverse document frequency. So inverse document frequency is the number of times that your word has not occurred. What is the rarity of words that has basically occurred in your document as well? So for that, we'll be using a logarithmic formula. It's basically 1 plus log of x by y, where x is the number of documents that you have where you're checking this, and y is the number of documents where this term occurs. So when you do a logarithmic inversion of this number of documents by the number of occurrence of the term, you will get the rarity of how many times the term has not occurred there. So let's walk through this with an example. On the left, I've kept the formula so that you can refer to it while we calculate on the right. So let's say right now we have an essay or we have a document which we also call as a corpus. So corpus is basically the input document. So let's say we have a document which is 500 words, and in this 500 words the word call appears 10 times. All right, so this is a generic document, there is 500 words and the word call appears 10 times here. So what does the term frequency of this mean? So term frequency again is the number of times a term appears, which is 10, divided by the total words, which is 500. So 10 by 500 will give a term frequency of 0.02. So for every word that you have written in this document, there is a 0.02 times chance that you've used the word call. This is term frequency visualized. And then if you have to talk about IDF, consider this. Let's say there are 10 lakh documents out there and the word call now appears in just 60,000 of these 10 lakh documents, right? So 10 lakh documents, the word call appears in only 60,000 documents of these 10 lakh documents. Now to find out the inverse document frequency, basically as I just mentioned, we're going to take the 10 lakh, which is the number of documents, total documents, and divide it with the documents where we have the term which we require. So IDF in this case becomes 10 lakh divided by 60,000, which gives us a value of 1.22. And now if you have to give context to your machine, if you have to tell your machine, hey, this is the word, this is the context, this is how many times it occurs, there's something called as TF-IDF weight, and this weight is basically the product of term frequency and inverse document frequency here. So as soon as we multiply all of that, we'll get a number which is 0.0244, and this number will basically give context to your machine, saying this is the weight of this particular term in these documents and in each of these particular documents as well. So your word in every document, in total number of documents added together, clubbed, and after you find the term frequency and the inverse document frequency, you will arrive at the weight of it. So on that note, we've seen all of these theoretically and we need to now check it practically. So let me quickly jump to the practical aspect of how we can go on to check it. So here I am making use of Google Colab. Google Colab is basically a Python Jupyter notebook which is hosted on their Google Cloud platform. So this is where we will check out a very simple demo use case of how we'll go on to work with chatbots by using Python. Here again, as we have walked through in the theory, we'll be making use of NLTK. NLTK is the Natural Language Toolkit, which is a beautiful library to work with when you're thinking about Python. And of course, as always, whenever you're working with Python, it is a common practice that you import all the libraries that you require at the start of it. So in this particular case, we are importing NLTK and NumPy because you have to work with numerical computations. We're importing random because we'll be randomizing a couple of aspects here, and we're importing string. So string is basically a library which will help with string processing techniques in Python as well. So if you are on a native Python environment which is different from Google Colab, you might have to install all of these before using it. To do it, instead of import, just type pip install, pip space install space NLTK, pip space install space NumPy as well. So with Google Colab, all of this comes pre-installed, and that's the reason all we have to do is we have to just import them and it starts working. So after importing all of the libraries, the first step is to make sure that there is some data through which we can teach the chatbot, right? So this is where we'll have a file. This file or this document is called as a corpus, and with this document, this is where all the data resides in which your chatbot can understand. All right, so to do that, first we'll be using the file function. We'll be using an open function where the file we have, we'll call it as chatbot.txt. Of course, you can call this anything else you want. You'll be opening it in the read mode because you're reading it, and if there are any errors, we're going to ignore those errors for now. So after reading these document, we'll be converting it to lowercase because, as I told you, case conversion is very vital for data pre-processing, and we will download the punched part of the tool case because we're working with English language and this is already a pre-trained library that is present, right? So this is a one-time download that you'll have to do. And of course, we have something called as WordNet. So WordNet is basically a database which consists of relationships in between each of these words, all right. So with WordNet you will have an access to like 200 languages. With respect to Punkt, it will give you the pre-trained library for English as well. And in fact, the WordNet is it's a pretty old library of data. It is present with us from the 1980s as well. So that's a fun fact for you guys. And now we spoke about tokenization as well, right? So we need to tokenize this to be each inputs of words and be inputs of sentences. So basically we are using nltk.sent_token to basically convert the sentences from the raw data, and word_tokenize to basically convert words. So here sent_tokenize is the sentence tokenizer, word_tokenize is basically the word tokenizer. All right. So again, as you can see, if you just put your mouse on that, you will basically find out what it is. So you can actually go on to the definition of it and find out about it a little bit as well. So now to do this, we need an input. So we haven't yet talked about what input we are doing, right? So in fact, let's go to a Wikipedia page and give Chatbot. So there is a Wikipedia page called Chatbot, and this is like a basic input to our model to train. So what we'll actually do is we'll take everything here, just hit Control A, in fact copy all of this and basically put it to a file, create a file called as chatbot.txt and just put all of this there. So you will have something like this, and this is like a text file through which your chatbot can learn something. All right, it's simple as this. After that, save it, call it whatever you want, but then you have to remember the name because you have to input this, right? So now coming back to the input, as soon as I hit play, now it's going to say an error because it does not know where my chatbot.txt is. It's on my desktop and we're running it on the Google Cloud. So let me quickly upload the file here, chatbot.txt, and as soon as this is uploaded, I can run it again, and now it sees my chatbot.txt file. It will convert everything to lowercase, it will download everything that's required, it will convert it into sentence tokens, it will convert everything into word tokens. So we did all of this by making use of 5-6 lines of code, and it's this simple, guys. And now coming to the next aspect of the same step 2, basically here is where we'll be printing an example to see our sentence token and word tokens to see if it has worked, right? So now as you can see, I just hit print and we're trying to just print a sentence token here, and we're trying to print a word token here as well. So whatever sentence here, you can give any sentence for checking here, and then you can just paste to see if this this sentence, which is the raw input, if it is converted into a token or not. So as soon as I hit play here again, it is obviously converted into sentence tokens and word tokens as well. So coming to the next step is basically pre-processing and handling your data. So as I said, WordNet is basically like a dictionary out there with more than 200 languages, and where it understands your words. Now we discussed about lematizer. With respect to lematizer, we give this word certain context, right? So that's basically what we're doing out here. With lemmatization, we are giving it context. You can think of the example which I just mentioned, good, better, and best there as well, right? So basically step 2 is all about that. And then coming to step number 3 is basically where you will be programming a greet response. See, for example, with any chatbot, right, be it Alexa, be it Siri, be it Google Assistant, whatever it is, as soon as you say hi or hey, it will not tell you something which is very vague. It'll greet you back. It'll be very nice to you, and it'll say, hey there, what's up, or how's it going, whatever it is. It's like a human conversation. So when you say hi to someone, they'll not just nod their head. 90% of the time they'll say hi back to you, right? So to give it that human touch, step 3 is all about giving greeting inputs and responses. So if you give it a response saying hello, hi, greetings, sup, what's up, hey, or whatever it is, it will give you a response back with hi, hey. It'll nod its head, it'll give you hi there, hello, it'll say I am glad you're talking to me, and all of that. So you can change these inputs and these responses to whatever you want. So basically this is not very complex. If if it sees any of these, it'll give you a random input of this. This is where we require the random function that we inputted, right? So you might be wondering where it's not like you give hello and it tells you hi every single time. You can say hello 10 times and it'll give you 10 different outputs from this response here. So as soon as we run this, we are taking the inputs and we're generating random greeting responses and printing to the screen. Now coming to step number 4. Step number 4 is where we start giving out responses. So to give out certain responses, so you need to understand that we'll be using the TF-IDF concepts. So I hope you guys remember the term frequency concept, the inverse document frequency there. Now we have to import all of these, right? So basically these are all part of scikit-learn. It's part of the concept called as the feature extraction, which is based on textual inputs. So we're going to import that, and you might be seeing the second thing which is being imported here as well. So the second thing which is imported is something called as cosine similarity. So cosine similarity is a part where you'll be checking out and teaching your chatbot about how to find certain behavior inputs and how to find and understand what your difference is and the similarity is in between what the user types and in between what document is present. Do you understand that? So in our case, the document is the Wikipedia article that we took up, and the user input might be something where, you know, it has to learn and map this user input to the document. So that is where cosine similarity is used as well. Of course, you know, we can discuss the TF-IDF concept or cosine similarity in a lot of depth, but then I do not want to overwhelm you guys with loads of information here. All right, so we're trying to keep it simple, and as you can see, it's just a couple of lines, and you know, we have almost built our chatbot. So after generating these responses, we need to write a function for concepts such as where, you know, we are thinking of stop words, we are pretty much, you know, removing all these stop words, understanding it, and we haven't talked about what happens if your chatbot doesn't understand you, right? So if it sees stop words, it knows what to do. If it sees a greeting message, it knows it has to greet you back. But then if you type random stuff there, it has to give you a response, right? So it cannot stay idle. So basically we are trying to print a message here saying, hey, I'm sorry, I do not understand whatever you have typed. So with respect to this function, it's pretty straightforward, it's pretty easy. If it doesn't understand something, it'll tell you it doesn't understand you. And step 5, yes, step 5, or probably we can call this step 6 as well.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So this is the last step where you will be programming the start point and the end point. So starting when you run the chatbot, instead of greeting it, it will probably say, hey, my name is this, I can help you with this, and you know, I want to quit. And if you want to quit, you know, just type something, you know, type bye-bye or whatever. So in fact, there's actually a tiny mistake here which I will clear, which is a spelling mistake which is can. I mean, come on, everyone does spelling mistakes. All right. Now, so basically what I'm trying to tell you guys here is that as soon as your chatbot starts working, it'll print out this message. It'll say, chatbot, hi, my name is SampleBot. I can help you with chatbots if you need. This will be anything else, because, you know, we randomly picked a Wikipedia article for chatbot. You can pick up anything. It doesn't have to be a Wikipedia page. You can make it learn on a blog of your choice and then give you responses to the questions you ask. And then if you want to come out of the loop, this is basically working on a while loop where it's constantly waiting for your input. If you want to quit, you can just type bye, and if it sees a bye in the input section, it'll say thank you or thanks, and it'll basically quit. So as soon as we go ahead and run this, you know, it says chatbot, my name is SampleBot, how can I help you? You know, if you want to quit, type bye anytime. So let's say hi to our chatbot. It'll say hey. Again, as I mentioned, it is a random response that it is giving to us based on the greeting pool, right? So I can say hi again, and it will say something else apart from hey. So it says hi there. Another time, let me say like hey or something. it'll say something else. So as you can see, it's not giving you the sample a response that it is supposed to give. So it is generating random responses and it's giving it to you out there. Now let's just say we want to quit. All you have to type is bye, and as soon as it says bye, it's like, okay, thank you for talking, bye bye. And it's pretty simple like this, right? So even this we achieved with like 5 or 6 simple steps in Python, which is really amazing. And in fact, let's run again. So in the chatbot article, there's this person called as Alan Turing, who is considered to be the father of intelligent machines. So let's ask the chatbot, who is Alan Turing? Let's see if it can find that out. Of course, the responses will be pretty vague. It will not be very accurate. It says there is a stop word which came here as well. Of course, apart from that, it gave you the answer. It says Alan Turing was a British scientist and he was a pioneer in computer science. See, I asked it a question saying, who is Alan Turing? It figured out that I'm asking a who question. It found out everything about Alan Turing and it gave me a sentence output there saying Alan Turing was a British scientist and a pioneer in computer science as well. So basically, this you might be expecting like a 2-liner, 3-liner output, but our chatbot, this simple chatbot, is intelligent enough to find this for you, and it's amazing. So basically, we didn't write hundreds of lines of code here. We probably wrote like 100 lines in total, or less than that, in fact, to build our own chatbot to do this, right? So it's as important as this, and it's as fun as this. So we can check out a case where it doesn't understand. So if I go on to type some random stuff, it'll say, so, see, I'm sorry, I did not understand you. So this pretty much covers all of the cases. We checked out greeting, we've generated response where it does not understand you, and it pretty much analyzes your document and gives you a valid response of whatever is in the document as well. So you can type something else as well which is not in the document and it will say I do not know, because it has not gone through these words in the document there as well, right? So again, pretty simple, and I hope this demo was pretty much understandable to all of you guys. So there are many other complex demos which I can use and show with respect to NLP, probably by making use of very, very complex data, and by creating like a very nice use case, by making use of a very nice user interface, by using TK Inter and whatnot. But then again, to keep it simple, so this was what I had in mind. Consider this graph on your screen right now. So you'll see a couple of statistics here, basically telling you the number of dogs, cats, birds, or horses, or any pets in general that a household might own. Well, how was this statistic derived? You cannot go on to probably survey every single household on the face of planet Earth to probably get this information, right? So this information will be extracted from a place, from multiple places, in fact, where there is some detail given about if people are owning dogs, cats, birds, or horses, for example. So this, what you see on your screen, the very good looking animation, of course, but more importantly, the detail that you see in the screen with respect to the numbers is the exact result one can obtain of data extraction. Of course, there are millions of other results and other staggering numbers or achievements that you can go on to have when you're making use of data extraction, but I thought this was one very nice case of what happens and what you can actually obtain by making use of data extraction. All right, this brings us to a quick introduction to data extraction. So when we talk about data extraction, what is it exactly that we're going to discuss? The first thing you need to understand about data extraction, as the name suggests, is basically that it is a technique which will go on to pull data from places such as websites, social media sites, or whatever it is in general, and this information can be used by you and can be leveraged in such a way that you can go on to probably use this information effectively. See, for example, there are multiple things when you can consider some simple entity such as a tweet on Twitter. So people go on to post things of whatever comes to their mind on Twitter, right? So there's something called a sentiment analysis which has been coping up and which has been upcoming for the last couple of years basically. So when you think about Twitter sentiment analysis, you can understand if people are happy about something, if they're sad about something, or if their viewpoint is even neutral. So who knew a couple of years ago that your post on Twitter will actually help people analyze something? So why would somebody even want to analyze something on Twitter, you might be asking? Well, basically at the end of the day, you're converting this raw data, which basically is the Twitter responses in our case, into information. So you might be wondering if your brand is performing very well, if your product is selling well, and how happy are people when they're dealing with your businesses, and much more. So I just gave you an example which came on the top of my head right now, but again, I can give you a million examples of how and where data extraction is being used very effectively. And in fact, make sure you stick till the end, because in our demo we're going to be considering something from the present situation right now, and it's going to be really nice to understand the real-time use and help of data extraction techniques as well. So again, coming back to the definition, basically what we're talking about is a technique, is a methodology which will help us gather the data, and it does it in an automatic way so that we don't have to manually gather the data. So this part where it's automated is all about what we're going to discuss, because at the end of the day, if it's going to be a manual task, you wouldn't need a procedure to do that. You wouldn't need a technique to do that, right? So all you have to do is see something from a website and start typing it out probably. So this automation part plays a huge role. So when we're talking about extracting data from websites, when we're talking about extracting data from anywhere, you need to understand that there's two types of data present in today's world. One is structured data and the second one is unstructured data. If we're talking about structured data, structured data will have something to adhere to. It'll have some rule, it'll have some policies, or it'll have basically a guiding principle behind it. For example, when you look at the data present in databases, it'll either be of the same type, or it will adhere to all the rules of the data that is present in the database probably. Or when you're thinking even of structured data in general, it can be just a very good, very well organized calendar or a timetable basically in your calendars. So, something from that simple entity to all the way till, for example, images, it can be audio, it can be video data, and it can be anything text as well. So when you're mixing up all of these concepts, your data becomes unstructured. There is no one set governing policy over the data which says, yes, I can use this one rule to basically assess and control all the data. So this is a very important difference that one must understand when you're working with structured data and when you're analyzing unstructured data as well. So I hope I was clear in helping you understand structured and unstructured data. Anyway, on that note, guys, let's keep the session very interactive. Make sure you head to the comment section and leave us all your comments. So we have our team members waiting for you guys to hit the comment section, and they'll help you out as soon as they can. So make sure you hit that comment section and leave us with any questions you have, suggestions, or anything you'd want from this session as well. So let's keep it interactive. Head to the comment section. Alright guys, so on that note, we need to check one more important thing, is how one can go on to do this. There is one term when it comes to data extraction, especially from websites. The term is scraping. See, so when you go on to check any website for that matter, right? So all these websites, they contain images, they contain text of some sort, or they might contain, if it's a website such as Amazon, for example, or any e-commerce site, you'll have products, you'll have pricing, you'll have situations where the product is deliverable to one place and not the other, for example, as well. So when you're working with all of these concepts, there are a million ways and there are a ton of data that you can actually gather from these websites. So basically what one can do is, if you guys are into sports, you will know that the players for the teams are usually auctioned off when you're working with Premier Leagues. So when you're talking about all these Premier Leagues, what usually happens is each player has a value and they're bid on and they're won. So you can actually go on to websites to find what the price of the player was when they were bought into the league, and you can create a very nice looking Excel sheet, and you can organize to see what player was worth what, and eventually at the end of the Premier League they usually put out tables and charts with the number of goals. So you can create this very fun project where you're trying to find out the return on investment as well. So again, just another example here. But then if to give you another example, you can go on to e-commerce sites like Amazon, again Flipkart. There are many other places there. You can find out all the prices that each of these guys are offering for the same product, and you can find out who is providing it for cheaper. Is it Amazon, is it Flipkart, or any other case for that example as well. So all this information is gathered in the websites, and we use a term called as scraping to basically pull all of these information out. Scraping literally means hunting for the information that you need, filtering for the information you need and basically bringing it on to your machine, or basically to bringing it on to your native base, where you'll be converting it into files that you can use. So CSV is a very structured form of storing the data. For example, let's go back to the e-commerce example we went. So you can have name of the product, the vendor 1 and vendor 2, for example Flipkart or Amazon, and you can get the price of both of them, and you can compare and check who's giving it for a better price and whatnot. So this forms the basic outlay of how one can go on to perform data extraction. Data is present in the websites, we'll be cleaning the data and pulling whatever data we require, and after that we'll see if there is any processing to be needed, and if processing is needed, it is done, and at the end of it we will save all of these files in a format which is basically structured and which we can use further down the line. All right, so on that note, you need to understand why we need to perform data extraction. Guys, again, if you know why data extraction is important in today's world, head to the comments and let me know. So coming to the answer to why one should scrape data, here is a very good first example for you. When you go on to the top job hunting sites, be it Naukri.com, be it Indeed, or be it LinkedIn Jobs or whatever, so in this situation, when you have to find out about all of the top jobs that are present around the world, well, it would be really nice to have all these jobs that you're looking for at one particular website, right? So consider the situation where, let's say, you want to become an artificial intelligence developer. Artificial intelligence is on the rise in today's world, as you might know it, and you're looking for a job. So in this situation, you would want to check out all the jobs that are available in your vicinity, in your area, or in your area of interest as well, right? So if all of these job listings were probably put in a very structured Excel sheet, or if these were put in a very nice place all in one. So if all of these were put in a very nice single place where you can look at, analyze, assess, and basically apply, that would be really nice as well, right? So basically, to perform this, you will require data scraping, and this is actually a very good example of projects in case you guys want to consider doing your own projects with respect to job listings as well. Find a keyword, find a career, and basically scrape data of various websites where you can create your own list of these jobs available as well. Anyway, coming to the second reason of why one must scrape data, think about social media analysis. See, all of us pretty much use a minimum of, well, let's say 4 out of 6 social media that you see on your screen, right? Everything from Facebook, Instagram, Snapchat, Twitter, WhatsApp, LinkedIn, and more. If you are a business person, or if you are a marketing enthusiast, programmer, or whatever it is, if you're looking to scale your brand, if you're looking to sell your products more and ensure how your outreach is, as we discussed previously, you will need social media. At the end of the day, social media is something we all go back to on our couch at the end of the day to scroll through to see what's happening in our friend's life. Well, let me tell you, it is way more than that, because with the help of social media, brands are being established, they are taking off. So in this competitive world, it is enough that people have to start using these tools to help market their brand, to make sure that more customers are coming in and whatnot. This is one aspect of it. The second aspect of it is that you need to understand what your customers feel about your product. You need to understand what your customers have the opinion about your product, because 3 people might be really happy about your product while 10 people might be showing disinterest or saying that your product might be bad. Knowing this can help you with your brand and much more, right? So scraping data with respect to social media is very important, not only in terms of businesses but in general as well. Now, coming to the third reason of why one must perform data scraping is understanding market value comparison. So this is exactly what I was talking about when I gave you the Amazon Flipkart example. So it's not just e-commerce websites, it can be the comparison between any 2 products. If you're looking for a product, you can bet on it that there are multiple vendors for the same product. So, it is very, very rare cases, it is 0.001% of cases where there is only one vendor for your product across the entire world. Well, let's talk about the other 99.99 cases, right? So there, you have more than one provider who's giving you the product that you're looking for. So in that case, you need to understand, you need to perform analysis to see who's giving it for a lower price, because if it works out for you at a lower price, you're at an advantage, right? So probably this wouldn't matter if you have a low investment of say $1, $10, or maybe $100, depending on how much you can digest. But then if you're looking to purchase something in the thousands of dollars range, probably in the millions of dollars range, then of course this is going to add a lot of value, because again your savings are in the thousands as well, right? So scraping data for market value comparison is very important. And of course research and development. When you're understanding that, let's say you can provide scientists or physiologists and everyone in the field of science more data where that can be helped for them to perform analysis and give them a look at the data that pretty much that they've never taken a look at from the angle that you can provide with the use of web scraping, is something which is very vital as well. Because they can be working with a lot of data, but then once you step in with web scraping, once you give them data, it might provide them the angle, it might provide them some clarity, it might provide them basically what I'm trying to tell you is that it will provide them with a view that they have not thought of looking at as well. And of course all of these data can be further put into use by making use of artificial intelligence, machine learning, or whatever it is. But then to get to that, you need to give them the data, right? And this is exactly what and why it's important to scrape data for the world of research and development as well. So on that note, you might have a question saying, is it legal to start pulling data from everywhere around the world? Well, to answer this is a bit tricky. I'll tell you why. The answer is yes and no. So you can legally extract some information from websites, and you can of course illegally do it as well. So to understand how you can abide by the laws to make sure what's legal to be pulled, what's not legal to be used, the websites will actually tell the users about it. So the websites will tell the users saying, hey, this is legal to do, this is not legal to do. So how, you might be asking, how are the websites telling the users? Because you don't see it anywhere on the websites, right? So every website has a file called as robots.txt, and this robots.txt will basically tell all these crawler robots, all these spider robots, which basically go on to pick the actual data from the websites, saying, hey, you are allowed to do this, you are not allowed for this particular information. So when these websites say, and these robots basically, when they can have all the access they want to everything that they're allowed to. And once if someone with a very bad intent tries to pick up information from a website which is not allowed to access, then their intentions are not good, and they might be doing something with your data which they're not supposed to. So let you access is basically amazon.com/robots.txt. And as soon as you hit enter, it will take you to their file, where they will tell you what you can allow and what you cannot allow. So you can see disallow/wish list. So all of these pages which start with disallow means that you cannot legally access all of these as well. You can see allow as well. So basically allow will tell you, hey, you know what, you can have legal access to all of these as well. So this is exactly what I was talking about. But then to give you more clarity on what this means, it's not just Amazon. You can visit any of the websites and just type in /robots.txt, and this will give you an understanding to see if you can actually scrape their data or not legally. So in fact, to add value to my point, here is what it would look like. So basically, as I mentioned, any website will have this file, and this is what it basically means. As soon as we saw user agent start disallow, if disallow is not followed by anything, it basically means that the user or the crawler robot or the spider robot basically, which is going to pick the information for us, it has full access to their website. And if we have a disallow and if we put in a slash there, it means that it will block all access, and no data can be scraped from there. But then you can actually prevent access to particular folders, you can prevent access to particular files, and much more. So you can see disallow /folder/. This means that this one particular folder has blocked access, and you cannot access this when you're pretty much trying to scrape the data. And then there is disallow /file.html, and this ensures that there is one particular file which is basically blocked for access by all of these crawler robots as well. So this is very important for you to understand even before you begin scraping data off the internet. And now the question comes, Python for data extraction. What makes Python the tool that one must go on to use? The first thing when we talk about Python is ease of use. So Python has been this amazing language, and personally, been a fan of it, been using it for multiple years now, seeing it take over the top position when you're comparing it with Java or whatever it is. Python is amazingly easy to work with. So there are multiple reasons. One, it's very readable for people who have never used Python before. Two, the syntax is again very easily understandable, and you do not need a lot of training when you're working with Python. Of course, structured training is very important to understand the core values of Python and how you can go on to use it effectively as well. But the point here is that there is no semicolons, there is no complex syntax, and everything at the end of the day is a breeze when you're working with Python. So of course, I think many people in the comment section can agree to this point on how easy Python is to use when you compare it with all the other programming languages out there. So point number 2 is something very important. Point number 2 is what makes Python what it is. It is the number of libraries that Python supports. See, for example, in the world of data extraction, we will perform computations, we will perform data storage methodologies, and we will go on to visualize this data at the end as well. So for numerical computations, you have libraries such as Panda and NumPy, which will perform any computation on the data that you have extracted. And for data visualization, we have tools such as Seaborn, Matplotlib, and much more, which will basically help you even after you have achieved the results of data extraction as well. And these are just 4 libraries among hundreds and hundreds of libraries that are present, which are being used around the world as we speak. Basically, which makes what Python what it is, because at the end of the day, with getting access to so many open source libraries, you're part of a huge community, and you're using tools which will make your job a lot easier, be it data extraction, be it machine learning, be it neural networks, whatever it is. With respect to Python, it just makes it easier, and this adds value to my last point as well. So coming to the next point, it's small code. You might be wondering what I say by small code. With respect to Python, as I mentioned, the syntax is not complex. One more thing is that the syntax is not long. For small amounts of code, you can basically get big results. In Java, if you have to compare to, pretty much go on to print hello world, you have to write 4 or 5 lines of code. Those are complex syntaxes as well. So for a beginner who has never seen programming before, that will be overwhelming. With Python, it is pretty simple. It says print, open your braces, put your message inside, and hit enter, and your results are printed. So I just gave you a simple example again. Even with respect to data extraction, you need to understand that there is a small amount of code, but at the end of the day, the results that you get for typing the small amount of code is huge. And this, in my opinion, is one of the most important aspect of using Python for data extraction as well. So coming to the next point, it's again a very nice point here, is that it's the community. When you're working with data extraction or any other concepts with respect to Python, we have an amazing open source community where everyone is friendly, everyone wants to help each other out and pretty much develop products, establish brands, whatever it is. Everyone is very friendly, and this entire community is filled with people who are enthusiasts, who are willing to help each other out, and who are basically willing to see that all of them grow together in the world of programming as well. So this is why personally I love Python too. And again, I am sure our viewers can agree to this point as well. So you might be wondering, what are the Python libraries available for data extraction? Well, there are many libraries, but then here are the top 3 most used libraries. The first thing is Beautiful Soup. So Beautiful Soup is again another open source library which basically parses your HTML and XML documents and makes sure that you can extract all of these information very easily. So you might be wondering what parse basically means. So parsing is an operation of performing syntactical analysis where you're trying to make sense of symbols, where you're trying to make sense of the text which is given, the strings or whatever it is, and then bringing you that information. So Beautiful Soup again is a very widely used Python library for data extraction alongside a Selenium. So Selenium is basically used for automating your browser activities as well. So when you perform web testing, when you perform activities where you're pulling the data continuously, you have to go on to test to see if your data is being pulled right, to analyze your data, to automate this process of verification and validation. So Selenium is used right after Beautiful Soup for that. And then there's AnyTree. AnyTree is basically, helping you create a tree data structure which is used for data extraction. So a tree data structure at the end of the day will basically make sure that your data is organized and it can be pulled in a structured way, and this will help in further analysis, in further storage, and much more. See, there are many other tools you can use as well. There is requests which you can use, there is LXML, and there is many other tools as well. But these three are mostly the top use tree, because one, we are talking about converting your data into something useful. The second one, we are basically pulling the data for any tree to use, and after that we'll be using Selenium to basically test and automate the process as well. So as I just mentioned, there are multiple libraries which one can go on to use for data extraction. And this quickly brings us to the demo where we'll actually get to see this hands-on. And just before we jump to the demo, we need to understand the problem statement at hand. So what is the problem that we are facing in today's world with respect to data? In my opinion, it is data requirement, because see, when you're basically trying to solve a problem which needs a lot of data, first thing, you need all these data to work with, right? So here is where data extraction is a king. When you're working with data extraction, you can have the ability to basically provide all the data that's required, for example, for the creation of data sets. And these created data sets will help solve the world's problems, right? So let me give you an example. When you're working with artificial intelligence, machine learning, neural networks, or whatever it is, more the data you provide, there is a good chance that your machines and your neural nets or whatever it is, it will learn better and understand quicker. So it's not only about artificial intelligence that, more the data, better the learning. But when you talk about any other situation as well, if you were given price comparison of products from just two places, would it make more sense? Or if I could give you a price comparison of 10 places, the 10 places would basically be a better, point of reference for a business decision, right? Exactly my point here. So more the data, better the learning, better business decisions, better key performance indications, and much more. So let's consider one of the things that's happening right now. So for example, we have the COVID-19 outbreak across the world right now, and it is something very grievous as well. When you look at the numbers on your screen, basically we had total infections of 2.4 million and 170,000 deaths at the time of the creation of this video as well. And pretty much this number is going on and on every single second, and it's very scary to see. And at this point of time, again, I would like to enforce everyone to take all the precautions, that is, stay safe, stay in quarantine, and we can fight COVID-19. So basically, humanity has fought multiple viruses across the history of the last 100 years and more. So pretty much, this is an easy task at hand if everyone does their job, and let the doctors work their thing. And let's see, as IT people, let's see, as the people who are computer science enthusiasts, IT field enthusiasts, let's see how we can help them out better to achieve this, right? And that's exactly my point here as well. So again, when we're talking about how important is a data set to solve a problem, let's see if we can bring machine learning together and medicine together. So we have a comprehensive video on the channel which will guide you on how machine learning is basically used to fight against COVID-19 as well. So make sure you check that out after this video. So coming back to how important the data set is, the first thing your data set can help in this particular case is it'll tell you where you can trace the outbreak from, where it originated, how it started out, where is it spreading, how quick it's spreading, and much more. Diagnosing patients is something very important. Again, it will help you tell what patients have been diagnosed at what time for what particular disease or whatever conditions they have as well. Disinfecting areas, you can find out by making use of machine learning models saying where the contamination is highest and help disinfect those areas as well. And then when you're looking at finding a cure, probably this is the most important thing. This is the most widely asked thing right now, to see if computers can help fight against a virus. And of course, computers are doing everything they can. There are experts out there who are bringing together the world of IT and medicine just for this cause. So if computers can help scientists find a cure for this particular disease, it would help. And again, if we take a quick backtrack, of course, medicine in all of its glory will be the one finding the cure. But then the field of computer science, if it can speed up something in the field of medicine, that is what we're basically achieving. To speed up something, we need more data again, and more data is obtained by making use of data extraction, right? So you see where we're going here. So just before we dive into the world of showing you how data extraction works with respect to the demo, here is a sample fact about how machine learning came into picture. So basically, Blue Dot is an artificial intelligence platform which basically tracks all the infectious diseases that happen, right? So this actually found out that there was a lot of pneumonia cases happening around one particular market in Wuhan, China. And just 9 days later, after the Blue Dot platform found out this unusual rise in cases, World Health Organization stated that they have found a new virus out there, and there are a lot of people hospitalized with respect to pneumonia as well. And this was at the end of 2019, and now we know that in the April of 2020, we know where we are. We know the 100,000 deaths which has happened, 2.4 million cases and whatnot, right? So this again was one of the places where IT helped, and it could only do this where if it had all the data from around this market in Wuhan or whatever it is, right? So again, they and the people at Blue Dot basically again made use of data extraction to get all of these data and create artificial intelligence models around it, and then put out a conclusion saying there are a lot of pneumonia cases here as well. So this is exactly one case. So I picked up a medical case study to show you guys, because again, I believe that artificial intelligence, I believe that you can make use of machines with medicine together to help speed up today's world of medical research and whatever it is in general as well. So I'm a huge fan of that, and I hope you guys could see the connection as well. So coming to where you can pick up the data, in our case, let's say COVID-19 dataset creation, you can have data picked up from the satellites, you can have data picked up from the news, you can see who all flew around the world at what time to trace and understand where there could be an outbreak by taking all the data from the flights across the world, and of course all the health organizations, hospitals, your local governing bodies which is taking care of the local areas as well. So there are multiple places where you can find a lot of data. For example, every day you can check out, there are news about where hotspots are, where there is a lockdown, where there is a complete shutdown, where people cannot step out of the houses as well. So when you look at the data, there is plethora of data, there is a lot of data. To go on to use this effectively, you need to create that structured aspect that I spoke about in the starting of the session, right? So just on to that, here is what the solution would look like to perform data extraction on a data set such as the COVID-19 data set by making use of web scraping, by making use of data extraction. So as mentioned, we'll be making use of Python in this particular cases, and we'll create a data set for various reasons, and all the various reasons we just discussed in the problem statement, right? So quickly coming on to how it works, it is pretty simple. It's about 10 or 11 steps, and it's really simple to follow as well. So follow along with me. The first step to perform data extraction is to make sure you set up everything you require in your Python runtime environment. For example, here we're making use of Google Colab. Basically, it's a free Jupyter notebook where you can run Python commands online, and everything is stored on the Google's ecosystem, and they provide you storage and computation power as well. But then I'm aware that most of you might not be using Google Colab. So if you're using your local machine, if you're using any other environment to run your Python code, just make sure you install a couple of libraries before we begin with. As discussed, Beautiful Soup 4 again is a very important library for web scraping. We have requests as well. So requests will basically help you pull and parse data from the HTML sources we'll be looking at as well. So in this case, we'll be pulling data from a very famous website called as worldometers.info. So these guys have been putting out very structured information when it comes to how the outbreak is being handled and all. So to do that, to pull the data, to pull all the HTML data and to analyze and understand it, we require requests. And we have a library called as LXML as well. So LXML again will help you parse your XML data and pretty much make it understandable and make it usable for further down the line. So you can execute these code statements that are in the comments in case if you're using any other environment as well. So coming to Google Colab, basically Google Colab has all of it covered for us. So all I need to do is run it, and basically it is imported because it's already installed in the backend. Step 1 is very simple. Step 1 is to get your runtime set up. Now step 2. So what we're trying to do in step number 2 is we're creating a beautiful soup object. All you're trying to do is making use of the website's HTML, and here is where the LXML parser will come into the picture, and we're trying to create this object where we're getting all of the source from the website URL as well. So you can see the URL is given on your screen. It's worldometers.info/coronavirus. So this is where all our data is, and all we're trying to use is make use of the get operation in HTML request to basically pull all of this data. So by running step 2, you would have created an object. Step number 3 is something simple as well. So what we're trying to do here is we're trying to create tables with all of the data surrounding COVID-19, right? So when we're trying to do this, you need to understand that there are multiple tables which will be available in that Worldometers website. So we need to perform some analysis in the backend to find out what table ID is given. So we can pull all these data from that particular table as well. So here the ID attribute which I found out to be the table there was given as main table countries today, and running this will basically create a table. It will find us the ID attribute, and at the end of the day, so our beautiful soup basically understands that this is the table, this is the ID where I can pull all the data from. So step number 4 is basically where we go on to extract the headings that we require for the data chart that we're going to use. So to do all of this, you might be wondering, is the data already clean where we can directly grab the data and start using it? Well, the answer is no, because with respect to most of the cases, the data that we see and use will basically be some sort of it'll have some sort of an anomaly, or it'll have some sort of characters that we would not want to use, or let's say it's of no use to us. In that case, what we basically do is we replace all of these unwanted characters with something else, and we make sure that we actually go on to keep the data as clean as possible for further use as well. So you can, for example, see every new line character here is basically replaced by a blank space when you're working with heading, and you're working with a non-breaking space as well. So /xa0 deals with non-breaking spaces, and again we are replacing those non-breaking spaces with an empty string as well. So all we're trying to do in step number 4 is clean the data and get all of the headings so that we can have headings for our columns and use it further as well. And after step number 4, step number 5 is to find the data for all the continents across the globe. So for example, in the data that we have analyzed, there is the data continent aspect where data can be pulled for each continent. So in our case, we want the data across the world, right? So we're not looking for data only from say Africa, Australia, only from Asia or whatever it is. We want the details from across the world. So all we're trying to do is to ensure that we find the table where all of the rows which do not have a data continent attribute. So if it does not have a data continent attribute, it means that we're trying to pick up the data from all the countries and not just any one continent, right? So we want the data from around the world. To do that, we need to recursively go on to check if these particular aspects have the country's attribute, and to find out if these attributes are present or not. If they're not performed, then we're going to pick that, because that indicates we're looking at all the countries and not just one single continent as well. So basically, after performing analysis and after setting our scope to the data across the world and not just one particular country, we need to remove the first row. So basically, all we're trying to do is we're removing the first row in the heading, because we already extracted it before, right? So if you remember, we already pulled out headings in step number 4. So basically, performing this operation will remove the first row, since we already have it to repeat it again. Now, coming to step 7. Step 7 is basically the creation of the result list. So all we're trying to do here is we're creating a list and we're calling it result. And this list will basically hold all of the data temporarily until it can be written into a CSV file, which will be our final output. So let me repeat. We're going to create a list called as a result, and this result will be a temporary point of storage for all of our data, which will later be written in a CSV file, and this CSV file will be our output. So basically, running step number 7 will create the list. So basically, at the end of the day, we need to append all of these headings. We need to add all of these headings to the list, right? So result.append of headings will do just that. It will make sure to add all of the heading to the results that we actually want. And step number 9 until step number 8, we have cleaned the data, we have pulled all the data that's required, we have created headings, and we have basically removed all the unwanted spaces, we have created a result list, and we have added the headings there. Now step number 9 deals with adding all the data with respect to the each rows and each columns as well. So until now we already picked up the headings. With respect to step number 9, we are going to basically find all the data that needs to be extracted, to find all the data, to scrape all the data, and we're going to add it to a list called as row. After we are adding it to a list called row, we're going to check if it's present already. If not present, we're going to keep adding it. And after that, we're going to have to add all the data that we found in the row list into the result list, right? So basically the row list will have all the data that we have pulled through all the different rows in the data. So it will not have headings at this point of time. To make sure that the data is collaborating with the headings, which is basically present in our result list, we actually append the rows to the results as well. So performing step number 9 will add all the data of each particular row and eventually append all of this to our result list. And then step number 10 is the most simple step probably, because here is where we are preparing for storage. So whenever you create any file in Python, basically be it CSV file or anything, we need to create a file and we need to open it as well. So basically using the open command, we're creating a file called as data.csv, and we are opening it in the write mode, and we're starting it with a blank line as well. So when you go on to run this particular command in step number 10, it will create an empty file. It will create a file called as data.csv. It will open that file for further working, because we need to write the data, right? So the file writer needs to have access to all of these files that it can write to. So that is why we open it prior to writing. And again, the second part of step 10 is to actually write these files that we actually obtained it into this file called as CSV file, and then we can actually push all of this results. Step number 10 was basically preparing it for storage, creating it, opening it, and make sure that there is a file writer which can write. Step number 11 is where we actually write the result into the CSV file. So writer.write rows of result will write the actual results to our CSV file. This will be pushing all of the data that we have from our result list into the CSV file, and at the end of it, it is always a good practice to close the file basically, which will make sure that the data is saved. So you might be wondering now, okay, step number 11 is done, we've written everything to the CSV file and it is stored, but where is the file? Well, in your case, you will have the file present in the Python interpreters folders. In our case, it will be created basically in the Google ecosystems files. And let me double click on the data.csv that we just created here. And as you can see on the right hand side of your screen, you can choose to pick up how many ever details that you have to show on your screen as well. So here as well, all the countries, all the total cases, the new cases from yesterday, the total number of deaths in that country, new deaths, total recovered, and much more. So this detail we've picked up from the worldometer side. What are the active cases? How many of these active cases where people are serious? What are the total cases for 1 million of population, deaths per 1 million population, and much more. So worldometers is a comprehensive website, and this at the end of the day, this will create a very nice data set, and this data set at the end of the day can be used to perform analysis. Again, to find out how that is done, make sure to check out our machine learning video, which is basically performed using a data set similar to this as well. So this creation of data set, not just in the case of COVID-19, it can be anything across the world. Once you have structured data and once you've created structured files like this, you can understand that you can leverage this and make full use out of it down the ladder. It's basically performing analysis. It can be working with deep learning, working with machine learning, whatever it is. Step 1 is very much essential in all of these fields of processes, and step 1 is creation of data. And we have created a structured pipeline to access our data as well. And this again, in my opinion, is one of the most important use cases or uses of data extraction when you're working with Python as well.
Right, so we'll start off with the questions. So this is our first question over here. So we have this diamonds data set, and we are supposed to extract only those rows where the price value is greater than 1000 and the cut is equal to ideal. So this is our data set over here. So we'd want to extract only those records where the value of the cut is equal to ideal, and this price which you see, and this price needs to be greater than 1000. And we're supposed to implement this with R. So let's do that. Now this diamonds dataset is a part of the ggplot2 package. So first we'll go ahead and load this ggplot2 package. So I'll use the command library of ggplot2, and then let me have a glance at this data set.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So I will use view of diamonds, and this is our diamonds dataset over here. So this is our dataset which comprises of these columns: caret, cut, color, clarity, depth, table, and so on. So our task was to extract only those records where the price value was greater than 1000 and the cut was equal to ideal. And to do that, we'll be using the deployer package. So I'll be loading the deployer package. So deployer is basically a package which is based on grammar of data manipulation. And this is the command to extract those particular records. So first, what I'm doing is, from this diamonds data set, I'll be using the filter function which is part of the deployer package. And with the help of this filter function, I'm giving two conditions inside this. So the first condition is the price needs to be greater than 1000. After that, I'll use the AND operator and then given the second condition. So the second condition is the cut needs to be equal to ideal. And I'll store the result in diamonds 1000 ideal. I'll hit enter. Now let me have a glance at the result. View of diamonds 1000 ideal. So you see that there are 14,700 entries in total where the cut is equal to ideal and the price of the diamond is greater than 1000. So out of the 53,940 records, we have filtered out 14,700 records where the cut is equal to ideal and the price is greater than 1000. Now we have our second question over here. So on the same diamonds dataset, we are supposed to make a scatter plot between the price and the caret. And we are supposed to do that using the ggplot2 package. So over here, the price needs to be on the y-axis and the caret needs to be on the x-axis. So this column, it needs to be on the x-axis, and then we have price. This needs to be on the y-axis. And the color of the points need to be determined by the cut value. So again, let's head back to R and let's implement this. So again, to implement the scatter plot using ggplot, we are supposed to load the ggplot2 package. Alright, and this would be a command to make that particular scatter plot. So ggplot2 is something which is based on grammar of data visualization. So ggplot helps us to stack multiple layers on top of each other. So first off, we'll start with the data layer. On top of the data layer, we'll stack the aesthetics layer. And on top of the aesthetics layer, we'll stack the geometry layer. So first, we have the data layer where we'll give the name of the data frame to this data attribute. And we are working with the diamonds data frame. So the first layer is diamonds. After that, we will map these columns onto the aesthetics. So using this aesthetics attribute inside this ggplot function, I will map this caret column to the x aesthetic, and similarly I will map this price column onto the y aesthetic. And as the question stated, the color of these points need to be determined by the cut column. So again, I'm reiterating it. Caret is mapped onto the x aesthetic, price is mapped onto the y aesthetic, and cut is mapped onto the color aesthetic. And once these two layers are done, we are supposed to build the final layer, which is basically the geometry. And since we are supposed to make a scatter plot, we'll be using the geom point geometry. And this gives us the required scatter plot. Let me zoom this. So as we see over here, price is mapped onto the y-axis, caret is mapped onto the x-axis. And these colors which you see, these basically denote the different cut values. So yellow, it denotes the ideal cut, and this purple which you see, that denotes the fair cut. So you see that if the cut is fair, then mostly the price of the diamond is higher and also the caret value is higher. And when it comes to the ideal cut, we see that the caret range of the ideal cut, it starts from 0 and it's mostly till 3 or 4. So this is the sort of interpretation which we can make from the scatter plot. And then we have our next question. So this time we are supposed to introduce 25% missing values in the iris data set and impute the sepal length column with the mean, and similarly impute the petal length column with the median. So this is the iris dataset. So again, let's head back to our studio and perform these tasks. Let me have a glance at the iris dataset first. View of iris. So this is our iris dataset, which comprises of these 5 columns. So we have sepal length, sepal width, petal width, and species. And our first task is to introduce 25% missing values in this entire dataset, and that'll be totally random. And to introduce missing values, we'll be using the missForest package. So let me load the missForest package using the library function. Now, this missForest package comprises of this prod_any function. And using this prod_any function, I'll be introducing 25% missing values. So this basically takes in 2 parameters. First is the data frame or the object into which we are supposed to introduce missing values. The second parameter is the percentage of missing values that we'd want to introduce. So in this iris data frame, we are supposed to introduce 25% missing values. So I'll give the value of 0.25 and I'll store this in a new object and name that object to be iris.mis. Now let me have a glance at this modified dataset. View of iris.mis. So this is a new data frame which comprises of 25% missing values. Now I'm supposed to impute this sepal length column with the mean and similarly this petal length column with the median. And to impute those 2 columns separately, I would require the HMISC package. So I'll load this package now. Library of HMISC. And this package comprises of the impute function with the help of which I'll be imputing different columns. So first I'll use the width function and this takes in 2 parameters. First is the data frame which consists of missing values. So in this data frame we are supposed to impute the missing values. So this is the iris.mis data frame and this is the first parameter. Next we'll use the impute function and inside the impute function again it takes in 2 parameters. First is the column which we want to impute. Next is the function by which we want to impute this column. So I want to impute the missing values in the column with the mean of this column. So wherever you see any values in this column, all of those values would be replaced with the mean of this column. And I'll store the result back to this column, which is iris.mis $sepal length. I'll hit enter. Now let me have a glance at this imputed dataset. So view of iris.mis. So you see that wherever we had the any values, all of those values have been imputed with the mean. So this 5.85562 which you see, this is nothing but the mean. So initially there was an any value over here and that has been imputed with the mean. Similarly, there was an any value over here and that has been imputed with the mean of this column. Next, similarly, we are supposed to impute this column with the median of this column. So let us do that. So again, I'll use the width function and then pass in this data frame with the missing values. After that, I'll use the impute function and I am supposed to impute this petal length column. And the imputation would be done with the help of the median function. So wherever there are any values, all of those any values would be replaced with the median of this column. And the final result, I'll store it back to the same column. I'll hit enter. Now again, let me have a glance at the modified data frame. So view of iris.mis. So this is a modified data frame. So this 4.2 which you see, this is nothing but the median of this column, right? So wherever there were any values, those any values have been replaced with the median of the petal length. Now let's head on to the next question. So what do you understand by linear regression? Well, linear regression is a supervised learning algorithm which helps us in finding the linear relationship between 2 variables. So one is the predictor or the independent variable and the other is the response or the dependent variable. So we try to understand how does the dependent variable change with the independent variable. So linear regression is a supervised learning algorithm which helps us in finding the linear relationship between 2 variables. So one is the predictor or the independent variable and the other is the response or the dependent variable. And we try to understand how does the dependent variable change with the independent variable. So let's say there's this telecom company called as Neo. And now the data scientist at this company wants to understand if there's a linear relationship between the monthly charges incurred by the customer and the tenure of the customer. So he collects all of the data and builds a linear model between the monthly charges and the tenure. So here, monthly charges would be the dependent variable and tenure would be the independent variable. And in linear regression, there could be more than one independent variable. So if there's just one independent variable, it is known as simple linear regression. And if there's more than one independent variable, it is known as multiple linear regression. So guys, this is the underlying concept of linear regression, where we have one dependent variable and multiple or a single independent variable, and we try to understand the linear relationship between the dependent variable and the independent variables. So next, we're supposed to implement this simple linear regression in R on this empty cars dataset, where the dependent variable is this MPG column and the independent variable is this displacement column. So again, let's head back to RStudio and implement this simple linear regression. So this is our empty cars data frame, which comprises of all these columns. So we have MPG, the number of cylinders, displacement, horsepower, DRAT, weight, CUSEC, VS, AM, gear, and carb. So as the question stated, MPG is our dependent variable and displacement is our independent variable. And we want to try to understand how does MPG vary with respect to the displacement of this column. So now, before we go ahead and implement the model on top of this data frame, we are supposed to divide this data frame into training and testing set so that the model does not overfit the data. So what happens when we don't divide the data set into training and testing sets is, it overfits this data set. And when we give it new data, it'll fail miserably on that new data. So that is why it is always necessary to divide a data set into train and test sets. So let's go ahead and do that. And to divide a data set, we would require this caret package. So let me load up this caret package, library of caret. And this caret package comprises of the create data partition function. Now, this create data partition function would give me true or false labels. And this create data partition function comprises of these parameters over here. First is the column which determines the split. So that is obviously the MPG column. And then we are supposed to give in the split ratio. So I am giving the split ratio would be 0.65. That is 65% of the labels of this column would have the true label and the rest 35% of the records would have the false label. And I am storing this into the split tag object. So again, I'm reiterating it. So I am taking this empty $MPG column data set and 65% of the records would have the true tag associated with it and the rest 35% of the records would have the false tag associated with it. And I'm storing this result in split tag object. Now, once I have the split tag object ready, what I'll do is from this entire empty cars data frame, I'll select all of those records where the split tag value is true and I will store those records in the training set. Similarly, from the empty cars data frame, wherever the split tag value is equal to false. So if I just give in split tag, it'll have all of the true values in it. And when I put in the minus symbol in front of the split tag object, it'll contain all of the false labels. And I will select all of these records and store them in the test set. So now we have our training and testing sets ready. Now let's have a look at the number of rows in training and testing set. So I'll type in n row of train. So see that there are 23 rows in the training set. Similarly, I'll type in n row of test. And now we see that there are 9 rows in the testing set. Now we'll go ahead and build a model on top of the training set. And to build the simple linear model, we would require the lm function. This lm function again takes in 2 parameters. First is the formula. So over here, the formula is MPG tilde symbol displacement. So whatever column we give on the left side of the tilde symbol, that is taken as the dependent variable, and whatever columns we give on the right side of the tilde symbol, all of them are taken as the independent variables. So this time MPG is our dependent variable and displacement is our independent variable, and we are building this model on top of the train set. And we'll store this result in mod underscore empty cars. So now that we've built the model on top of the train set, it's time to predict the values on top of the test set. So for that purpose, we'll be using this predict function, which again takes in two parameters. First parameter is the model which we've built, and the second parameter is the data frame on which we want to predict values. So we want to predict values for the test set, and I will store this in predict empty cars. Now let me have a glance at the predicted values. So head of pred empty cars. So these are the predicted values of MPG for all of these cars. So Mazda RX-4 WAG, the mileage predicted for this car is 22.55. The mileage predicted for Valiant is 20.04. The mileage predicted for Mercedes is 18.08, and so on. So this is how we can build a simple linear model on top of this empty cars dataset. So now we'd have to calculate the RMSE value for the model built. Now when we actually build a regression model, it predicts certain y values associated with a given x value. But there always is an error associated with this prediction. So to get an estimate of average error during prediction, RMSE or root mean square error is used. So again, let's go ahead and calculate the RMSE value for the model which we've just built. So now that we have the actual values and the predicted values, let's bind both of them into a single data frame. So for that purpose, I will use the cbind function, and our actual values are basically present in this MPG column from the test set. And our predicted values are stored in this pred empty cars object, which we had created in the previous question. So I will create this new column and name that column to be actual. And again, similarly, I'll create another column and I'll name it as predicted, which would have the predicted values. And I will store this in a new object and name that to be final data. Let me have a glance at it. View of final data. So these are the actual values of all of the mileage, and these are the predicted values of the mileage for these cars. Now we see that there is an error present in the prediction. Now what we have is actually a matrix. So we are supposed to convert this matrix into a data frame. So I will use the as.dataframe function and convert this object into a data frame. So as.dataframe, I'll pass in this object, which is final data, and I'll store the result in final data again. Now I'll have a glance at the same thing. View of final data. So these are the actual values, these are the predicted values, and we see that there is an error present in the prediction. Now the error is basically difference between the actual values and the predicted values. So let's go ahead and calculate the error in prediction for each of these records. So to calculate the error, all I have to do is subtract the predicted values from the actual value. So it will be final data $actual minus final data $predicted. And I will store this result in a new object and name that object to be error. So now that we've done this, I will also go ahead and bind this error calculated to the same final data frame. So cbind, I'll bind the error object to this final data and I'll store the result in final data again. So it'll be view of final data. So this time we have the actual values, we have the predicted values, and we also have the error in prediction for each of these records. Now to get the average error which is present throughout all of the predictions, you would have to calculate the root mean square error. So the root mean square error, as the name states, first we'd have to calculate the error, then we'd have to take the square of it, then we'd have to take the mean of it, and then finally we'll take the square root. So this is how we can calculate the root mean square error. So final data $error, and we'll square this error first. After that, we'll take the mean of this squared error, and then finally we'll take the square root of the mean squared error. So this is what we have. So the RMSE value for this model which we built is 4.33. Now you guys need to keep in mind that the lower the value of RMSE is, the better the model. So let's say if we had some other model and the RMSE value for that model was 5, then this model would be better than that model. Similarly, let's say if another model's RMSE value was 2, then the second model would be better than the model which you built. Now, similarly, we are supposed to implement simple linear regression in Python on this Boston dataset, where the dependent variable is this MEDV column and the independent variable is the LSTAT column. So now in the data science interview questions, it's not necessary that you'll be asked questions only with respect to one programming language. So you might be asked questions with respect to R and Python, both of them. So that's why it's necessary to be good with both of these languages. Right, so I'll head on to Jupyter Notebook and implement simple linear regression on top of this Boston dataset. So I'll start off by loading the Pandas package. So I'll type in import pandas as PD, and then I'll load this Boston dataset, and to load the dataset I'll be using the read_csv function. So pd.read_csv and the name of the file, which is boston.csv, and I'll store this in the data object. So now that we've loaded the data, let me have a glance at the head of this data. So these are all the columns and the first 5 records present in the data frame. So we have Crim, Zn, Indus, Cas, Nox, Age, and so on. And for the task of simple linear regression, MEDV is our dependent variable and LStat is our independent variable. So this MEDV is basically the median value of price of the houses. And we are trying to understand what is the median value of the price of the houses with respect to this LStat column over here. Now, before we go ahead and implement the model, let's understand the dataset a bit more. So I'll use this data.shape, which would give me the number of rows and columns present in this data frame. So we see that there are 506 rows in total and 14 columns in total. Now I'll go ahead and separate the independent and dependent variable from this entire data frame. So for that purpose, I'll use this data.loc, and since I want all of the records, I'll take all of the records, and the only columns which I want from this entire data frame are LStat and MEDV. And I'll store this result in data1, and I'll also have a glance at the first 5 records of this data frame. So these are the first 5 records of this new data frame where I have only LStat and MEDV columns. Now I'll also go ahead and do a bit of visualization with respect to these 2 columns. And for that purpose, I would require the matplotlib package. So I'll go ahead and import this matplotlib package as well. So here what I'm doing is, I am mapping the LStat column onto the x-axis and the MEDV column onto the y-axis. And I will give the label of the x-axis as LStat and the label of the y-axis as MEDV. And finally, I'll show this graph which I've built. So what I've built is basically a scatter plot where MEDV is on the y-axis and LStat is on the x-axis. So you see that as LStat increases, MEDV decreases. So there is an inverse relationship between MEDV and LStat. So again, I'm reiterating it. As LStat increases, MEDV decreases. So this tells us that there is an inverse relationship between MEDV and LStat columns. Now, to build the model, we are supposed to separate the independent variable and dependent variable into 2 separate objects. So I'll take this LStat column from data1 and store it into X object. Similarly, I'll take this MEDV column from data1 object and store it in Y object over here. So X consists of my independent variable and Y consists of my dependent variable. Now it's time to divide the data set into training and test sets. So we have this train test split function from sklearn.model selection. I'll go ahead and load that function, and this function over here takes these 3 parameters. So X and Y are basically the dependent variable and the independent variable, and then we have test size is equal to 0.2. So this states that 80% of the records would be in the training set and 20% of the records would be in the testing set. So it's a 80-20 split. And this random state which you see, so this is basically a seed value, so that if I want to get the same values again, I can set the same random state to get the same values. And I am storing these values in xtrain, xtest, ytrain, and ytest. So xtrain contains all of the train values for that independent variable. Xtest contains all of the test values for the independent variable. Similarly, ytrain contains all of the train values for the dependent variable, and ytest contains all of the test values for the dependent variable. So now that we have xtrain, xtest, ytrain, and ytest, it's finally time to build the model. So I'll go ahead and load the linear regression model from sklearn.linear model, and then I'll fit the model. So first I'll create an instance of this. So linear regression, and I'll create an instance and I'll name that instance to be regressor. And with the help of this instance, I'll fit the model on top of the training set. So regressor dot fit, and I will pass in X train and Y train. So to sum it up, what I'm basically doing is building the linear regression model on top of the training set, which basically comprises of the independent variable and the dependent variable. I'll click on run. Now let me have a glance at the intercept and the m value of it. So linear regression is nothing but y equals mx plus c. And that c is nothing but the intercept. So you see that the intercept is 34.12. And m, which you see, this is the coefficient. This coefficient is nothing but the slope. And you see that the coefficient is minus 0.91. So there is a negative value associated with the coefficient because there is an inverse relationship between the dependent variable and the independent variable, as we saw over here. So as LSTAT increases, MEDV decreases. And that is the reason this coefficient is associated with a negative value. So now that we've built the model, it's time to predict the values on top of the test set. So again, I'll use this instance and I will use the predict function with the help of this instance. So regressor.predict, and I will pass in this xTest object inside this function, and I'll store this in the ypred object. So we've built the model and we've also predicted the values. Now let me have a glance at the number of rows and columns of the actual values and the predicted values. So we see that both the predicted values and the actual values comprises of 102 records in total. So now that we predicted the values, we'll go ahead and calculate some metrics. So we'll find out the mean absolute error, the mean squared error, and the root mean squared error. I'll click on run. So see that the mean absolute error for this model is 4.69, the mean squared error is 43, and the root mean squared error is 6.62. So again, the lower the values of these three, it means the better the model is. So let's say if we are comparing these values with some other model, and if these values are less than that second model, then the first model would be better than the second model. So that was implementing simple linear regression in Python. Now we have our next question over here. So the question is, what do you understand by logistic regression? Well, logistic regression is actually a classification algorithm which can be used when the dependent variable is binary. So let's take this example. So here we are trying to determine whether it will rain or not on the basis of temperature and humidity. That is, temperature and humidity are the independent variables and rain would be our dependent variable. That is, we're trying to understand whether it will rain or not on the basis of the temperature and the humidity. And again, logistic regression algorithm, it actually produces an S-curve. So let's say x-axis over here, it represents the number of runs scored by Virat Kohli, and the y-axis represents the probability of Team India winning the match. So let's say this point over here, it denotes 50 runs. So what we can see from this graph is, so if Virat Kohli scores more than 50 runs, then there is a greater probability for Team India to win the match. And similarly, if Virat Kohli scores less than 50 runs, then the probability of Team India winning the match is less than 50%. So let's take this value over here. So let's say the number of runs scored by Virat Kohli is around 60. So if the number of runs scored by Virat Kohli is around 60, then the probability of Team India winning the match would be, let's say, around 65% or so. Again, let's take this value over here. So let's say this is around 97 runs or 95 runs. And if Virat Kohli scores 95 or 97 runs, then the probability of Team India winning the match is 1, which is 100%, isn't it? So similarly, this value over here. So let's say this is around 5 runs or 10 runs. So if Virat Kohli scores 5 or 10 runs, then the probability of Team India winning the match is 0. So basically in logistic regression, the y value lies within 0 and 1 range. And this is how logistic regression works. So now we are supposed to implement logistic regression on this hard data set where the dependent variable is this target column and the independent variable is the age column. So let's go ahead and implement logistic regression. So let me start off by loading this data set first. I'll use the read.csv function. Now let me have a glance at this dataset, view of heart. So this is our entire data frame, and this target which you see, this is our dependent variable, and we have the age column over here, and this is the independent variable. So we are actually supposed to rename this. So we see that the column name is incorrect over here. So our first task could be to rename this column. Let me go ahead and do that. So I'll use the column names function and I'll pass in this data frame, which is heart, and I am supposed to rename the first column. So I'll give in 1 inside the parenthesis and I will rename this to be age. So now again, let me have a glance at this modified data frame. So it'll be view of heart. So see that we have successfully renamed this column from IH to age. Now let me have a structure of this data frame. So structure of heart. So you see that most of these are integers. But then again, since we are building a logistic regression model on top of this data set, this final target column is supposed to be categorical. It cannot be an integer. So we'll go ahead and convert this into a factor. So I'll use the as.factor function and convert this integer value into a categorical value. So as.factor, and I'll pass in this column over here, which is heart $target. And I'll store the result back to heart $target. Now again, let me have a glance at the structure. So that will be structure of heart $target. So initially it was integer. Now we have converted that integer column into a categorical value, which has two levels, which are 0 and 1. So now I'll actually build a simple logistic regression model, and I'll not divide this data set into training and testing sets. So we'll do this and we'll see what are the different probability values for the person to have heart disease on the basis of the different age values. And to build the logistic regression model, we'll be using the GLM function. So again, this takes in 3 parameters over here. First parameter is the formula. So here target $age is the formula, which basically indicates that target is our dependent variable and age is our independent variable. And we are building this model on top of the entire data frame, and family is equal to binomial. So when we state family is equal to binomial, we are basically telling R that this is a logistic regression model, and I'll store the result in log mod 1. So now let me have a glance at the summary of the model which we've just built. So summary of log mod 1. So we have this p-value over here, and we see that there are 3 stars associated with this p-value. So this basically means that we can reject the null hypothesis. That is, the null hypothesis states that there is no relationship between the age and the target columns. But since we have 3 stars over here, this states that the null hypothesis can be rejected and there is a strong relationship between the age column and the target column. Now again, we have other parameters over here. So we have something known as null deviance and residual deviance. So simply put, the lower the deviance value, the better the model. So this null deviance basically tells us the deviance of the model when we don't have any independent variables. That is, when we are trying to predict the value of the target column with only the intercept. So if that's the case, then null deviance is 417.64. And residual deviance is that deviance when we include the independent variables and try to predict the target column. So when we include the independent variable, which is age, we see that the residual deviance drops. So initially when there were no independent variables, the null deviance was 417. After we included the age column, we see that the null deviance has reduced to 401. So this basically means that there is a strong relationship between the age column and the target column, and that is why the deviance has reduced. So now that we've built the model, we will go ahead and predict some values. So now I want to know the probability of the person not having heart disease when his age is equal to 30. So now let me actually head back to this data frame over here. So the values in this target column, it is 0 and 1. So when we predict the values, we get the prediction for 0. That is, the person not having heart disease. So when the person's age is 30, we see that the probability of the person not having heart disease is 81.2%. Now similarly, I'll predict the probability of the person not having heart disease when the age is 50. So when the age is 50, we see that the person not having heart disease, the probability, it comes down to 60%. Now what I'll do is, I'll predict the values for a set of age values. So this time the age value, it starts at 29 and it goes on till 77. So I'll get a set of predictions starting from 29 to 77. So you see that when the age is 29, the probability of the person not having heart disease is 82%. Similarly, when the age of the person is 30, the probability of the person not having heart disease is 81%. So as the age increases from 29 to 77, the probability of the person not having heart disease decreases. So this is the final case over here when the age of the person is 77. So when the age of the person is 77, the probability that the person does not have a heart disease is 26%. So this is quite an interesting relationship, isn't it? So we see that as the age of the person increases, there is more likelihood that the person would have heart disease. So this model we built on top of the entire data set. Now what we'll do is, we'll divide this data set into train and test sets and build a model on top of the train set and predict the values on top of the test set. So again, for that purpose, I would require this caret package. So library of caret. Again, this caret package comprises of the create data partition function. So this takes in these parameters over here. So this is the split criteria, which is hard $target. That is, I want to split this data frame with respect to this target column. And the split ratio, which I'm stating over here, is 0.7. That is, 70% of the records would have the true label associated with them, and the rest 30% records would have the false label associated with them. And the final result, I am storing it in split tag. Now, what I'll do is, from the entire hard data frame, whichever records have the true label associated with them in the split tag, I'll take all of those records and I'll store them in the training set. Similarly, from the entire hard data frame, wherever the split tag value is equal to false, I'll take all of them and I will store them in the test set. So I have my training and my testing sets ready. Now let me have a glance at the number of rows of the training and testing set. So n row of train, there are 213 rows, and n row of test, there are 90 rows. So now that we have the training and testing sets ready, let me go ahead and build the model on top of the training set. So again, we'll use this GLM function and build the model. So this time the formula is the same, which is basically target tilde age. So target is the dependent variable, age is the independent variable, and we're trying to determine the probability of the patient having heart disease with respect to his age. And we are building this model on top of the train set. And since this is a logistic regression model, the family would be equal to binomial, and I'll store this result in log mod 2. Now that we've built the model, it's time to predict the values. So I'll use the predict function, and this again takes in these three parameters. First is the model which we've just built, and then second parameter is the object on which we want to predict the values. So we want to predict the values on top of the test set. And finally, we'll set the type to be equal to response, which will basically give us probabilities for these predictions, and I'll store the result in pred hard. So let me have a look at the range of the predicted values. So we see that the range of the predicted values of the heart disease, it varies from 0.21 to 0.86. That is, the probability of the patient having heart disease, it varies from 21% to 86%. And this is how we can build a simple logistic regression model on top of this heart disease dataset. Now let's head on to the next question. So what is a confusion matrix? So confusion matrix is actually a table which is used to estimate the performance of a model. It tabulates actual values and the predicted values in a 2x2 matrix. So these are the actual values and these are the predicted values. So this what you see, true positives. So this denotes all of those records where the actual values were true and the predicted values were also true. So these denote all of the true positives. After that, we have the false negatives. So false negatives denotes all of those records where the actual values were true, but the predicted value was false. So where the actual value is true, but the predicted value is false, that is known as a false negative. Then we have false positives. So in false positive, the actual value is false, but the predicted value is true. And such values are known as false positives. And finally, we have the true negatives, where the actual values are false and the predicted values are also false. So if we want to get the correct values, then correct values would basically represent all of the true positives and the true negatives. And this is how confusion matrix actually works. So now we are supposed to build a confusion matrix for the model which we built, where the threshold value for the probability of predicted values is 0.6, and then we have to find the accuracy of the model. So as I've already stated, accuracy is basically true positives plus true negatives upon all of the values. So this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. So when we divide the left diagonal with all of the values, that is when we'll get the accuracy of the model. So let's go to RStudio and find out the accuracy of the model which we built. So to build a confusion matrix in R, we'll be using the table function, and inside the table function, first we'll give in the actual values and then we'll give the predicted values. So the actual values are stored in this target column of the test set, and the predicted values are stored in the pred heart object which we had created. And then we saw that the range of the probabilities, it was from 0.2 to 0.8. So from that range of 0.2 to 0.8, I am setting a probability threshold of 0.6. That is, wherever the probability is greater than 0.6, it will be classified as 0. Or in other words, it will be classified that the person does not have heart disease. And similarly, wherever the probability is less than 0.6, it will be classified as 1. Or in other words, that the patient has heart disease. So I'm reiterating it again. So wherever the probability of pred heart is greater than 0.6, it will be classified as 0. And wherever the probability of pred heart is less than 0.6, it will be classified as 1. So let's go ahead and build a confusion matrix. So you see that this is our confusion matrix, and this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. And if you want to find the accuracy, all we have to do is divide this left diagonal with all of the values. So that'll be 31 plus 17 divided by 31 plus 17 plus 10 plus 32. So you see that we get an overall accuracy of 53% for this model which we built. Now let's head on to the next question. So what do you understand by true positive rate and false positive rate? So let's start with true positive rate. So in machine learning, true positive rate, which is also referred to as sensitivity or recall, is used to measure the percentage of actual positives which are correctly identified. So the formula for true positive rate is true positives divided by all the positives. So I am stating it again. True positive rate is basically the measure of the percentage of actual positives which have been correctly identified. Now let's look at false positive rate. So false positive rate is basically the probability of falsely rejecting the null hypothesis for a particular test. So the false positive rate is calculated as the ratio between the number of negative events wrongly categorized as positive, that is all of the false positives, upon the total number of actual events. So this is how we can calculate true positive rate and false positive rate. Now we have the next question, and we are supposed to explain what is ROC curve. So ROC curve, which actually stands for receiver operating characteristic, is basically a plot between the true positive rate and the false positive rate. And it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So the closer the curve is to the upper left corner, the better the model is. Or in other words, whichever curve has greater area under it, that would be the better model. So let's say we have this curve over here, and let's say there is another curve which goes like this, which is nearer to this upper left corner. Then in that case, since the second curve covers greater area under it, that would be a better model than the first model. So this ROC curve helps us to find out the area under the curve as well as the right trade-off between the true positive rate and the false positive rate. Now we are supposed to build the ROC curve on top of the logistic regression model which we've built. So let's head back to our studio and do that. So to build the ROC curve, we would have to load the ROCR package. So I'll use the library function and load up the ROCR package. Now this ROCR package comprises of the prediction function, which would give me a prediction object. So this takes in two parameters. First parameter is all of the predicted values.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
So this spread hat comprises of all of the predicted probabilities for the target column. And the second parameter is the labels of the dependent variable. So test $target has all of the labels of the dependent variable, and I will store this result of the prediction object in ROC pred hat. So now that we've created the prediction object, we can go ahead and build the ROC curve. And to build the ROC curve, we'll use the performance function, which is again a part of the ROCR package. So this over here takes in three parameters. First is the prediction object which you built. So the name of the object was ROC pred hat. After that, we will just give in TPR and FPR. So TPR and FPR stands for true positive rate and false positive rate. So for this prediction object which we built, we are basically trying to find out the right trade-off between the true positive rate and the false positive rate. And I'm storing the result in ROC curve. Now, let me go ahead and plot this ROC curve which I've just built. So this is our ROC curve over here. Let me zoom this. So we have this curve for different probability values over here. So this what you see are the different probability values. And our ideal curve should be something like this, where we have more of true positives and less of false positives. And this green color which you see, so this green color actually represents the ideal threshold value. So the ideal threshold value over here would be somewhere between 0.48 and 0.62. So this is where we would have the ideal threshold value of the probability. And this is somewhere where we can get the right trade-off between the true positive rate and the false positive rate. So maybe it could be this over here. So this point which we see, so the probability would be somewhere around 0.5 or somewhere around 0.55. So this is where we could get the right trade-off between the true positive rate and the false positive rate. So now that we've built a logistic regression model in R, again we need to know how to build a logistic regression model in Python. So this time we are supposed to build this logistic regression model on top of this customer churn data frame, where the dependent variable is this churn column and the independent variable is this monthly charges column. And after that, we are supposed to find out the log loss of the model. So we are basically trying to determine whether the customer would churn or not on the basis of this monthly charges column. So again, I'll start off by loading the Pandas data frame and also load the customer churn.csv file. And for that purpose, I'll be using the pd.readcsv function. Right, so we have successfully loaded the file. Now it's time to have a glance at the head of this data set. So these are the different columns which we have. So we have this customer ID, then we have the gender of the customer, we have the senior citizen column, which tells us whether the customer is a senior citizen or not. This column tells us whether the customer has a partner or not. This column tells us if the customer has any dependents or not, the tenure of the customer, whether the customer has phone service or not, and so on. Sort of all of these columns, the columns which are of our concern would be the monthly charges column and churn column. So this monthly charges column basically tells us the monthly charges incurred by the customer in dollars. And this churn column tells us whether the customer would churn or not. So now since we have our data set with us, let me go ahead and separate the dependent variable and the independent variable into two separate objects. So I'll store this monthly charges column from this customer churn data frame in the X object. Similarly, I'll store this churn column from the customer churn data frame in the Y object. So we have our dependent variable and independent variable to be separate. Now I'll go ahead and divide this model into training and testing set. And for that purpose, I would require this train test split function, which is part of the sklearn.model selection package. Now I'll use this train test split function, and this takes in these parameters. First are basically the independent variable and the dependent variable. So the independent variable is stored in X and the dependent variable is stored in Y. After that, I'll set the test size to be equal to 0.3. So this basically states that 70% of the records would be in the training set and the rest 30% of the records would be in the test set. And again, I'll set a random state value so that I can use these same values again if I want to. And I am storing all of these values into xtrain, xtest, ytrain and ytest. So xtrain comprises of the training set of the independent variable. Similarly, xtest comprises of the test set for the independent variables. After that, we have ytrain, which comprises of training set for the dependent variable. And then we have ytest, which is the test set for the dependent variable. So now we have xtrain, xtest, ytrain and ytest. It's time to build the model, predict the values and get the log loss value. So first I will import this logistic regression function from this sklearn.linear model package, and I'll create an instance of logistic regression. I'll store it in L, and then I'll fit the model on top of the training set. So L.fit, and I'm fitting the model on top of xtrain and ytrain. After that, I'll predict the probabilities on top of the test set. So L.predict underscore proba, and I'll pass in x underscore test, and I'll store the predicted probabilities in y underscore pred. So now that we've fit the model and also predicted the probabilities, it's time to look at the metrics. So the question stated that we were supposed to find out the log loss. So I'll just import the log loss from sklearn.metrics, and inside this log loss function, I will pass in the actual values and the predicted values. So actual values are stored in ytest and predicted values are stored in ypred. So we get a log loss value of 0.55. Now again, similar to RMSE, the lower the value of log loss, the better the model is. So again, let's say if there is another model and the log loss value of that second model is less than this, then that second model would be better than this model. Now we'll head on to the next question. So what do you understand by decision tree? So decision tree is a supervised learning algorithm which is used for both classification and regression. Right. So decision tree can be used for both classification purpose as well as regression purpose. So in this case, the dependent variable can be both a numerical value as well as a categorical value. So there is a flowchart like structure where the topmost node is known as the root node, the internal nodes with children are known as the branch nodes, and the final nodes without children are known as the leaf nodes. So here, each node actually denotes a test on an attribute, and each edge represents an outcome of the test, and each leaf node holds a class label. So let's say this first node over here, we are trying to determine the age of the patient. So let's say if the age of the patient is greater than 50. If the condition is true, we'll come here. If the condition is false, then we'll come here. After that, over here, we'll check if the person smokes or not. And if that person smokes, we'll come here. If that person doesn't smoke, we'll come here. Similarly, over here, the test condition could be whether the patient has any children or not. If the condition is true, we'll come here. If the condition is false, we'll come here. So this is how the decision tree works. And finally, we'll have class labels over here. So these would represent individual class labels. So let's say this represents that the person has cancer. This represents that the person does not have cancer. Similarly, this would represent that the person has cancer. And again, this would represent that the person does not have cancer. So in decision tree, we basically have a series of test conditions which would give us the final class labels. Right. So now we have to build a decision tree model on top of this iris dataset, where the dependent variable is the species column and all other columns are independent variables. And after we build the model, we are supposed to find out the accuracy of the model. So let's go ahead and do this. So I'll start off by having a glance at the iris dataset. View of iris. So this is our data frame which comprises of all of these columns over here. And to build a decision tree model, we'll be loading the party package. So library of party. So again, before I go ahead and build the model, our task is to first divide this data frame into training and testing sets. So again, I will load up this caret package, library of caret. I'll use this create data partition function, and this create data partition function takes in the species column as the split column, and I'll give the split criteria to be 0.65. That is 65% of the records would be having the true label and the rest 35% of the records would be having the false label, and I'll store that in split tag. Now from the iris dataset, wherever the value of split tag is equal to true, I'll store that in the train set. Similarly, from the entire iris dataset, wherever the value of split tag is equal to false, I'll store that in the test set. Now again, let me have a glance at the number of rows of the training and testing set. So you see that there are 99 rows in the training set and there are 51 rows in the testing set. So now again that the train test split is done, we can go ahead and build a model. And to build the model, we'll be using the C-tree function, which is a part of the party package. So this again takes in two parameters. First parameter is the formula. Next parameter is the data set on which we are supposed to build the model. So here the formula is species tilde dot. So this tells us that species column is the dependent variable, and when you put a dot on the right side of the tilde symbol, that basically means that all other columns except the dependent variable are the independent variables. So sepal length, sepal width, petal length and petal width, all of them would be the independent variables and species would be the dependent variable. And again, we are building this model on top of the train set, and I'll store this result in my tree object. So now that we've built the model, let me plot it. So plot, and I'll pass in this object, which is my tree. Now let me zoom this. So this is our root node, and the root node, the split criteria is on the basis of the petal length column. So we see that if the petal length is less than or great, so see that if the petal length is less than or equal to 1.9, then we come over here and this tells us that the species of the flower is setosa. On the other hand, if that is not the case, that is, if petal length is greater than 1.9, then we have another test condition over here. So here we check if petal width is less than or equal to 1.7. And if it is true, again we have two scenarios. So here we are checking if petal length is equal to or less than 4.7. So if petal length is equal to or less than 4.7, then there is a 100% probability that the species of the flower is versicolor. Similarly, if the petal length is greater than 4.7, then there is around a 60% probability that the species is versicolor, and there is around a 40% probability that the species is virginica. On the other hand, from over here, if we directly come over here and if we check that petal width is greater than 1.7, then in that case, there is almost a 100% probability that the species of the flower is virginica, right? So these are the test conditions on the basis of which we are trying to determine to which class does the species belong to. So now that we've built the model, let's go ahead and predict the values. So I'll use the predict function again. This takes in these parameters. First is the model which we built. So the name of the model is my tree. And then this is the data set on top of which you want to predict the values. So we want to predict the values on top of the test set. And then finally we want the response. And that response I'm storing in my pred object. Now after this, let me go ahead and build the confusion matrix. And to build the confusion matrix in R, we'll be using the table function. And the first parameter includes all of the actual values and the second parameter includes all of the predicted values. And this is what we have over here. So this denotes all of those records where the actual value is setosa and all of those actual values have been correctly predicted as setosa. So there are 17 such instances. So this denotes all of those records where the actual value is versicolor and all of them have been predicted as versicolor. So there are 16 such instances. And this one denotes those records where the actual was versicolor, but it has been incorrectly classified as virginica. Similarly, this one over here, this states that there is one record where the actual value is virginica, but it has been incorrectly classified as versicolor. Similarly, this 16 which we see. So out of the 16 records which were actually Virginica, all of those 16 records have been correctly classified as Virginica. Now again, to find out the accuracy, we are supposed to divide this left diagonal with all of the values. So that'll be 17 plus 16 plus 16 divided by 17 plus 16 plus 16 plus 1 and 1. So you see that we get an accuracy of 96% for the model which we've built. Now let's head on to the next question. So what do you understand by random forest model, and also explain the working mechanism of random forest? So random forest is an ensemble model. That is, it combines multiple models together to get the final output. And to be precise, it combines multiple decision trees together. Now let's understand the working mechanism of random forest model. So let's say we have this dataset A and we have n records in it. Now what I'm going to do is draw samples from this dataset. So this actually will be sampling with replacement. That is, I'll take one record from dataset A, take note of it, and enter the same sample in dataset A1, and then put the record back to where it came from. And I'll repeat this process n times so that there are n records in dataset A1 as well. So what you need to keep in mind is, out of these n records in A1, some of them might have come twice, thrice, or even several times over, while some records from A might not have made it at all to A1. So I've created A1 like this. Now I'll go ahead and create multiple datasets the same way, and each of these have the same number of records as A. And the X over here, it could be anything. Let's say 100, 500 or 1000. So from just one dataset A, we were able to create multiple datasets for our advantage. So just for our sake, let's say the dataset A has 1000 rows and the value of X is also 1000. So it would be 1000 cross 1000, which would give us 1 million rows. That is, from just 1000 rows of data, we were able to create 1 million rows. Now for each of these X datasets, we'll fit X decision trees. Now let's say this A1 dataset over here has 10 independent variables. So what happens in a random forest is, each time a node is being split in a decision tree, not all 10 columns will be provided to the algorithm. This is important, so I am reiterating it, guys. So each time a node is being split in a decision tree, not all 10 columns will be provided to the random forest algorithm. So now the question arises, what would be made available to the algorithm? So only a random subset of these 10 columns will be available to the algorithm. So let's say I want to split this root node now. So instead of providing it all the 10 columns, only a subset of the columns will be provided. So let's say 3 columns, and it could be any 3 out of the 10. And with those 3, the algorithm goes on to split the node. And similarly, from the left node over here, it is again going to be provided with a random set of 3 variables. And it is not necessary that the left node should get the same 3 variables. It can be a different set of 3 columns altogether. So whenever we are splitting a node, it is given a random set of m predictors from the entire predictor space. And the reason this is done is to make each of these X trees very, very different from each other. Now let's say a new record Ri comes our way. Then we are going to pass this record to each of these X trees, and we are going to get each tree's prediction on what class this new record is going to represent. And since we have X trees, we'll get X predictions in total. And to get the final prediction, all we have to do is select that class which would have the majority of the votes across all the predictions of the individual trees. So guys, this is the working mechanism of random forest. So now we'd have to go and build a random forest model on top of this CTG dataset, where NSP is the dependent variable and all other columns are independent variables. So let's head on to RStudio and implement the random forest model. Alright, so let me start off by loading the CTG dataset. So I'll use the read.csv function and load this file. Now let me have a glance at this data. So view of data. So this is our dataset which has all of these rows and columns, and this is our dependent variable where we have these 3 values 1, 2 and 3. So this 1 basically means that the person does not have cancer, 2 means that the person is suspected to have cancer, and 3 means that the person has cancer, right? So these are the 3 different levels associated with this NSP column. Now, let me have a glance at the structure of this dataset. So structure of data. So you see that this NSP column is actually an integer. So we'd have to go ahead and convert this integer type into a factor. So I'll use the as.factor function and convert that NSP column from an integer to a factor, and I'll store that back to same column, data $NSP. Now let me have a glance at the structure of it again. So structure of data. So see that initially this column was an integer. So using the as.factor function, we have converted this into a factor with 3 levels. Now let me have a glance at the frequency of the values of this NSP column. So see that there are 1655 patients who don't have cancer, 295 patients who are suspected to have cancer, and 176 patients who do have cancer. So now, before we go ahead and build the model, we are supposed to divide the data set into train and test sets. So first we'll set a seed value. So that seed value would be 1, 2, and 3. Now, I'll go ahead and create the data partition, and the split column is basically this NSP column, and the split ratio which I'm giving over here is 0.65. That is 35% of the records would be in the test set, and the rest 65% of the records would be in the training set. And I'll store this in split tag again. Now from this entire data object, wherever the value of split tag is equal to true, I'll store all of those records in the train set. Similarly, from the entire data object, wherever the value of split tag is equal to false, I'll take them and I'll store them in the test set. So we have our training and testing sets ready. Now again, let me have a glance at the training and testing sets. So n row of train, there are 1383 records in the training set. Similarly, n row of test, there are 743 records in the test set. So now that we've divided the data into training and testing sets, I can go ahead and build the random forest model. So for that purpose, I'd have to load the random forest package. So I'll use library of random forest and I'll load up the random forest function. Now again, I'll set a seed value and the seed value would be 222, and I'll build the model. And I am building the model on top of the train set. So I'm using the random forest function. And this random forest function again takes in 2 parameters. First parameter is the formula. Second parameter is the object or the data set on which we are supposed to build the model. So the formula is NSP tilde dot. That is, this NSP column is our dependent variable and all other columns would be our independent variables. And we're trying to determine whether the person does not have cancer, is suspected to have cancer, or has cancer with respect to all of the other columns. And we are building this model on top of the train set, and I am storing this result in the RF object. Now that we've built the model, let me go ahead and predict the values on top of the test set. So again, I'll be using the predict function. This again takes in 2 parameters. First is the model which we've just built. So the model which we've built, the name of that model was RF, and we are supposed to predict the values for the test set. So I'll give in test over here and I will store the result in the P1 object. Now let me build a confusion matrix for this. So table, and this table function will take in the actual values and the predicted values. So the actual values are stored in the NSP column of the test set and the predicted values are stored in the P1 object. So this is what we have. So this left diagonal represents all of those values which have been correctly classified. So this 567 which you see, so this represents all of those records where the patient actually did not have cancer and it was correctly classified by the model that those patients did not have cancer. So this 8 which you see, this tells you that there were 8 patients or 8 records where the patient did not have cancer, but then again it has been predicted that the patient is suspected to have cancer. Similarly, this 4 over here, it represents those records where in actuality the person did not have cancer, but it has been predicted that the person has cancer. Similarly, if we take this row over here, this 20 represents all of those records where that person in actuality is suspected to have cancer, but it has been incorrectly classified that the person does not have cancer. And this 81 represents all of those records where the person is in actuality suspected to have cancer and it has been correctly classified. And that is how it goes for the rest of the records. So if you have to calculate the accuracy, we are supposed to divide this left diagonal with all of the values. So that will be 567 plus 81 plus 51 divided by all of the values. So 567 plus 81 plus 51 plus we have 2 plus 3 plus 8 plus 4 plus again 2 plus 5 plus 5. And this gives us an accuracy of 96%. So what I've done is I have divided this left diagonal with all of the values, and for the model build I got an accuracy of 96%. So guys, these are some of the questions which you frequently come across when you appear for data science interviews. Let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'd have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary and we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary, which is my dictionary. I'll put in dot, and then I'll just type in keys. I'll click on run, and we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange, and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2, and house number 3 are our real world entities, which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name. And after this, I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object. Right. And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard. Right. So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created 2 get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly, I'll create another method which would be put age and I'll pass in self inside this. So for this, it would be print of your age is. Let me again put in double quotes over here. Right. So your age is, it would be self.age. So we have created our class where we have 2 variables, name and age, and I've created 4 methods. And out of those, from those 2 methods, I'll be getting the name and age of the person, and the rest of the 2 methods would help me to print the name and age of the person. Right, I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance, and I just have to call in human. So I'm creating a person instance of the human class. Now, from this person object, I will invoke the getName and getAge methods. So person1.getName. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right, so now it's time to get the age of the person. So I'll type in person1.getAge. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right, so we have successfully created our class which would print out the name of the person and the age of the person. Right, so next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method. Right, so we have created our init method, which is basically a constructor, and going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this, we have age. So let me change this to be age over here, and this would be self.age. After this, we'll have to print in the branch. So let me just put in branch over here, and this would be self.branch. Right, so we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now, since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, We'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use this super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3. And the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 NumPy array comprising of all the zeros. So there's a 5 cross 5 NumPy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the NumPy library. Let me just type in import NumPy as np, and inside A, I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out A. So we have successfully created our 5 cross 5 NumPy array where all of the values are just zeros. Now let's say we have two NumPy arrays like this. So this is our first NumPy array, this is our second NumPy array. First NumPy array comprises of 1, 2 and 3. Second NumPy array comprises of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7 and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the NumPy library, import NumPy as np. I will go ahead and create my first NumPy array, A equals np.array. And the values are 1, 2 and 3. Similarly, I'll create my second NumPy array, which is B. I'll change this variable to be equal to B, and the values are 4, 5 and 6. Now, to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the NumPy arrays which I'd have to add. So I want to add A and B. And I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a NumPy array. So this is our NumPy array over here. and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68, and I'd have to get the first two largest values, which over here are 100 and 68.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.
Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this numpy array. So 100 and 68 are the two highest values from this numpy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as pd. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4 and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24 and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango and orange, and the count of the fruits is 12, 24 and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width, and species. Now, out of this, we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the Pandas library, import Pandas as PD. And after this, to load a CSV file, I'd have to use the pd.read CSV function. And I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this dataset. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now, let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is, again, iris, and from this, I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal dot width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we give in the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be Pandas and NumPy. So import Pandas as PD and import NumPy as NP. After this, I'll load the iris dataset. So iris equal to pd dot read CSV, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column. And the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame. And with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these three columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the Pandas data frame. I'll type in import Pandas as PD. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readCSV function. And I'll give in the name of the file, which is enhance.csv. And I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right, so we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here, right? So this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in two parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function, and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda, and then you'll give in all of your arguments. After that, you'll put in a colon, and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda, and I'll give the name of the variable to be a. I'll give a colon, and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the numpy package. So I'll type in import numpy as np, and I would also need the matplotlib package. So I'll type in from matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x, and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt.plot, and I'll pass in x, comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt.x label. So the label would be x-axis. Similarly, plt.y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt.title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange. And we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list. Right. So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1. Right, so this is our numpy array which comprises of the numbers from 0 to 9, and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the numpy library. Import numpy as np. After this, what I have to do is create my numpy array. So arr equals np.arange, and it will go from 0 to 10. Let me just print out this numpy array over here. This is my numpy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So arr %2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'll have to perform an operation so that we get the common items between two numpy arrays. This is our first numpy array. This is our second numpy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first numpy array and I'm storing it in A. This is my second numpy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two numpy arrays inside this as the parameters. So A, B, I'll pass in these two, I'll click on run, right? So I've got the common elements present in these two arrays, right? So we have a Pandas series over here, and we'd have to convert each of these elements into title case. So Mary had a little lamb. So we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the Pandas library. Import Pandas as PD. Now I'll create the series pd.series, and I'll pass in the values, which are basically Mary had little lamb. Right, so this is done, and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now, right? So this is my Pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital, right? And as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a Pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x, colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here. Right, so all of these elements have been converted into title case. So now we have the same Pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3 and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this Pandas series. Import Pandas as PD. Let me again create the series. Ser equals pd.series, and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this Pandas series, I'll have to use the map method. So ser.map, and inside this, I'll again create a new lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In had there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s_length. Let me load the package. Import pandas as pd, and I'll also load the file. So pd.read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s_length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here. I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s_length. So it'll be s_length. So this is how it goes. So iris.rename, and the original column name is sepal.length, and I'd have to change it to s_length. And I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1.head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the Pandas library, import Pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in xtrain, xtest, ytrain, and ytest. So xtrain would comprise of all of the training values or all of the training records for the features. And xtest is basically the test set for the features. Ytrain is the train set for the target and ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of xtrain and ytrain, or in other words, I'm fitting the model on top of the train set. Right. So now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length, and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. 30. So I'll start off by loading the requisite packages, which are NumPy and Pandas. So import NumPy as NP and import Pandas as PD. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these 4 columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first 4 columns. So I'll just extract sepal length, sepal width, and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame, and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'd have to import train test split from sklearn.model_selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set, and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain, and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics, and we'll also get the accuracy score. Right. So this is my confusion metrics, and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly, and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly, and 2 of them have been classified incorrectly. So to get the accuracy, we'd have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same, and it comes out to be 91.11.
Also guys, if you're looking for an end-to-end training in Python for data science, Intellipaat provides a Python data science course and training which covers all of the concepts which you need to learn, and also will help in getting you a job. So for more information, check out the description box below or visit intellipaat.com.